What if Earth was a curved plane, as in flat but also a bit curved?
Yeah,
Hello?
it already is. It already is like that, right? Like we've got flat water that covers most of the surface,
Yeah, yeah,
and then we've got curved parts like valleys and mountains and hills and elevation change over the landscape. So yeah,
yeah, yeah.
yeah,
So let's say your
you-
position is that flat, I mean, that Earth is flat. But what if it was flat but also a bit curved? Like flat but curved. How do you then justify your evidence for Earth being flat?
because the surface of the water is not curving, and we're not claiming to know the shape of the Earth overall.
What if I
Flats.
claim Earth is round, globe,
Uh-huh.
but it's curved, but it's also flat?
Well, you can't have a globe that's covered in
I'm not claiming it's a
70%
globe. I'm
water.
claiming it's a curved plane.
Okay, then would the water be curving or would the water be flat?
It would be both, depending where you look from, because it would be Earth would be a plane as not a flat plane, but a curved plane.
Right, but the surface of the water, like let's say we have the Pacific Ocean, is the surface of the water curving or is the surface of the water flat?
I don't know. It depends what evidence I would show. I'm just
Right. So
playing
whenever we
with.
test, right, I
Yeah.
get you. But whenever we test it, we don't find any curvature. So if someone wanted to claim it was curving, then they would need to find some evidence of that happening.
But why don't flat earthers do this then? Like claiming, well, Earth is flat, but it's a curved plane. Why is
Because
your like?
we don't detect any curvature over any large body of water. So we don't have any evidence to make such a claim that it's curving.
But wouldn't that be a strong argument though? Like, okay, well, the Earth is not perfectly flat. It's a bit of a curve, because he would then refute all their arguments. I mean, the arguments
Right.
from the
Not
globe heads.
really. Well, okay. So if we said it's curving a bit, they would say, "Do you have any evidence of it curving a bit?" And then there isn't any evidence of that. So,
Yeah, well, they would have the evidence.
well, they don't have any evidence of that.
Well, I think they do. Well, that's besides the point. I'm just steel
Well,
manning your position because, like,
our
mathematically,
position,
is
we
it?
can, yeah,
Yeah.
mathematically, you can do whatever you want. But if we test that mathematics against the real world, then we don't find any curvature.
But do flat earthers believe that it is perfectly flat?
No.
Then it would be a small curvature or
Well,
uneven
perfectly
flatly.
flat. Well, name one thing that's perfectly flat.
I can't, because nothing is truly perfectly flat by nature.
Right. So then we need to add some context in. So what we say is that in this context, the surface of the water is not curving over distance as it would have to do if the Earth was a globe. And we don't like so if there's no curvature over distance, right? So no change in height over large distances. Obviously, you could have a lake, right? And some
But
days there's
locally,
wind and there's waves. Well, some days there's wind and there's waves on the lake, so it's not very
yeah.
flat. There's waves, but it's not still not curving over distance. It's still
So
flat
what
overall.
if a local small curvature, but not entirely, like Earth is not fully curvy, a curved plane, but maybe locally by miles.
Well, you know that if that requires the water to be curving, then we would need evidence of that.
Yeah, so Earth is not perfectly flat. It could locally
No,
be curved.
no. I mean, yeah, like if you're talking about the land,
or
we're talking about the water, the surface of the water. It could locally be curved. You can have a wave, obviously.
yeah.
You can have we have tides, and you can have like water flowing, and then it's like a hump over the section where it's flowing over, like when water goes down a river and it goes over the rocks and it makes humps. So there's all different situations, but there's no curvature as would be required if the earth was a globe.
So flat Earth positions that you go is from the water, but the
Yeah,
terrain is not the water.
that's correct.
But what about underneath the water?
Yeah, it's bumpy. There's all sorts of different changes in the landscape. So you have hills and valleys and mountains, and um, all sorts of things like that. So it's not perfectly flat, but it's also not curving over the surface of the water, and the water covers most of the known area of the earth. So it can't be a
Yeah,
globe.
yeah.
Hey, you there, Yoda?
Hey, I wanted to throw a subject out to kind of test the water, see what everyone's thoughts are. Um, I've been reading a lot about it today. Uh, is anyone here familiar with the Minos neutrino underground experiment by Fermilab?
I am familiar with some neutrino experiments, but I don't know if it's this one.
It's when they used a beam of neutrinos and they fired it from uh, Fermilab to um, an underground detector 732 kilometers away. And they angled the beam downward at 3 degrees. And at the detector, the neutrinos were detected to be emerging from the ground, going upward at positive 3 degrees, like 3.5 or something.
Right, so I know where you're going with that. It's similar to an argument I used to use when I was a Glober. There are neutrino measurements from the neutrinos that originate from the sun. The sun produces a shitload of neutrinos. It's a scientific term. And they come from inside of the Earth at night. Right, so the globe argument would be, oh, the sun is on the other side of the sphere. That's why the stream of neutrinos come from the inside of the Earth, and then as the sun moves or the Earth rotates, whichever version of the imaginary heliocentric model you want to use, then that beam shifts accordingly. So you're just presenting another version that, like, okay, humans shot neutrinos into the Earth, and other humans received it in another location, right, from inside of the Earth. That's what you're saying.
Yeah, and it sounds like both of those experiments are very strong evidence that we live on some sort of concave surface.
Again, what do neutrinos have to do with the shape of the Earth?
Well, when you shoot them down into the Earth, they come back up somewhere else. That's not explainable unless you have some kind of
Or
proof.
maybe you shoot them into the Earth and they bounce off something and come up.
Oh, okay, can you provide any experimental evidence of neutrinos
No, can you
bouncing off
provide the
rocks?
experiment that they're not bouncing off?
Yeah, because that's not how neutrinos behave. We have no
Yeah, well,
observations
the
of neutrinos
largest
behaving that
hole
way.
we ever dug was 8 miles, so you don't know what's below 8 miles.
But it wasn't going 8 miles.
Maybe it's a neutrino reflector.
The mine was 700 meters below the surface, and you can calculate what the minimum like height would be. But basically, like yeah, you're basically saying that
Yeah, why don't you do all these calculations to prove the globe?
so neutrinos don't refract through matter the way light rays refract through
You don't know.
atmosphere.
You don't know that. Maybe there's unknown matter inside of the Earth that does refract them.
Yeah, so you're invoking some uh, unobserved mechanism that you have no
Well, in
evidence
your
for.
model, 90 or something percent of mass energy content of the universe is of unknown character.
No, it's through the Higgs mechanism. Like that's very well understood.
No, listen to the words. See, you're new to this, and you don't know the globe model very well. 90 something percent of all the mass slash energy, because mass and energy is equivalent in your model, in this universe is of unknown type, meaning it's not explained in the standard model of particle physics.
No,
It's not
the
in.
majority of like for example
You're
like
not listening. Like, just Google it.
no,
90
I know what you're
something
talking about. It's
percent
not even.
of the content is not in the standard model of particle physics. It's not a lepton, it's not a boson, it's none of those things. If you look
Yeah,
up
but the
standard model of
heliocentric
particle physics,
model has nothing to do with quantum field
oh my
theory.
God, I'm just saying, if 90% of the universe in your model is not known, it's what it consists of. then me proposing that there could be an unknown material inside of the Earth that does reflect neutrinos doesn't sound that crazy.
Wait, repeat that last part. Something.
If in your own model, lambda CDM,
okay,
in this model of your cosmology, lambda called dark matter.
Oh, you're talking about dark matter. Yeah, well, that's
90%. But just let me finish. I'm repeating this because you asked me to repeat it.
98% of the mass in the universe.
Stop interrupting me. Stop interrupting me. You asked me to repeat this.
To finish.
Yeah. If in lambda CDM, 90% of the content of the universe is not known, meaning it's not covered by the standard model of particle physics, then this is an analogy. Then me proposing that inside of the Earth there could be some yet undiscovered material that has the property of reflecting neutrinos doesn't make me sound like an idiot, right? Because I'm invoking the same paradigm. You people invoke this paradigm in lambda CDM. You say, oh, galaxies don't move the way we expect them to. There must be some invisible thing of unknown property that is causing that. I'm invoking the same for neutrinos. So?
Well, lambda CDM model,
Peter, especially
theory,
in their model, how they
I'm responding to what he said right now. I'm responding to what he said. I can't respond to two things at once.
Bro,
the lambda
you heard me try to get in earlier, but go ahead.
The lambda CDM model and quantum field theory are two separate things. And
I understand.
Yeah, and so
but they're not. But they're not. Because lambda
they
CDM
are two separate
says,
things.
No, lambda CDM says the universe consists of matter and energy, all of which is covered by standard model of particle physics, photons, neutrinos, electrons, protons, not protons, quarks, antimatter, all that stuff. And it says there's also a very large amount, I forgot the number, but 90-something%, that is dark matter and dark energy, which is not included in the standard model of particle physics. We have no idea what it is. That is admitted openly. I have as a Glober, I didn't have a problem with that. I was like, okay, we don't know what it is.
Yeah, neither do I. And I'm not talking about
good. It's an analogy. I know. Understanding analogies requires an IQ of like probably 95 plus. So listen
what you're
to this analogy.
What you're saying is that, okay, if we live on a flat Earth, we see the beam goes down and it comes back up. So there must be some reflection or curving happening inside the Earth.
Absolutely. Yes.
Okay, that's where you're at right there. And
then you say,
to bridge the gap. To bridge the gap, you're invoking dark matter / dark energy.
No, I'm not. See, this is why your IQ is 93 maybe instead of 95. What I'm saying is,
so you're saying
you dunked on me and you said, oh, you cannot invoke that possibility because we know that neutrinos don't interact with anything. Well, now I invoke a yet undiscovered type of matter that does interact with neutrinos. How about that?
Okay, can you provide any sort of experimental
evidence
that such matter exists?
I can, and it will be analogous to lambda CDM invoking dark matter, and listen to it. Here it is. The Earth is measurably flat. If you shoot neutrinos into the Earth, there's no way they can come out on the other side from the Earth. Therefore, I know that there's some substance down below that reflects them. This is analogous.
Making the question, though.
No, this is well. Then
you're presupposing the shape of the Earth and then invoking some imaginary.
Then I'm sorry. Then lambda.
That's exactly what you guys accuse Globers of doing with refraction.
Well, I'm sorry. Call me stupid, but I am at least at the level of the scientists that embrace lambda CDM. So I'm very humble. I don't aspire to be better than them.
Your whole argument is that, well, in order for these neutrinos to curve, it would require some heretofore unknown type of matter.
Which is exactly what lambda CDM does.
No, and then you're saying, and I'm justified in claiming that
do you hear what I'm saying? Yes, I admitted that.
Gets it.
No. Okay, let me finish. Goddamn. You're saying I'm justified in claiming that this undiscovered matter exists because some other scientist in some other field did something that I perceive to be similar.
No. I'm sorry.
yeah,
I'm sorry.
and lambda
I'm
CDM
sorry.
is
I
not.
stand
It's not just like.
corrected. I
It's
stand
not the
corrected.
cosmology of the gaps. We have like
Yes, it
we can
is.
observe the effects of dark matter and
I
dark
stand
energy.
corrected. You're absolutely right. I invoke a substance that reflects neutrinos because I need to confirm what is observed, the Earth being flat. Now, period.
But the
I
Earth
put a
being
period.
flat or round is the conclusion. You can't presuppose
No, we know
that,
it
and
from
it
other
starts doing
things.
reasoning.
No,
It's exactly what you
it's
accuse
not.
Globers
No,
of.
it's not.
Yeah.
No, it's not. Can I
You
make
have
an
to challenge
analogy
a
that
monster
maybe
which
you would?
you hated.
Would you be able to think through an analogy?
Yeah, your analogy is flawed because we actually have
Okay.
observational evidence of
Well,
the effects
let me try another
of
analogy.
dark energy and dark matter.
Yeah, okay. So there used to be a cosmology called general relativity, period.
Used to be. General relativity is not.
Yes.
What are you talking about? It's still.
Lambda CDM is a modification of it in two ways. One, it has a lambda, which Einstein set to 0. It has a non-zero lambda, and it has CDM. That's why we call it lambda CDM. It's an evolution of general relativity,
Yeah,
not
dude,
the pure.
science isn't a religion. We don't
Can
have
somebody
Saint
mute this guy?
Einstein and Saint
Can
Darwin
somebody
and
mute
whatever
this
they
guy
said is
for
so
3
perfect.
minutes? 3 minutes is all I need. So when people made more careful observations, I'm explaining your model here. They realized that what they call galaxies, they're spinning in ways that should result in them breaking apart. Yet we don't observe them breaking apart. It was then postulated that the only way to explain what is measured, which is a very specific motion of those things, is the presence of otherwise unknown type of matter that would create additional gravity to hold them all together. So people used exactly the same reasoning that I presented. It's an analogy. I know it's very hard because you have to think about two things in parallel, which I don't think you can do. They went like, we observed them moving this way. Our calculations do not agree with that. If we introduce this unknown thing, if we postulate it, then calculations do agree with what we observe. Lambda CDM. Now, I am doing the same. We observe and measure the Earth to be flat. We supposedly observe neutrinos be shot into the Earth and come out on the other side from inside of the Earth. How do we make it work? We invoke the presence of an unknown substance that reflected neutrinos. It's a working model, the same way lambda CDM is. That's it.
Hey, quick question, Peter. Probably for both of you. If you're shooting neutrinos, how do you know it's the exact one that you've shot out that's come back into the receiver? So neutrino number 472, you've shot him out. He's on his merry way, and then number 472 hits the receiver. How do you know it's not
Because
just something
you
else?
can manipulate. You can make them look special.
Yeah, that's great. But how do you know it's the ones that you've shot out are actually being received?
The same way when you laser paint a target, the bomb knows that this is the laser you shot and not a laser that Sergei shot.
That's
Okay?
what I want to know. How do they know that?
It's in the paper. These things are explained in these papers. That's the crux of the whole experiment, how to make it work this way.
So he hasn't presented the paper yet. So maybe he should present that so we could see how these things are detected.
Of course he
That'd
can.
be
I've
cool.
seen those papers and I remember reading that, and it has all the nauseating detail about how they generated the neutrinos, yada 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 yada. But yes, I'm not questioning the experiment. I'm questioning the conclusion from it.
You finished? We can unlock him now so he can bore us to death.
Yeah,
with,
absolutely. I know what he's going to say. He's going to go in the
his
loop.
Blitz fanboy crap.
Matrix, the answer to your question is simple correlation. When the emitter is not turned on, you detect background, basically mostly coming straight down, or just random directions. And then when the detector is turned on, you see over 10-fold increase in the neutrino flux at the detector, which correlates when you turn it off, the flux goes down. When you turn it on, the flux goes up. That's pretty conclusive evidence that the neutrinos being generated are the ones being detected.
How do
Yeah,
they detect them?
and those fuckers, they they travel nearly with the speed of light, right? So it's nearly instantaneous on
The speed of light is
the
not
scales
instantaneous;
we're
it is
talking.
finite.
I said nearly in time, you moron. Like, given the relatively short distances,
Right.
you can ask the guy, "Hey, I flipped the switch on. Hey, I see the neutrinos. A fraction of a second later."
Yeah, timing is like a thing. Yeah. This is a somebody just posted a thing from the paper. Great, cool.
Now prove that it relates to the shape of the Earth.
Well, I mean, I explained it, right? So, okay,
Yeah, and I explained it as well.
Well, no. Okay,
Yeah, how
so
do you know
basically,
Peter's
You both
explanation
affirmed
wrong?
consequent.
Yeah.
You
so
said
first of
assuming that
all,
the Earth is a
first of all,
sphere, it makes sense. I said assuming that the
no.
Earth is flat, and no, knowing the Earth is flat and assuming there's a substance inside of it, it also makes sense.
So first of all, this experiment was not devised to prove or demonstrate whether or not the Earth was curved or not. It was just to analyze something about the phase of the neutrinos as they're changing. And it's as of no, it's like, okay, yeah, so on this end we pointed it down at 3 degrees, and then at the detector we have to point orient the receiver because the trajectory of the beam is coming out at this angle, right? And it was like a footnote.
Perfect.
Yeah, you didn't answer
Perfect.
Peter's
I love
question.
it. I love it.
But do you
You love
understand
it.
why
Okay.
they
So
did that?
that doesn't prove anything for anybody. What are you talking about?
Yeah,
Yeah.
the dudes
And so
did an
basically,
experiment about neutrinos. They
yeah,
shot
so
some neutrinos, they received them, they measured some shifts, whatever the detail in the paper is. Congratulations.
yeah, and so
How
I
does
mean
it
the
prove the Earth's a
height.
globe?
Well, yeah. So let me see if I can do it.
I can answer that.
Yeah. So there's some height, some minimum height that the beam went through, right? And you can calculate that just based off of the geometry of the sphere and all that. So basically what you're saying is between the surface of the Earth and 700 meters down, there is some unknown layer, or under it, actually. Yeah. It's
So,
so you're
how deep, like percentage-wise, from the radius of the claimed radius of the Earth, have we dug?
8 miles. 7.6.
No, percentage of the claimed radius.
You're gonna make me calculate the
No, I
percentage what
asked
7
Ken
is of.
I don't know, physically dug down.
I think it's
Or it's
0.19%.
Yeah, but that doesn't mean that we can't
yeah,
probe
it's
the
close.
internal composition of the planet through other methods.
So you know the entire composition of the planet, with like beyond reasonable doubt.
Me personally, I'm not a geologist, so the answer would
Hey,
be
you know
no.
what? I just derived. I just derived the composition of the Earth beyond 8 miles just now. I just derived that it has a layer that reflects neutrinos.
Okay, now prove that it's that
Yeah, dark sea.
No, can you demonstrate that such matter exists?
Yes, I believe there's an experiment where they shot some neutrinos into the Earth and they came out on the other side from inside of the Earth, which would contradict the fact that the Earth is measurably flat. Therefore, I derived there's a layer that reflects neutrinos.
Yeah, because you're
I love it.
presupposing flatness, and then you're bending everything else, and you're
No, we measured the flatness.
and you're invoking imaginary matter in order to make your theory fit.
And we couldn't.
Everything. You're doing everything that flat earthers claim
That's not
globers
true.
do.
Let me
I don't
explain.
think
We measured flatness. We couldn't measure what's inside of the Earth. That I give you. We did not measure that. And therefore, and we did measure the behavior of the neutrinos. I will grant you that paper without looking at it. Therefore, we just derived that there's a neutrino reflecting layer inside.
Yeah, the Black Mirror Earth. Black Mirror Earth layer.
I don't
Yeah.
think he gets what you're doing, Peter.
Yeah, he's
All right, I have to pause it for a second because we got to listen to that a little bit one more time. So basically, Quantum, whatever his name is, Peter just forced him to shit all over his own globe claims, basically. Try to guess where to rewind it.
layer that reflects neutrinos.
Yeah, because you're
I love it.
presupposing flatness, and then you're bending everything else, and you're
No, we
invoking,
measured the
and
flatness.
you're invoking imaginary
No, we
matter
measured the
in order to make your
flatness layer that reflects neutrinos.
Yeah, because you're
I love it.
presupposing flatness, and then you're bending everything else, and you're
No, we
invoking,
measured the
and
flatness.
you're invoking imaginary
No, we
matter
measured the
in order to make your
flatness,
theory fit.
and
You're
we
doing
couldn't.
everything. You're doing.
We measured flatness. We couldn't measure what's inside of the Earth. That I give you. We did not measure that, and therefore, and we did measure the behavior of the neutrinos. I will grant you that paper without looking at it. Therefore, we just derived that there's a neutrino reflecting layer inside.
Yeah, the Black Mirror Earth. Black Mirror Earth layer.
I don't
Yeah.
think he gets what you're doing, Peter.
Yeah, he's creating his own fantasy world where he can
No.
rewrite the rules.
He really
Yeah.
doesn't get it.
He's
No, I
doing
get it. I
exactly
get
what you're doing.
Okay, so what does that mean? Does that mean that both of us are right or both of us are wrong?
But because of what the neutrinos are doing, you're coming to a conclusion. He's doing exactly the same thing as you're doing.
Well, I would say based on
You're both wrong.
no, based
Good,
on
I'll help
Both
you.
affirming the
You didn't
consequence.
measure
it's not affirming the
curvature.
consequence.
You didn't measure curvature, so you're using your understanding of neutrinos and an assumption that you know what's inside of the Earth to confirm the curvature or derive it from it that you couldn't measure directly. We're doing the other way around. We measured the flatness directly. We do not know what's inside of the Earth. We actually assume that your understanding of neutrinos is roughly correct and that you can emit them and receive them. We grant you this. And therefore, we derive that there's a neutrino mirror somewhere in the inside of the Earth.
Yeah, it's flat Earth of the gaps.
And it's lambda CDM of the gaps.
Nope.
Yeah,
because we
and
actually have direct observation.
You can't have your cake and eat it
of
too.
There's
Peter-
literally
energy and dark
CDM and lambda are two things that are not covered in the standard model of particle physics. It's
No,
literally
but
in the
neutrinos
name.
are covered by the standard model of particle physics, which would
Yes,
be
they
true
are.
even on your flat Earth. Okay,
I
let me ask you a
know,
question.
but
On your flat
but
Earth,
the
does the
mirror
standard
is
model
not
apply?
included.
But Peter's
On your
got
flat
one
Earth,
more.
does the standard model apply?
But Peter's
The
got
Yes, it
one
does.
more thing. Sorry, Peter's got one more thing than you've got, right? He's got a measurement of a flat surface. You don't have a measurement of a curved surface.
Does
So
Peter
at the
have a
moment,
measurement
his
of
is
a
more
curved
correct.
neutron beam?
What are you talking about, dude?
Does Peter have a measurement of a curved neutron beam? Because you need to establish that
Yeah, I
it's
do. You just
plausible
gave me one.
in order to present it as an explanation.
Yes, you just presented one.
He doesn't need to show they're curved.
Do you understand that
Reflective.
this is derived in a very analogous way
How
to
do you
how
bend the
dark
neutron
matter
beam?
is
Tell me.
derived?
How do you
He's not bending them.
How do you make extra gravity where there is no mass?
How do you make extra gravity where there is no mass?
Hey,
Yeah,
you
you
want
add
some?
dark matter. You add dark matter. You
Hey,
postulate
guys.
dark matter.
Check this out, Peter. Check this out. Hey, Wansome, if you go and get a CAD program and draw where these supposed neutrinos are going from, so an angle of 3 degrees below the surface, if 3 degrees is the actual number, then your little receiver should be, 135 miles away? I think it was. No, 218.3434 miles away.
Yeah, so it's
Is that where the
700
receiver was?
So the receiver is 700 meters below the ground and 732 kilometers away. So
Well, it's not going to hit then.
I calculated it. Yeah,
CAD draw it out. Go and CAD draw the angles out and see where it is.
I know trigonometry, so I can tell you that.
Yeah, that's right. Go and CAD draw the fucking thing out and look where it hits.
I don't own CAD.
I use a free version, LibreCAD. Go and
Why
download it.
Listen, so these
Draw
are
it out.
right?
Go and draw it out. You
I'm
will
drawing
understand
it on a
after
piece
you
of
see
paper
it.
right now. It's
Yeah, that's great.
732 kilometers. That's the horizontal distance, and the vertical distance is 700 meters. Okay, that would correspond to about 0.05 degrees pointing down on a flat Earth.
So at 1 degree, if we shoot something down across, which is just off of horizontal, it's only going to be 87 kilometers away.
Yeah, that's right. That's what I'm saying.
You need 700. You're a tad bit short, son.
My whole point is that the measured angle.
Your whole point is you're making a claim that neutrinos are landing in a very, very particular spot based on a very accurate angle. I'm showing you your angle and/or your distance is incorrect.
If you try to draw it out on a flat Earth, it doesn't work. It only works on a compass.
I'm not drawing it on a flat Earth. I've got it on a fucking great big sphere with a 39, 59 mile radius. That's why I said draw it out, and you'll see what's happening. Your numbers don't match up. They shoot this beam. There will also be a deviation. They don't shoot perfectly. They will have a spread.
Yeah.
Excellent. So what's the upper and lower limits of this spread?
It said that the central axis of the beam had this orientation. So regardless of the spread.
Plus or minus what?
Plus or minus what?
That's what I want to know.
Plus or minus irrelevant because they're talking about the central axis. So whatever.
So if you're off axis, they're not going to hit. So you have a problem. You're claiming they're hitting. I've got no problem with that as a claim. So that means these things have got to be accurate. If they're not, you're not hitting. The math ain't mathing, son.
Do you think I made this up or
I don't give a shit. To me, I'll tell you what I think. I think you're a Blitz fanboy and you thought you'd come in here and lay down this cool shit. You're lucky Indio's not in here. He'd rip your asshole a new one.
Dude, Indio's a fucking joke. I call him Indica Indio because he puts people to sleep and he makes you.
Indio owns you, bro. You're just a hurt little boy. You've come in here making claims. I've pointed out your mathematics is incorrect, and now you are coping.
Yeah, go run away to Indica Indio, bro. He's gonna put everyone to
So you've got nothing. Have a nice day, kid.
Well, I'll give him 1 point. Indio does tend to speak for a very long time.
Yeah, it always ends up being about flat earthers, never flat earth.
That was actually quite funny, Peter.
How's about that Aries failure?
And it wasn't a claim, it was a measurement.
Yeah.
What are we talking about today, fellas?
Hello. Hello? Why is everyone else muted?
What's going on in here? Good day to everyone.
What's up, Jemsy?
Hey, Joder.
Got a guy in the chat who seems to be hung up on math and math only.
Math only.
Yeah, he did math. He performed trigonometry to determine the angle of dip through the chord of the earth, and says because he could perform this mathematical operation, then Earth has to be a globe.
Whoa.
Now, it's within the context of neutrino emission and detection. So I'm like, all right, convince me that this is actually possible. What's a neutrino? And he seems to be doing everything he can to begin with that. Before we can even get into like how does neutrino emission work and how are neutrinos even detected, I just want him to describe what a neutrino is. He's doing everything he can to avoid having this part of the conversation.
And remember, there's trillions of neutrinos passing through your body every second, but they can detect specific neutrinos.
Some.
He's sitting in VC right now. Won't open the mic.
Come on, bro. Help me out. I want to buy some neutrinos. The trillions of them passing through. I mean, should be fairly cheap. Actually, yeah, just tell us. I mean, he got the math already. Where are you getting the math from? Like, can you show?
He could probably MS Paint some of it.
Yeah.
Here, let me one up him a bit. I'm going to present his own math. Look, you can draw shit.
Are you actually there?
Oh, I'm actually here. Yes, I am actually here. Well.
Yeah. What's a neutrino?
Doctor.
What's a neutrino?
It's a particle.
A particle. That doesn't tell me anything. What's a neutrino?
Particle. Somebody asked me what light is. I'm going to say a photon. They're like, that doesn't tell
No,
me
I'm
what
asking
light
you what a
is.
neutrino is, dumb fuck. Come on, what's a neutrino?
What is math?
All right, so you're bricked. Got it.
I have the same question. What is that? A neutrino? What's that? Sir?
Neutrino?
Yeah, what is that?
I told you. It is a particle. Like, do you want, like, what do you want me to say? Like, it's like ask me what light is. I say photon. You're like, well, what is that? It's a photon. Why are you getting so hostile, man?
Hostile? I'm being hostile.
Doctor is.
I'm being peaceful.
Are you mad that like people can actually do math?
Mad?
No, I'm
Because
just
math?
upset at dishonesty because I don't think you have any idea what you're talking about.
They were talking about like the experiment, or like they were talking about this experiment that happened in Illinois and like Minnesota.
All right, what's a neutrino? How was it discovered or invented?
Well, I don't know how it was discovered, but I do know that it's a particle.
How do you know it's a particle?
Because that's what we call them.
So you have no idea what this is. Classic dodge. Classic dodge.
Dodgy, dodgy.
What will be an example of a neutrino in the physical and natural world? Right here, neutrino.
It could be like an electron, or like that could be it.
An electron is a
Like
neutrino?
an electron.
Well, they pair with like electrons.
They pair with. Excuse me, what?
Yep. Did you not know that?
They neutrinos pair with. That's what the audience heard.
You never heard of an
Yeah,
electron
can you repeat
neutrino?
yourself? They pair with what? Can you say that again?
I said it's an electron neutrino.
Oh yeah, what makes it an electron?
What makes it that way? Well, it would have like no electric charge, right?
Oh wait, I thought neutrons had no charge.
Not the electric neutrino.
Oh, it's electrical?
Mm,
But it's electrically neutral, but it's electrical. Yeah, go figure. It's electrically neutral. That's why I call it a neutrino. Duh. Now you're telling me it's electrical. How do you know it's electrical when it's electrically neutral?
I'm just a pilot.
Yeah, you're a pilot. Okay, so you're talking out of your ass. You
But I
could
do
just
know how
say, I
efficient
don't
it
know,
is.
and be honest about this topic.
Hmm?
I mean, have those words ever passed through your lips before? I don't
Bro,
know.
he heard you saying you could be honest, and he's like, huh? That doesn't compute or something?
Well, he's a pilot, so.
Yes.
I mean,
Yeah,
but
that means you're at the
how can
top
you
of the food
say
chain, right?
how can you say when someone is asking you, can you be honest? You're supposed to say, yeah, I could be honest if I wanted to. Or you could say, no, I cannot be honest at any
Well, it's
point.
kind of like a weird conversation.
Yeah, it is weird. I mean, you came in here describing a neutrino event, and you don't
You're
even
trying
know
to
what
tell
these
me
things
some
are.
things don't exist, okay? It's not a wordy conversation. It's like telling
No,
me
no,
gravity
I did
doesn't
not tell
exist.
you they don't exist. I asked you to convince me that they exist because I want to see how much you know about it, Mr. Knowledge.
Of course they exist. They interact with gravity, right? They are like in like the weak nuclear like force,
They
right?
interact
Of
with
course they do.
gravity? How do they interact with
Right.
gravity?
How do you think?
I'm asking you, bro. This is your topic.
You tell me.
You told me they interact with gravity. I'm like, oh, cool story. Tell me how that works. I'm very curious. Tell me all about neutrinos. Go ahead.
Well, do you think that gravity affects mass?
Okay, so dodge the topic.
You were supposed to tell him how Is that is the case? Not asking him a question.
Yeah, you told me they're electric, and there's like actually no electromagnetic interaction at all with neutrinos, which is freaking hilarious. Now you're telling me
Well,
that they interact with gravity, and I'm like, okay, great. So how much mass do they have?
they actually have the least amount of mass out of all the others.
Oh yeah, how do they know that? How do they? In what units do they detect mass of neutrinos?
I don't know that.
Oh, okay, good. Some honesty here. It's electron volts. Please tell me more about neutrinos.
Please tell me more about your flat earther.
Well, I can tell you as a pilot, you've actually never seen curvature of the Earth before.
Is that true? Why do you think that like my horizon like drifts the further I climb? Why do you think that is?
Because you have a wider viewing angle of the surface from higher up.
That wouldn't be true on a flat Earth. You know that, right?
No, that is absolutely true. You can demonstrate this on something as small as a chessboard. If you view
reason
a
why
chessboard at a very oblique angle, you won't see the edge of it. But as you
There's-
raise yourself higher than the pieces, then you can see the edge of the chessboard.
So you're saying on the flat Earth model, like what's obscuring my vision? Like then, like why? How's that explained on your model? Right.
I don't know. It depends what you're talking about. Obscuring your vision, like what do you mean obscuring your vision?
Yeah, human vision is very limited.
So
Vision of what? Vision of what?
what I'm saying to you, like, would it be any difference if I'm on the ground or I'm up in the air? Like, if can I see past the horizon on the ground?
What horizon? What are you calling a horizon?
What do you think horizon means?
I know it's an optical phenomenon that's, due to your environmental factors and your limitations of vision.
It's it's a what?
Yeah, it's an optical phenomenon. It's where your mind draws a line that separates the sky from the earth.
So what's obscuring my vision at the horizon?
A combination of factors. You want me to repeat myself? Environmental as well as limitations to your biology and your own perception.
Which you said the higher I go, I can like see further. Why is that? Why do you think that is?
I already told you why, because you widen the angle of view to the surface that you're viewing.
Is it because I'm going above the curvature of the Earth at that point, and that I can see past the
What
horizon
curvature? What curvature? What are you talking about?
What
Where does curvature
my
factor into
vision?
the horizon?
So, because the horizon is what is skewering my vision, that curvature. Okay, when you say I go up, okay, what I'm doing is I'm going over the curvature at that point, which is the horizon, which allows me to see past it. Okay, that's not true if I don't go above it, right? That's the reason on the flat Earth model, like there's no such thing as your vision being obscured at the like you would be able to see distances both no matter where you were. Like if you were 10,000 feet up in the air or at ground level, there would be nothing obscuring your vision.
No, that would be incorrect. That violates physics.
I agree. That's why I don't believe in it. I'm not a flat earther. So you're saying that like if I go above that curvature, like right, which if I climb high enough, right, I can see past the horizon. Yeah, that's true. That's because I'm above the curvature at that point at a certain altitude, right? That which it's no longer obscuring my vision.
You know, they took a picture of Earth, guys.
Horizon doesn't. I mean, the edge of the ball doesn't obscures your vision. It blocks your vision. The obscure part will be maybe weather conditions or medium conditions, or maybe your eyesight conditions. So you're saying something that doesn't make sense.
So like if you're about like 5 feet above like the ground,
Listen,
like,
listen.
like the horizon would be roughly 3
see
miles
if
away.
you
Like right, if you're standing at like 10,000 feet, the horizon's about like 126 miles. Like right.
On a globe, yeah, that should be the case, right? Yep. So
Yeah.
let's say we have a lake, right? Beautiful clear day, clean conditions, no wind. We set up a camera at 5 foot height, just above the surface of the water. Horizon should be about 2.7 miles away on a globe. And any water that's beyond that 2.7 mile horizon should be physically obstructed and not able to be seen, right? Knowledge? Acknowledge?
What's that? Smoking.
It's terrible for your health.
Yeah, I gotta get me
You're
through
good.
this.
I'm just joking. All right. Did you hear what I said though?
Nope.
Okay. Right. So if we go to a beautiful lake, right? There's no wind, nice clear conditions. We set up a camera 5 foot above the surface of the water. The horizon should be about 2.7 miles away. 2.73 if you want to be precise. Let's just say 2.7.
Yeah.
All right. So any water beyond that 2.7 mile horizon should become physically obstructed behind the curvature of the earth.
Well, like
Do
like if like ships were like sailing away over like that distance or whatever, like they would never like appear to sink from like the bottom up, right? They would be fully visible, right?
No,
You
on a
understand?
globe. I'm talking about a globe. On a globe.
But what we see at those distances that it's the bottom up though on the globe.
Yeah, right. So exactly, right. So that's, you agree with what I said then.
That's not what we see in your model. Though. That's not what we see in reality.
No, it's not ever.
They don't remain fully visible. They sink from the bottom up in reality when you go see it, right?
Okay, I'm trying to get you to agree with me. I'm talking about your model. I'm talking about the globe. Because that's what we're going to test.
It's not
okay,
my model.
No, the globe model. Not you. You're not. It's not your model. It's just the globe. Right?
You mean everybody's model?
It's not everybody's model. It's just if the Earth's a globe with a radius of
99% of the population.
No, it's not that, right? But when they do surveys, right, it's actually completely different than that. So that number that you said is incorrect compared to the surveys. But we don't need to worry about that. Let's just stick with the test, right? So if we have a lake and we have nice conditions and we set up the camera at 5 foot height, the horizon should be about 2.7 miles away on a globe. Do you agree?
Did you say 5 feet?
Yeah, 5 feet above the surface of the water. That would mean that the horizon should be 2.7 miles away, approximately.
Have you guys broke off a piece of the firmament?
No. We don't just jump in and say yo and interrupt conversations. I'm having a nice friendly conversation with my friend Knowledge right here. Right, so do you agree? Do you agree, Knowledge, that the horizon would be 2.7 miles away approximately if you set up a camera at 5 feet high above the surface of this beautiful, calm, clear lake? Nice day. shiny water.
Yes, yes, sure.
Yeah, you can agree with me. If the Earth's a globe,
Yes.
right? And then, right, let's say we had the Titanic, right? It's about 175 feet tall, approximately, something like that. Right. So let's say the Titanic was docked right next to the camera, and now the Titanic is going to sail away to the other end of the lake. Let's say the other side of the lake's about 20 miles away. Okay. Now, once the Titanic sails away from the camera, it's going to get out to where I can see the horizon line at about 2.7 miles. As it starts to go beyond the horizon line, the bottom of the Titanic will start to become obstructed behind the curvature of the Earth. Once it gets to 10 miles, the bottom 66 feet. Oh, sorry, we got to take the observer height into account.
Are you taking refraction into account?
I'm talking about just the physical obstruction at this point.
Okay, but the distance changes when you take refraction into account. Like, right? So even if you do say it's 2.7,
so right now we're just
it's not actually 2.7, is it? No, it's not.
We're talking about no, listen. Right. So right now we're just making sure we can both agree on the geometric features, right? Independent of the atmospheric conditions. Just so we can agree on what should physically be obstructed. Notice I said physically?
Yeah.
Yeah, physically obstructed. So the bottom 46 feet of the boat should be physically obstructed. Or probably even, well, I could check the exact math, right? But let's say by the time the boat gets to the other side of the lake, 20 miles away, should be completely hidden behind the curvature of the Earth. Just physically obstructed behind the curvature of the Earth, because there's 266 feet of raw curvature over 20 miles on a globe. Right, that's what should happen. Okay, now tell me what you know about refraction.
Well, it's because the air is denser near like the surface of the Earth, right? It's like a giant lens, right? And like the light rays like downwards towards the ground, right? So like when you take like the curvature into effect, right? Like those distant objects and like in the horizon, like they'll appear like slightly higher and closer, like to your like what you see.
Not quite, right? So temperature, pressure, and humidity is what's going to be. Hold on.
The air is denser near.
Hold on. I let you finish. Even though what you said was incorrect, I let you finish so I could.
It's not incorrect.
Then talk. Oh yeah, it is actually incorrect because you're just taking the atmospheric pressure into account, right? And that's higher as you get lower on a broad scale, right? It gets thinner as you go up in altitude, right? Now, that's not what controls the refractive index in the lower troposphere. It's the temperature that's the primary controlling factor of the refractive index. Of course, we're talking about optical density. Okay? Now, you can look this up any way you like. Temperature is going to be the primary controlling factor. That's why we have atmospheric refraction, right? It doesn't necessarily bend downward, right? It can bend upward. We have opposite effects. So you should be able to agree with me that light will just bend towards the higher refractive index, right? Kind of like in Snell's law or in the differential equation of Snell's law, if we're talking about a gradient medium. Wherever the gradient has a higher refractive index, which is the optical density, the light's going to deviate towards that. Do you agree?
I guess, yeah.
Yeah. So it could bend up, it could bend down, it could not bend at all if you have like a neutral density gradient, which is pretty rare. But temperature is going to be the main thing that controls the density of the air lower to the ground.
Well,
Well,
like I understand what you're saying. Like just like normal refraction, what you're saying. Like instead of like the 2.7, it would be like roughly 3. Like so when the cold air, like what you're kind of like when it sits directly over like cold water over like a warm layer of air, like that can make like dozens of miles. Like you can see past like the horizon, right? like what you're saying. I mean, I get what you're saying. I don't.
Okay. Look. So look. This is what they claim
I don't
in
disagree
the
with
in
you.
the in the if the surveyors, right? So surveyors just kind of guess the refraction. So they just take standard refraction into account. They just assume it's bending downward a little bit, and like you said, instead of the horizon being at 2.7 miles, it would be at 3 miles. Let's say, like 15% is approximately the 0.13 refraction coefficient that they use, right? So it's like 15%. So yeah, it's 2.73 miles plus 15%, even though that's just a guess, but let's just go with that.
It's
Okay, so
actually
let's just say 3 miles, including
it's not 15.
it is 15. It's a 0.13 refraction coefficient.
For normal.
So you could
for normal, like
this is just normal. Like, so once we get into normal, like this is the problem. There's papers saying how ridiculous just having a standard refraction is.
show me the paper.
Because if we get into what's normal, if we get into what's actually normal, the lapse rate actually decreases in temperature with height. So the normal wouldn't even be light bending downward when we're looking through a very small gap in this atmospheric density gradient that decreases with height, because it hardly decreases at all over this tiny little 5-foot window we're looking through. So that's why they say temperature is the primary factor that you need to take into account. So temperature actually decreases with height. That's the normal lapse rate. So if we're talking about the normal, then it wouldn't be downward bending light. But I can grant you that because we got lots of wiggle room when we go and do observations. So let's say the horizon should be around 3 miles with refraction taken into account. Because let's say we have a beautiful clear day and there's no sign of any miraging effects or like crazy atmospheric refraction. It's just a nice clear day. Everything looks pretty normal. We have pretty neutral temperatures with the water and the air, that kind of thing. So let's just grant you the refraction, standard refraction. Horizon should be around 3 miles, right? So when we actually go and test this, it doesn't do that, right? We can see the whole way across this 20-mile lake, and there's no horizon at all present over the whole lake. And then we test it again at nighttime to see if, maybe there was some crazy atmospheric conditions taking place. And once again, we see the whole way across the 20-mile lake at nighttime. And we can see the shoreline on the other side of the lake.
Can you show me in the side chat, like what you're talking about?
Yeah. Okay. Just give me a second. I'll just pull it up. It's actually 21 miles, this observation. I was just saying 20.
I'm just saying, when you say like observation, like I'm not just going to take your word for it.
Of course not. No. Yeah. Trust me, bro. Trust me. Why would I lie?
No, I'm not saying that you're lying. I just want to
No,
know.
I know.
So I
I'm
can
just
follow
joking.
along.
I'm just making small talk.
I would never
I'm
say
trying to
you
pull
were
up
a
the
liar.
observation. All right, so this is all out of a full-length video that's in high definition, but I have taken some clips and some screenshots from the video to save you having to. Yeah, I just took them from the video so I can present it without us having to sit through a long video.
I want to watch the full video.
But okay, if you want to go and watch the full video, you should let me present it first, because the guy in the video doesn't present the actual long distance observation as well, because what they also do is a laser test, and he focuses more on the laser test, where I just consider the laser test like a bit of icing on the cake. So let me explain it, and then I'll post the full video, and then you can watch the full video. I'll just give like a really quick
Are they
presentation.
shot with laser beams? If not, I'll be disappointed.
Are they what laser beam? I'm not talking about laser beams.
Oh.
So I'm just talking about what we can see.
Hey guys, if you don't mind me cutting in, I had a work call, so I had to bug out there. Sorry about that knowledge.
Who said what?
We were talking before about neutrinos, and I had to bug out due to a work call. Because yeah, despite popular belief, We are employed.
I never said otherwise.
Okay, well, there's a popular trope out there that apparently we're a bunch of booger picking retards and are unemployed, and that's not the case.
I'd say the correct word to use is skeptic, but not like right.
Yeah, you're right. Listen, you've been very polite, and I'm sorry for being harsh with you earlier.
Nothing
We
wrong.
gotta tune down the use of the word like, though. I think it'd be better if we said
The
that
R
a
word.
little bit less.
Yeah, the
All
R
right,
word too. It rolls off the tongue.
let's change it a bit and let's use the word lake a lot. Lake. All right, so let's get back to this lake. All right, I'm going to post just a little clip right now. So pay attention to the side chat. All right, obviously there's going to be a lot more than just this little clip. All right, so this is the camera set up at 5-foot height. The target shoreline is 21 miles away from the camera. Next slide, we have a top-down view with the Google Maps distance marcation tool showing you that's where he's standing at the top of that yellow line there, and he's zooming across 21 miles away to the distant shoreline. Now, he has a buddy over on the distant shoreline, and here's a close-up view of what it looks like. So this is where he's going to be zooming into. Take note of the big white smokestack. Take note of the target, which is the shoreline, the big shoreline. We can see some little streams or puddles on the shoreline as well. All right, now next we have back to the camera side of the lake. This is the camera setup, 5 foot above the surface. And here we have just the basic math, not taking any refraction into account. 5 foot eye height, target distance 21 miles. That means the horizon should be 2.7 miles away, and the shoreline should be hidden by 223 feet. But like you said, we can stretch that horizon out to 3 miles, no problem, by adding in some, standard refraction. As you can see in the video, we have pretty clear conditions. We don't have any crazy refraction going on that day. No miraging effects or anything like that. Now, I'm going to post some still shots from the observations. All right, so once again, we have the close-up of the distant shoreline. And then in the second image directly underneath that, we have the daytime zoom from 21 miles away. All right, you'll notice that we can see the entirety of the smokestack, and we can also see the shoreline on the other side and the bank. And then he did it again at nighttime. Here is the night shots even clearer. So we can see the shoreline. We can see the light reflecting off the little puddles on the shoreline. And we can see the entirety of the smokestack. And zoomed in a bit more, right? So this is the close-up picture of the smokestack again. And here is the 21-mile zoom screenshot from the video, where you can see the shoreline, you can see the bank, and you can see the entirety of the smokestack. Now the shoreline should be hidden behind about 200 feet, 223 feet. Taking the observer height into account, if you want to add the standard refraction, that's fine. Doesn't make much of a difference. Let's say approximately 200 feet. So 20-story building of curvature completely missing. And we don't have any horizon over the entire 21-mile distance either.
Okay.
So this black line, that's approximately where the horizon should be if the Earth's a globe. You can stretch that out to 3 miles if you want. I mean, even if you stretched it out to 10 miles, it's just not there over the entirety of the surface of the lake. Here's another Google Earth screenshot just for fun. So after this, they did do a laser test as well. they set the laser up at 5-foot height. Here's a picture of the laser transit. And his buddy, John, I think his name was on the other side of the lake. And he was able to detect the laser from the other side. Here's the laser being detected. Like I said, the laser part of the test is just like icing on the cake. I prefer the visual observation because it's just easier to follow along with. I mean, we can just see with our own eyes that the horizon's not there and the curvature, like the obstruction's not there that would have to be there if the Earth's a globe. So this is the kind of observations that we have plenty of. Anyone can go and do these themselves, and we have hundreds of these where every single time there's no curvature where the curvature should be there. So the math might work for the globe model and be internally consistent, but when we actually test it in reality, it's not consistent. It's actually the curvature, the math doesn't match reality, and we encourage people not to believe us and just to go out and check for yourself, because it doesn't require any faith, and you can just go and test these things. And when I first heard about this, I thought it was stupid as well. So I went and tested it myself at least 15 times because I lived on a giant lake in Australia, and I was able to test it. So yeah, there's one test out of many.
So 21 miles is 294 feet. Is that right?
Yeah. Approximately.
So like you understand refraction, right?
Yes, very well.
So light rays, like they travel horizontally, right? And they bend towards like downward towards like the Earth, right?
They also go left and right. The same degree is up and down.
If they're
They
bending
talked
downward,
about this earlier, by the way.
Yeah,
Yeah, we went over this. I talked about this with this guy earlier. We already went over this. Yeah, so what's standard refraction? We already extended the horizon. We already accounted for your standard refraction. Even though light doesn't necessarily bend downward all the time, it can bend upward too. Okay, but we just granted you some downward bending refraction because we don't have any miraging effects taking place. We don't see any effects of heavy refraction. Right? So I granted you some downward bending light, which is exactly what surveyors use worldwide, 0.13 refraction coefficient. So that just makes the horizon 3 miles away instead of 2.7. And that makes, instead of 223 foot of hidden height on the shoreline, now it's like 200 foot of hidden height instead of 223. So instead of a 24-story building missing, now it's just 20-story building missing. And if you wanted to claim refraction could cause 294 foot of curved water to just completely flatten out with no miraging effects, with no crazy distortion effects or anything like that, not only during the daytime, but also during the nighttime consistently as well. And in all of these other observations we have that have been done all over the world in completely different weather conditions, I'd say that that's an extraordinary claim, and extraordinary claims require extraordinary amounts of evidence.
If I could pile on, it's not just the vertical displacement that's a problem, but it's the horizontal displacement with respect to the vertical. Because this means that you also have a distance, okay, that you think is curving around a ball. And every point along that ball surface distance has to refract at a different rate of change in order to conspire together to produce a stable and flat image. We're talking trillions of photons taking independent paths that somehow conspire together to go from a curving surface to a flat and stable one. And I think that's a conspiracy theory, dude.
Okay. Did you calculate like the air temperature and pressure when you did this?
No, the question is did you guys do this when you came up with the standard refraction coefficient of 13% that we're correcting for?
Did you calculate it?
Do you even know what you're
No,
saying,
we're
bro?
not taking. Look, we're not making a specific claim here. We're not saying this observation proves the Earth is flat. We're just saying we all experience the Earth as flat, right? But we get taught that we're so small and the Earth's so big that you wouldn't see any curvature. So we're calculating specifically based off your specific claim how much curvature there should be over this distance. Okay, and then we're taking your standard refraction and we're applying it to it.
How would
Okay,
you know
and
that?
all we're
How would you
detecting,
know
That's
all we're
right.
detecting
Refraction's the
is
excuse.
zero.
How would you
Yeah,
know
it's
that
all we're
without
detecting.
calculating the air temperature and pressure? Like in cold air is dense, right? Like warm air is like thinner, right? So
Yeah.
light travels slower in dense air and faster, like in like the thin air, right? So if in
Yeah,
these
so
images, if you're not calculating that, then like it's going to appear distorted. It's and
You
wrong.
keep saying
yeah, so
calculating.
it's
You
not.
probably mean measuring.
So check this, right? So what you've just done is you've made a claim, right? So we're just showing you flat water over 21 miles. Okay, that doesn't align with the globe. Now you're claiming that really there is a physical geometric horizon at 2.73 miles, but there's some amazing refraction effect, right, caused by the refractive index gradient of the air that's able to flatten out that 294 foot of curvature and completely hide the geometric horizon from detection consistently during the daytime and during the nighttime, and just
Right,
make
so
it
the
all look
question is,
flat.
how do you know it's there in the first place? Well, you're the one that has to provide the measurement.
Yeah, you're the one.
No,
Yeah,
I'm not.
because you're the one saying that something is there that nobody can detect.
No, in order for these images to be accurate, you have
Yes, you're
to.
saying the curve is there and nobody can
There is a
detect it.
massive temperature difference when you go to like a
Oh,
great like lake.
really?
Yes.
Really? Okay, there's a massive temperature difference. Great. Okay, I want to
If
see
you don't,
evidence
if
of
you
that.
don't, if you don't calculate it into like the
Calculate
equation,
what? Calculate your
then
fantasy? No, you need to measure something real.
are you saying temperature is not real?
No, you need to measure it. You don't calculate. You've got to measure something. Listen, calculations produce video games. Like, the Superman Flight Simulator is an extreme version of calculation, right? How do you know that this is real? Well,
Because
you got to
because the
measure it in reality as a benchmark. You don't use calculations and models to benchmark claims against. You use reality.
Okay, but density differences bend light differently. Okay, over open water, air forms layers of like different temperatures, right? Light
Yeah.
passing through these like layers, like
Nobody's
bends. That's called
disputing that. So
that's
do you
the
have that?
Did
Good. So we're
he do
expecting
it?
you to provide that.
Did you do it in these images, Mr. Doctor?
Why
Did you
do we need to
calculate that?
produce it? This is your rebuttal.
Because it's not accurate if you didn't do that.
How do you
Well,
know
we're not
that? Okay,
making.
fine. Go ahead and produce an example for us.
He's the one
Yeah,
who
he
posted
he
the
doesn't
picture,
he
buddy.
doesn't seem to understand what's going on here. We're testing your hyperspecific claim, and all we're seeing is flat water. Now, what are you claiming
What
is?
are the
Can you
temperatures?
see?
What are the
Hold on?
temperatures
Listen.
taking at
Can
this
you see? Can you see any?
day?
Can you see any? Listen. Stop.
What's the temperature? Show me the temperature. Don't show
This
me the
is
distance.
no. So you're not getting it. You're not getting it.
I
So
don't
that's
care.
because you're spazzing out right now. Your brain's shutting down and you're going into cog dis mode, right? This is your way of trying to exit the conversation by just
No.
turning it into chaos until you get
You are
muted.
a moron. You don't understand refraction.
Oh, so just attack the person
This
instead of
guy
the
said
argument.
he agreed with
Yeah,
me that
cope
cold and light
harder,
like the
bruh.
density like is different. Like I need to
Listen
know in the images in the
more
diagram.
and talk less.
I
I
don't know
haven't
the
muted you
temperature
yet, but I'm going to start, right? So I'm going to tell you
Go fuck
something right
yourself,
now.
retard.
We're not
You're a
claiming
moron.
this to be
Yeah.
Bro, you
we're-
work for Pelosi. You have no room to call anybody anything at all.
I own a
This is
consulting firm.
hilarious. He just started calling you a retard for no reason.
Yeah, this is right. So this is being streamed on YouTube, and then these get
don't
clipped and they
care.
go all over
I
the
do not
internet and get
care.
hundreds of
You are a
thousands of
moron.
views, and you're not making a good appearance right now.
I don't
I'm
care.
totally
Who
clipping
cares,
this.
dude? We're on fucking Discord in a VC. You act like this
Yep,
is
I'm
something
clipping this.
prestigious. It's not.
I'm clipping this, and I'll show it to future generations.
That's fine.
Yeah, so Twonga, these clips,
If
right? So
you
it's on Discord. Knowledge, shush, hush for a second.
no,
Okay, so this is on Discord now. We don't have a lot of people listening. It's being streamed on 2 YouTube channels where there's also not a lot of people listening. Then people take the clips of these golden moments with Globers, and then they push them all over social media platforms that get huge views on X, on Facebook, on TikTok, and it's not just once or twice. They get spread all over the internet. So maybe in 5 years from now, this conversation will get 1 million views or more. So you can cope
Maybe your
all you
children
like.
will be embarrassed for your sake.
So Twonga, this is what happens when you act like a bitch. Doesn't work out for you. See you in 2 days, my friend. All right, Knowledge. I am trying to explain to you that we're not making a claim here other than testing your claim. And your claim is that there should be 223 foot of hidden height to the distant shoreline, and there should be a geometric horizon at 2.73 miles. Now, you're claiming refraction is making it all look completely flat. Do you have any evidence that that's possible? And now we're going to get crickets. Do we have the cricket sound effect for Knowledge? Yeah, thanks for playing, Knowledge.
I don't want to talk to you. You're an idiot.
Oh, yeah, great rebuttal.
You tried to tell me
Great
that
rebuttal.
you don't
Says the
calculate
guy who
pressure and
willingly
air
joined a Flat
temperature.
Earth Discord channel.
You just told me in order to like know if these images are like accurate or not, you have to know the air temperature and the pressure. You have to calculate.
No,
You
you
haven't told
don't.
it to me. Yes, you do.
No, you don't need to know that. You don't need to know that because there's
Yes,
so
you
this is
do.
what we can do. Yeah, this is what we can do. Okay, we can
The
reverse
horizon.
engineer it. We can reverse engineer it based on globe, right?
Would you
Based on
agree
globe
the
nonsense. So
horizon
listen.
moves every single day? Hey, dumbass, the horizon
Yeah, how
moves
far
every
does it
single
move?
day.
Yeah, how far
Cold
does it
water
move?
and warm air. Light curves deeply around like the Earth, right?
Yeah, how far does the
Okay.
horizon move?
Light bends
How far does the
upward
horizon
into
move?
space.
You just
Okay.
said the horizon moves, so how far does it
Okay.
move?
You tell me.
How far does it move?
You tell me.
Well, according to standard refraction, it just moves by 15%, and then heavy refraction can be about around 30%
If the
or
horizon
40%.
moves every day, the light travels like
Oh,
slower
so,
or faster
so this
depending
means you
on the
can't see the
temperature.
curvature of the Earth, Knowledge. You're telling the whole world that nobody can see the curvature of the Earth.
You said that you can.
No, you said
don't
that
have to
it moves
calculate
around,
that.
so we don't actually see the curvature of the Earth, do we?
Wow.
Like this guy is an idiot. Go back to the other guy.
No, you're telling
Did you
us that you
say this
can't see
guy
the
is an
curvature of
idiot?
the Earth. So how do you know it's curving in the first
I
instance?
don't want to talk to you or the refraction
I
guy.
know, because it's a difficult question that you fail to answer, right? Because you're giving
Who was
us
the guy?
all
Who was the
reasons
guy I
why
was
we see a
talking?
flat Earth.
Who was the guy I was talking to before? The nice guy.
You were talking to me
That
before.
was,
No, I wasn't.
I think, no, that was me. I just changed my name to Refraction Jackson. Yeah, I can also be a prick when you start being dishonest.
I'm not being dishonest.
So you're telling me that it curves so much the Earth looks flat and you can't see the curvature of the Earth. Is that right, Knowledge?
I didn't say anything. I don't know what you're talking about.
Yeah, you told me the horizon moves around all the time, so you shouldn't be able to see the curvature of the Earth, right?
So
I think he needs a lawyer. He needs a lawyer now.
He's
Because
lucky a
before,
lawyer just
when
joined
you
the
were
chat.
talking to me, you were saying that the curvature of the Earth is the horizon. Now you're saying it moves around all the frickin' time.
You are a moron. Be quiet. You literally said that neutrinos don't exist. You're an idiot. Be quiet.
No, I asked you to
No, he
prove that they
didn't.
do
He didn't
exist.
say
That's
that.
a whole different question.
I don't have to prove anything to you, dude.
Wow.
What was your
He didn't
claim?
say. He didn't
Yo,
say
your
they didn't
voice,
exist.
your voice is audibly trembling right now, Knowledge.
No, because this is a stupid
You're fucking terrified.
conversation. No, you
The
are.
burden of proof is squarely upon your shoulders.
You better take some more bong hits to deal with this cope session,
Tell
Knowledge.
me that in order your images that you've taken, right? You told me that I don't have to calculate the air temperature, rather it's cold or warm air over these lakes. Yes, you do.
No,
Oh, so
you
that's why it
do.
looks so flat all the time,
No,
knowledge? That's why it looks flat?
what's happening here is that if you do, your images are going to be wrong. That's the reason why you can't say
No,
that.
that's why it looks so flat, right, knowledge? Why don't you just say that's why it
Hold
looks
on.
flat? Can you tell the audience that this is why you think it looks flat?
What are you talking about, dude?
Does
You're
it look
telling us
flat?
why you think it looks flat because light bends.
This is excellent.
What are you talking about?
Oh, yeah, what are you talking about? Oh, I don't understand basic English anymore. Does it look flat? Why does it look flat? And does it look flat? Do you see any curvature in the observation? Did you see any geometric horizon or any horizon over the 21 miles? Yes or no?
That's because you're on a two-dimensional manifold here. Like if you scale it out, like if you go towards
All right,
like
so the sphere Earth is a two-dimensional manifold. Got it.
no, what you showed in the images, that's a flat plane.
It is
You
a flat
understand that?
plane.
Damn
You
Skippy.
got something right.
A two-dimensional manifold is a flat plane.
Yeah, but you need to specify what kind of manifold, dipshit. If you said a spherical manifold, then there'd be a mismatch between Cartesian Euclidean geometry and the geodesic spherical manifold geometry, wouldn't there? Right? This could be calculated in something called the transport rate as you take one vector and you notice an increasing divergence along another vector.
Okay.
Oh yeah, you're laughing because yeah, guess what? I had differential geometry in college.
Did you?
I just told you I did. Why would you ask me if I did?
You did not take college, bud.
Hong Kong. Yeah, here you are losing to a whole bunch of flat earthers in Discord.
No, you can't agree with
Yeah,
what
so
I
guess
said.
what? Yeah, guess what? I never went to a single college course in my life, and you're
No, you
getting
didn't.
embarrassed by a bunch of flurfs on Discord.
He can't agree with what I said, or else he knows the images that he posted in
I
the side
agree
channel
that it
are-
looks flat. I agree that it looks
I
flat,
don't
knowledge.
care if it looks
Let's start
flat.
there.
Yes, the ground looks flat, but if you scale it out,
All right,
like,
it
if
looks
you go
flat.
towards,
Great.
like,
Okay,
if
so you
If you
have a
scale
coping
it up,
session for
okay,
why.
so if you see something that looks flat and you scale it up, it's going to curve?
you can see the curvature. Yes.
So you just told
Yeah,
the
how do
entire
we do
room
that?
that it looks flat, and you say scaling it up
Who cares,
will
idiot?
make you
Be
see
quiet.
curve, even though you see the curve. Knowledge, you come around here all the time. You just made a new account.
No,
You're
I
actually
don't.
a clown.
No, you're the clown.
Well, then you have twins with the same voice as you, bro. Just a copy and paste.
So knowledge, this
fucking-
is what you can do. This is what you can do with this observation. You can
Don't care.
calculate. You can calculate.
You're not doing any
What
calculations. You just showed me like
you
a
can
Google map.
calculate how much the refraction coefficient would have to be to have no hidden height on a globe over this
How
lake.
are you going to do
Do you know what
that
the?
if you didn't take the air temperature into account? Tell me.
No, you can
It is not-
calculate. Listen,
Wait, did you
listen.
do
You
it?
can.
Did you do it?
No,
Did you do it?
listen.
Did you calculate
Listen.
the air pressure, the air temperature?
No,
or
because
the-
I'm not the one making the claim here.
Then your image is wrong, buddy.
No, what's wrong about the image?
Did I? Because you didn't calculate the air temperature because
Right. So how does
the
that
light rays
make the
bend
image
downward.
wrong? Right. So you're saying that refraction. You're saying that you can have a refraction coefficient of about k equals 0.99 with no miraging effects or anything. You probably don't know what I'm even saying right now, do you?
Well, he
know
said
what a
you
refraction-
calculate air temperature. I want to know how you calculate air temperature. Yeah, go describe a calculation of air temperature. Because you know what? I think you mean measurement, but you said calculation instead. So how do you calculate air temperature?
Would you agree that cold air is dense and warm air is dense?
Yeah,
right?
so how do you calculate air temperature?
Would you say that light travels slower in dense air? and
Yeah, yeah.
faster
So
in
how
cold
do you
air?
calculate air temperature?
So
The
if
answer
you
is yes.
don't-
How do you calculate it?
So if you don't do this in your images, right? If you don't understand how the light travels slower,
I
it's
understand.
going-
I
the
completely
distance
understand
is
it. Okay,
going to
probably
be
better than you. How
wrong.
do you calculate it?
The distance is going to be wrong.
So just keep dodging the question because you probably effed up and you don't want anybody to know. How do you
The
calculate air
distance.
temperature?
He just said the distance is going to be wrong.
Oh God.
The distance.
Yes, because the light travels slower like compared to like what the temperature is.
So what distance is going to be
When
wrong based on that?
Yes, what you posted
What
inside.
distance? The
Let me go
distance
get
of
it.
what?
Let me go
The
get it.
distance of what?
You
Can't
said
you
that this
answer
was
the question?
21 feet, like 2.7 point like horizon, like what you posted here,
That's
right?
the geometric horizon
Did
distance.
you
That's the
calculate the
physical.
temperature when you took this? Did you do it?
No,
Why not?
because I'm not making a
If the distance
claim
is
to the
going to be,
shape of the Earth.
if you
You are.
understand how refraction works, you have to calculate the temperature to actually understand what the
I'm not
distance
claim.
is.
Okay, all
Yes,
right.
you
So we
are.
can.
Yes, you
No,
are.
I'm not. I'm not trying to claim the shape of the Earth. You are. I'm just
No,
testing that,
you're
and there's
trying
no
to tell me
curvature.
the you posted inside there.
Calculate
Let me go get it. Let me go get it for you. What you posted.
No, I already know what I
You showed
posted.
me a Google image of a distance of, what was it, 21 miles? How do you know it's 21
Yep.
miles if you didn't calculate the temperature?
According to the globe, right? According to the maps of the globe,
Okay.
it's 21 miles, right?
But
So according to the globe model, over 21 miles, you should have 294 foot of curvature. Okay, according to the globe model, refraction coefficient of 0.13 is standard refraction. Right? Applying all of these things, the shoreline on the distant, right, 21 miles away should be around 200 foot hidden. It's not. There's actually no horizon over the entire 21
the
mile
air
lake.
temperature though.
Oh yeah, I forgot to calculate that.
matter.
Let me just get my calculator out
So the
and calculate
200
it right
plus
now.
feet is now null and void.
Yeah, it can't be 21 miles anymore because I didn't calculate the air temperature.
Any picture that you ever take, it has to come with a calculated air temperature now.
If you want to calculate the distance, yeah, it has to be that way.
I didn't calculate the distance. I just checked Google Maps.
Google Maps is lying though.
Yeah, well, they didn't have a temperature calculation, actually. Now, come to think of it.
Did they get a
So I guess,
temperature circumference as well? A pressure temperature
you
circumference?
should
maybe?
calculate the CO2 and the humidity. Calculate the humidity and apply those, and then maybe it won't be 21 miles anymore across that lake. Maybe it'll be 50 miles.
The Earth
or
is actually getting bigger and smaller based on the air that surrounds it.
Well, based on this observation, you would have to have a radius of like 1 million miles or something like that. So knowledge for this observation to be correct, you would have to have a refraction coefficient, right, which is little k equals 0.99. There's no evidence that such a refraction coefficient has ever been measured using visible light of any wavelength without, especially without crazy destruction like miraging effects, Fata Morgana, Superior Mirage, that kind of thing. We don't see any of that. In fact, it looks nice and clean and clear. So for you to claim that there's some type of temperature, pressure, humidity relationship that could cause 294 foot of curvature to just be completely flat is just a bullshit, baseless claim that you don't have any evidence for to back up whatsoever. And that's why when you bring up refraction, you globers, you shoot yourself in the head.
No, I
It's
didn't.
the worst nightmare. It's your worst
No, it isn't.
nightmare. Because
No,
you
it
don't
isn't.
have a single observation throughout all of history that accurately measured the temperature gradient vertically between point A and point B, and then used those measurements to do a calculation to work out the refractive index along the path, and then use that, right, to deduct the refraction on the particular day back to it matching the globe. You don't have that. It doesn't exist. All you know how to do is just say the word refraction. You learn how to make a noise with your mouth. Congratulations.
But you're
Have another
absolutely
bong
wrong
hit.
about this.
Oh, really? What was I wrong about? Name one thing.
Everything you just said.
Name one thing.
Yeah. Like,
Name one thing.
yeah. Like, right, you said that, like it should be hidden, like, right?
Like?
Physically hidden, geometrically hidden, physically obstructed behind the curvature of the Earth. Yes. 223 feet.
Okay. Prove it.
Okay. Right. So if the Earth is a globe with a radius of 3,959 miles, we can use the equation 1.225 times the square root of the observer's height in feet, which will calculate the distance to the geometric horizon, which is 2.73 miles. Right. And then we can calculate that the hidden height for the distant shoreline, 21.03 miles away, is 223 feet. If the Earth's a globe. Is the math wrong? Do you think the math's wrong?
No,
It's funny how they would make an Earth curve calculator, but when you go to use it, it's always wrong every time. No matter where you are, no matter what the fucking temperature is. It's funny how it's always wrong every time, anywhere, any distance. But you, day one, learning about flat Earth, you wouldn't know that.
No, like.
No? Like? Good response, bro.
Yeah.
Is that it? You done? Knowledge?
I don't think he has experience talking to 24/7.
He doesn't have the knowledge.
We can present not only laser measurements, but long distance, high altitude infrared photogrammetry, microwave-link tests, all kinds of things.
No, you can't. You actually distort everything.
We can and we do.
No, you don't. That's
We
why you
can.
get
It's
laughed
posted
at.
all over our home server as well as YouTube channels and
Yes,
everywhere
and no
else.
one takes you seriously.
Well, that's your problem, okay?
And everybody laughs at you, even scientists, even
even scientists, right? Yeah, even those scientists that are on our staff, because we're paid to indoctrinate you.
I wouldn't say that they're paid. I would just say that they're wrong.
Joking.
Like, I don't
It's a
think you have
labor of
bad
love, man. Nobody comes to this conclusion with any payment in hand.
I don't think you have any bad intentions.
You know why people don't take this seriously? It's because they've been told their entire lives that this is not a topic to be taken seriously. Totally serious.
I don't do it as a pilot because I need, like, there to be a globe in order to navigate. Because it is.
I know. You need your coordinate reference system to be a globe, to be interoperable with everybody else that uses the same coordinate reference system.
No, I know that time is fourth dimensional, meaning that space-time, so that would mean that, like, the differential manifold, like, affects the metric tense. That's what creates the geodesic. The geodesic is the shortest path between 2 points, like, on, like, a curved surface. That's what all pilots use to navigate. All of our airline routes, we use that to navigate, like, from point A to point B.
What type of pilot are you? I didn't know.
It's relativity that causes it to look straight when it's not. Great. So how would you know it's curving if not for relativity?
How do you know it's curving?
Yeah, if not for relativity, because you brought up that space-time, right, affects the metric tensor, which allows for geodesics to be the straightest path in this version of space-time. So are you throwing Eratosthenes under the bus and all the Greeks, Aristotle, Epicurus, and so on and so forth?
Aristotle? He's a philosopher. Come on, boy.
Yeah.
See, he doesn't even understand the point you're making.
No, he doesn't.
We even throw Newton under the bus because his theory is wrong, right? About gravity. Gravity isn't a force.
I mean, if you accept relativity, you wouldn't say that, though. You would say that Newton's laws are actually part of the entire general relativity framework.
They're also part of our modern way of life.
All right, so now you're not throwing him under the bus.
I'm throwing Newton under the bus, not Einstein.
Yeah, but Newton's laws are part of relativity, right?
No, I'm talking about his theory of gravity as well.
Okay, good. So I can agree there. So nobody knew that Earth was a globe until what? Einstein? Is that what you're saying?
We knew the Earth was a globe, I think, before Galileo. Before, like, we had Bruno, which, like, he was executed for that. That was pretty funny.
Oh yeah, how would you know that if space-time itself is curved and you can't measure it?
We can measure it.
Then how did they measure it if the objects in space-time they were using were also curved and look straight?
Because we know that time is relative to the observer. That's how you measure it.
How did they know that back in the 1500s?
I'm talking about Einstein. Moment.
I know you are, and I'm asking you, how did they know Earth was a globe before Einstein?
How did they know? Because of their observations, like, right?
Right, but hold on. But you said the observations are limited to the manifold of space-time through which they're observing, which means their observations would make it look straight, even though they're not. So how did they know that before Einstein?
You tell me.
That's your claim. I'm asking you how.
I was saying, like, the Romans knew this. Galileo knew it. Bruno knew it.
Yeah, how? If they didn't have any concept of four-dimensional manifold space-time, how did they know?
Because they observed, like, you know, the planets and like the moon, which is like, you know,
Like,
if those are spheres, there's no reason not to believe the Earth is a sphere.
Okay, so guess what? If you're in a parking lot and you look at cars all around you, do you think you're a car too?
No, but the parking lot is. The parking lot's actually a car.
I know that when I take off from, like,
Wow, these guys are falling apart. I mean, you would think it'd be some complicated like thing that they were doing, but then he just says, "Oh, we look at moon. Earth must be like moon." Like, bro.
Do you use
Yeah, he throws out $1 million
bro?
terms like relativity and manifolds, and I don't think he understands where he's getting into with all this.
So we say that, like, time is relative to the observer, right? Meaning that, like, with a strong, like, you know, gravitational, like, pull, like, we know that time ticks, like, slower on the surface of the Earth near the equator, simply because, like, it's near, like, you know, the center. We know that it ticks faster up in the air, right? So how does that translate to modern life? Well, GPS satellite systems. You have to take time dilation into account. Yeah, the GPS
I'm glad you
satellite,
brought this up.
because because time dilation is proof that Einstein is correct. We use them. Do you use them?
I love GPS systems. Yeah, let's stay on GPS for a while.
How are the clocks accurate if you don't take time dilation into account?
How would you know that? Let me tell you what. There's one of the guys who owns a bunch of patents on the GPS system. His name is Ron Hatch. He's got like maybe 20 or so patents on this, and he speaks at forums involving geodetic surveying and space physics, all kinds of things. And you know what he said? As one of the inventors of GPS, he said that general relativity corrections are actually canceled out by special relativity, which means you don't actually need to take them into account. That's right. And that's how he fixed the GPS network. No, that's how he fixed it. And I'll tell you how he did it. And his explanation was based off of the idea that because Earth, a globe Earth, right, has a bulge, an equatorial bulge of about 14 miles, that the increased mass in a general relativistic sense counteracts the motion, the relative motion of the satellites above the Earth in the ECI frame, Earth-centered inertial frame, due to special relativity. And that the precise cancellation of effects means that the entire general relativity correction is not actually needed whatsoever. And is actually canceled out elsewhere within the system.
No, it isn't.
No. Would you like to read a book about this, or maybe his
I don't care
papers? I
about
can
the
post a
book.
bunch.
I understand that they would be a lot slower, or they would be inaccurate.
Oh, a
if you
lot. How
didn't
much
take.
slower? How much
It would
slower?
be like 38 like microseconds, right? Because like
Yeah, per year.
Because like it's the exact time it takes, like, for like a light signal like to travel.
Per year or
like,
per
right?
day?
It would be 10 like kilometers.
How do you know the clocks run slower? in an accelerated frame?
How do I know? Because you can test it yourself.
Yeah, how is that done? What's one of the
Why
best
don't you
tests
do
that?
it? Why don't you do
No,
it?
I'm asking you. This is your claim. I want you to describe for the audience how you know this is true.
Because space-time is distorted. Okay,
I know that
time.
that's the claim. You keep repeating the
It's
claim. I
not
want
the
you to know.
claim. It's what's actually true, buddy. Did you go to college like
How
you
do
claim?
you know it's true? Do you understand what I'm even asking?
Because I fly the plane, buddy.
Oh, whoa. So your plane has like an
Oh,
atomic
man.
clock in it?
Like geodesics exist out of space-time. Okay?
They exist in your conceptual math, in your
No.
spherical coordinate system.
Like the geodesic is what we all pilots use to navigate. Like it's called like all
I
airlines do
understand.
this.
I understand. Yes. Would you like to discuss the Air Data Inertial Reference Unit of commercial airlines?
What is a geodesic? Can you explain what a geodesic is?
Yeah, it's an arcing path within a curving reference frame.
It's a straight line on a curved surface.
I said it's an arcing path within a curving
In
reference
order
frame.
for us to follow a geodesic, we're following a curved surface, meaning that the
Yeah,
Earth
but
is round, buddy. Are you saying that every single pilot in all the airlines are wrong and you're right?
no, I'm not.
So
I'm actually
basically,
asking
the
you if
Earth
you
is a
understand that a
globe
curved
based on
path within a curving
terminology
space-time.
and not anything to
Whoa.
prove.
No, they say they fly over a flat Earth.
Yeah, and second off, do you understand that the airplane has one job to do? If you fly with a modern aircraft that is taking elevation and azimuthal headings, it has one job to do, and that's plot your time over distance within a geodesic coordinate system.
And that's the shortest path between 2 points?
How do you know that is in reality?
Because it's a straight line. All straight.
In
We do that.
reality, yes, it is. Congratulations.
Two-dimensional manifold, which is the flat plane. Like the shortest path between 2 points is a straight line. You would do that like so.
So not
in
over
the
a
air,
ball
in
then.
the
So
air,
not around a ball then.
Exactly. He
Yeah,
just
so not
completely
around a
destroyed his
ball.
own
But a
argument.
straight
Yeah.
line in like
It's
when
not
you
around a
fly
ball. A straight line does not
is
curve.
a geodesic,
No,
which is
a
a
straight
line
line
on a
does
curved
not
surface.
curve.
But you follow a curved surface. That's the straight line when you fly.
You're like what do you call that? Jesus, a walking talking contradiction. A curved line is straight.
Straight lines work differently.
Right.
Up in the
Straight
air than they
lines
do
are
on the ground.
curved. Curved lines are
Right.
straight.
His coordinate
Triangles are
reference system is
curved.
curving.
Triangles are straight.
So
His frame of reference is
all
one
the
that is
commercial
curved. Okay.
airlines, are they all wrong? You're right. We don't need geodesics anymore.
What do you mean
navigate
they're
You don't
all
need it.
wrong?
All airline routes by commercial use are navigated for the shortest possible distance, right? To maximize our
How do you
fuel
know
efficiency.
that's true? I'm going to say BS. Okay. How do you prove that?
Okay. Hold on.
Dude, why does it sound like you're talking across the hall?
Listen, you have a curving frame of reference, and your paths are also curved within that frame of reference. The question is why, when you're taking straight paths in reality, as you admitted.
Yeah, it's a tough spot.
My fear of flying's even more justified now after listening to this guy. Strudel, shush.
Dude, and chat is going crazy. It's like a 2-for-1 in here. You can knock them down on both sides. The guy in chat's having a meltdown. He doesn't know what a triangle is. I had to tell him. He said, "You didn't have to tell me what a triangle was." I had to clip it for him where he said, "Okay, professor, what is a triangle?" Because he had to ask me. I said, "You didn't even know what a triangle was."
It's kind of like when they do the Michelson-Morley test, right? And they did not detect that Earth moves within its with respect to a fixed reference frame. And they say, well, the reason why we couldn't detect that motion is because what we're using to measure it with is being compressed due to space-time geodesics. And then, so how do you prove the unfalsifiable? You can't. So it's just a coping mechanism. until other data comes to light. And I'm surprised he never brought up any of the relativistic experiments, or I should say tests, that have been conducted. Like Heffel-Keating or the Pound-Rebka test or anything like that. He does not know a single thing about any of this that's been done within his own framework of knowledge.
Yeah, well, he's posted in the side chat his confirmation of the Great Circle line shortest flight path, right? It's just presupposing a globe. Once again, Yoda's asking you to validate that it's actually a straight line, and
use this to navigate. All commercial airlines do
Yeah,
this.
we understand that they do. We understand that the map they use has two points of origin.
Wrong,
the map they use has 2 points of origin, one in the north and one in the south, connected by longitudinal meridians. We understand that. That is the map. The map is not the territory. You're making the error for all the ages. You're putting the map before the land instead of the land before the map.
Do you understand what a Great Circle route is?
Yes, I do. And I understand for that to work, you need to have curvature in the vertical axis, which could be the Z axis in this convention.
So does airplanes take off and get from point A to point B all the time? Right?
Oh, so now you're asking me
In
to
order
accept a
for you,
pragmatic fallacy?
in
You're
order for
asking
you to
me
prove
because
that
it
it is
works, it
wrong,
must be
you have to
true?
prove that we don't make it to our destination when we do.
No, I don't. No, I don't. You have to prove that what you're doing is what you say you're doing. So how would you prove that you're curving in the vertical axis?
How would you prove it?
Do I have to ask the same question that you asked? Yes. How do you prove it?
That's easy. Like you would know, we've already proved it, like through Einstein, right? We know that time is fourth dimensional. Fourth dimensional means that like gravity is an effect of time, which means that like, so when you like, so space time is warped, like due to like, the mass, like, right? That's what creates like the curvature. That's what
Yeah.
gravity
How do you
is.
measure the warping? How do you measure that?
How do you measure it? By putting like, well, you could just by the object like that warps it.
Yeah. How do you measure that? You keep repeating the claim. How do you do that?
You tell me.
He doesn't
No.
know
How
how to
does the
measure
object warp
anything, dude.
space
He
knowledge? How do
calculates.
objects warp space-time knowledge?
They do because of their mass, the objects.
How? Okay. How do you know that's true?
How do I know it's true? Because the geodesic is born out of it, and I navigate it.
How do you know the geodesic is true?
Because I get from point A to point B every day.
So what?
It
Guess what?
works.
I have a GPS and it takes me the wrong route to my friend's house, but it thinks it's the shortest route.
Well, sucks.
Hey, do you understand you're not verifying the thing in question, right?
Right. You keep repeating the claim as evidence for the claim knowledge, and that's not how
I
this
don't,
works.
but
That's not
you
how you
can do
prove
the
something.
experiment. I can prove that time ticks slower on the ground than it does up in the air. You can do this too.
Good. Okay. Present me one example where that's true.
I posted it in the side chat, but like this chat like deletes all of the messages like after a day or
Okay.
so.
Why don't you describe for the audience what that was?
So they did an experiment about like the clocks, like where they put like the clocks on the ground, and like they observed that like the further away you are from like the Earth's gravitational pull, like towards the center, like time ticks faster in the air than it does on the ground. Hold on, let me go
Okay.
get
So
it.
what did they do?
Let me go get it. I'll post in the side chat just like I did the other one.
All right. Not that I want to poison the well, but you're going to post the Heffel-Keating test, which was refuted by James Kelly in 2002 Scientific American when he found some unpublished data regarding this that they'd thrown out because they had actually flown the atomic clocks on 747s east and west that had actually, through their flights, had logged time that ticked in the opposite direction than what was supposed from special relativity. And I can post that information, but I'll let you post, and then you can describe for the audience what I just said to the audience. How about that?
Well, I mean, if there's a second, I'd like to point out that even the claim that the airplanes fly the shortest route, which is by definition a straight line, is analytically false on his paradigm where the airplane is in the air in free space. So his claim would have to be that the airplanes are not flying the shortest.
They are.
Well, no, I don't mean to sidetrack you. Go ahead with your paper.
The only time
Are you a
that
commercial
they might
pilot
be doing that
knowledge?
would be
Just
for,
quickly.
like, the only
Just a
time
quick
that they would be
question.
doing that would be towards commercial. But the only time that wouldn't happen is for safety reasons, right? Like, right, on perfect day, perfect conditions, you would follow the div. But
No,
like,
I'm pointing
but
out that it's just analytically false. It would just be that they're in free space. The shortest distance between 2 points is a straight line. You're saying that they're following the surface beneath them in the air, right? So that wouldn't be the shortest distance between 2 points in the air, analytically false.
the geodesic is. Yes.
Are you a commercial pilot
So,
knowledge?
so
Knowledge.
Dr.
Hello.
Yonder. Okay. So, and
Knowledge.
these should not be like
Knowledge. Can you hear me?
differences at all. Be quiet. No one cares.
Answer the question.
No.
Let's say no. I'll answer for him. No, he's not. Drone
Stop asking me
licenses, like I
questions.
told you the other day, flying a drone in your backyard does not make you a pilot.
Yeah, what type of pilot are you?
I told you.
No, you didn't tell me. That's why I'm asking.
What type of license?
I'm
What type of
answering
license
his
do you have?
question. Stop asking me a million questions.
Just
I
asking
can
you
ask
one
you this.
question.
Go ahead.
Well, I just want to get this one answer, right? What type of pilot? What type of planes do you fly?
What type of license do you have, more specifically? See, if
Should
you
be
can't
an
answer
easy
it,
question to answer.
if you can't answer it right away like that, then we don't believe you.
Hey, Knowledge, how come in the test results from this that were dug up by James Kelly in 2000, 2002, test results show both positive and negative numbers for eastward and westward flights with respect to the fixed atomic clocks on the ground?
The 2002 what?
Hafel-Keating, okay? Your claim was that the Hafel-Keating test had proven general relativity, but when we pull up the actual data, which I posted at 13 minutes past the hour, the test results for eastward are positive and negative with respect to a stationary ground clock. And the test results for westward were positive and negative with respect to a stationary ground clock. Why would that be the case?
There shouldn't be any differences. It's because of like the gravitational pull, right?
Well,
like,
why would it be positive and negative? Because it looks like the plane was flying eastward and westward with respect to only an eastward direction. And for westward, it looks like it was also flying eastward and westward with also respect to a westward direction because the clocks were positive and negative.
Yeah, so what's your point?
The point is Hafel-Keating is actually considered fraud.
This isn't fraud.
The thing that you think proves that special relativity is true is considered scientific fraud. Yeah, it's considered
fraud.
for the reason that I just said.
There
Yes,
shouldn't
because
be any differences between the clocks. Okay,
there
there's
was
the time,
differences. Okay, the differences were not only differences, but positive and negative differences, which means the claim direction
your claim is
within the frame of reference is going to be eastward and westward with respect to eastward, as well as eastward and westward with respect to westward.
Okay, but time dilation says, like, right, that like when you're near a strong gravitational pull, which like when you're on the ground, time is going to tick slower because gravity, like, slows down time. Okay, that's the reason for the differences. When you're up in the air, that's the reason why you get the difference in the fucking different times here, right?
So why would the clocks tick in the opposite direction? Because what, gravity? So you're saying you can't falsify this? You're saying that you can't tell the direction the airplanes were flying in special relativity because of this? Great. Back to the drawing board for you.
This isn't fraud. You're just an idiot. This is exactly how we. This is how we update our GPS.
So it's his fault.
right?
It's his fault. You're an idiot, right? It's
Yeah,
somebody
sounds
else's
like it.
fault. You're the idiot.
Is that what you say? Like an experiment that proves Einstein's theory? You say it's fraud?
No, it didn't. I'm telling you,
Einstein was
it didn't match the
85
predictions.
IQ. Yeah, Einstein was 85 IQ. He walked around with his tongue sticking out. Did you ever see that? And he wore women's shoes.
You know, the scientific community fully accepts this, right? They didn't call it fraud.
No, they don't.
I know they accept it, but they don't accept the James Kelly investigation that was done years later, because this test was done in the 70s. This test was done in the 1970s, and then republished in the 1990s and 2000s.
Can you post that
2000 by Scientific American. Huh?
Do me a favor and post it. I have not seen it.
I just posted the data. You want to see the rest of it?
Yes. You could be right. I don't know. I got an open mind here.
Doesn't sound like it, but okay. Go find it.
If the math is correct, I can't argue with it. I'm sorry. I'm afraid.
Yeah. You know how to do math for relativity?
I did it for the neutrinos earlier.
You did trigonometry. You didn't do any math regarding, because you know how they detect neutrinos? Do you know why they use a Monte Carlo simulation? Do you know why they use a Monte Carlo simulation to detect neutrinos?
Wait, you were the guy I was talking to.
Duh. Yeah, why do they use Monte Carlo to detect neutrinos?
Why do they?
I'm calling him James Kelly. It's A.G. Kelly. All right, here's the paper.
I want to see it.
Okay, here it comes.
I'm dealing with a flat earther always has to be wrong guy in chat. It's funny. So now that shark fin's an irregular shape, but triangle B is a concave triangle. He called it, but the shark is not a triangle anymore. But space B on this chart here, this is a special triangle. He said it's got its own classification, and then I posted this, which is the shark fin swimming the other direction. And he said, no, that's not. So I'm not sure how shark fins work with globers anymore.
I'm sorry, so?
Okay, I'm going to read this for the audience. In Heffel-Keating test, did they prove anything? Question mark. There's a case for potential fraud when the raw data from the experiment showed much larger variations and inconsistencies than reported. When he examined the raw data, which was not only originally offered with the 1992 Science paper, critic A.G. Kelly, not James Kelly, so A.G. Kelly, discovered that the total range of drift during the experiment was about 7,000 nanoseconds, which is significantly larger than the reported effects. What's worse is the data appear to have been altered in order to falsely predict, really post-dict Einstein's relativity. According to Kelly's table, the alterations were significant. Clock 120, original reading was negative 57, altered to negative 55. Clock 361 eastward, originally reading positive 277, altered to negative 51. Clock 408 westward, original reading negative 54, altered to positive 262. What was concluded by A.G. Kelly and other researchers is that the atomic clocks were not stable. The original data tables were altered, and there's evidence of intent to deceive by data fitting the results to fit Einstein's equations. Here's some of the data that A.G. Kelly examined, which he presented for the first time after Heffel-Keating withheld it. Yeah, and I get that many scientists, people who claim or profess to be as such, refer to this test as definitive proof of special relativity. I'm also aware of the criticism behind it. And you know what? As somebody who's academically honest, I think it's important to weigh the evidence, positive and negative, against claims, don't you? Well, I guess we're done here. I will yield the floor to everyone else. Sorry for hogging it.
No, that was a good addition to this beautiful clip. But I want to know if this guy's really a pilot or not. Still, he won't answer. So if he
I
won't
talked to
answer
him
that,
yesterday. I told him drone pilots don't count, and he would never respond. So we know what he is now.
maybe he's a flight simulator pilot.
Yeah, Microsoft. We included that one too. Remember? We said, and there's another game that one also does not count as being a pilot, dude. Even though you earned your license in the game, it still doesn't count.
Yeah, Pilot
Yeah.
Wings on Super Nintendo.
Yeah, Atari Chopper Attack.
Ace Combat 7. It's like Call of Duty for wannabe airline pilots.
So we're gonna learn about triangles because Strudel at first knew what a triangle was. Then I showed him another picture. Then he said, well, no, there's different triangles then. All of a sudden there was different kinds of triangles. Then I showed him shark fins. We went to shark fins. He said, not a triangle. Showed him shark fin triangle. But showed him a shark fin with one curved side, or that is a triangle with one curved side. You show him a shark fin that's a triangle with no curved sides, but he said that's no longer a triangle. So these guys are losing their minds. I'm afraid that I might have to retire this test because I don't know what to do with it anymore.
Strudel, sounds like you got a bit
Yo,
wrecked in the
how's
side
it
chat.
going? Whatever you say, baby girl. What are you saying, boys? What's
You broke him.
crack-a-lacking? How are we
You
doing?
broke this one good and proper.
I'm so broke. Ooh.
Now I can see why you're on mute.
No, this is how I talk normally, baby. Right, so
Yeah, he
what's
sounds
poppin'?
like he's on
What
drugs.
we talking about?
Brainworms.
Drugs. Hey. You got some?
He's embarrassed. That's what
You
it
having a
sounds like when they're
party?
embarrassed. Don't be embarrassed, dude. Every single
I'm
Glober
so
fails it.
embarrassed, dude.
Every Glober fails it, dude.
Oh, what will I do? So yes, like I said, there are standardized triangles and they are flat-sided
No,
shapes,
they're
3
all
points. Yes,
so 3
but there are
angles. 3
different
points is not an
classifiers of
angle.
triangles. There are triangles with extra classifiers.
Like if I put two oranges
There are
next to each other
triangles
and they
with
meet at
extra
an angle.
classifiers.
Yeah,
There
if I
are
put two.
triangles with extra classifiers. You know
No,
what that
there's
means?
not extra
Yes,
classifiers.
Yes,
What?
they are. They are not
Like what?
purely triangles. They are different shapes, but they are called triangles. Yes.
No, triangles
Yes,
have
they
3
are referred
angles.
to as triangles. Yes, they are referred to as convex and concave triangles. The word triangle is there.
So
But
there's 3
yes,
angles
you
in
are
them?
correct. You are correct. Triangles, specifically just the word triangle, only have 3 sides and 3 interior angles and 3 points. Yes, you're right, and they add up to 180 degrees, which is what I'm trying to explain
It's
to you.
a
But I was
shark fin concave or
agreeing with you.
convex.
The
Hey, Strudel,
the shark fin
it's
that
a
he sent me.
shark fin
The shark
concave or
fin that
convex.
it has, the one he sent me has one concave angle, one convex angle, and two bottom angles that have they're actually convex. Yeah. So that's actually a 7-sided shape he sent me. The one that he asked me about. The
Holy
original one he
shit, a
asked me about.
7-sided triangle?
It's not a triangle, no. Yeah, you're right.
It's not
I said
even
it
a
wasn't.
triangle?
I said it wasn't.
See what happens when you ask him what a triangle is? He came up with
Dude,
an
look at the
hour.
image you
An
sent
hour
me.
now. He's been trying to
No,
figure out what
hold
a
up.
triangle
Look
is.
at the image you sent me. The image you sent me has waves that make up the bottom side, which is like
You should have
six
said
different
no. That's
sides.
a
Excellent.
shark
I did
fin.
say no. I did say
Yeah, you
no.
should have said it's a shark fin.
There's a shark fin and waves actually.
Just say it's a
made up.
shark fin.
No, but
It's a
it's a shark
cartoon
fin
drawing
with
of a
waves.
shark fin. That's all
Yeah,
you
but
had
the
to say.
2D shape.
See how you
The
didn't pass
2D
the
shape
psychological test I
is
was doing on you?
1, 2.
This
The
is just a
2D shape.
psychological test I do on
The
you guys.
2D shape is 1, 2,
What the
3,
fuck?
4, 5, 6. It
What
has
is this
6
thing, Rod,
angles. The
dude?
2D shape you sent
What
has
the
6
fuck?
angles.
They're fighting all the time. Fighting.
It's not a pure
All
shark
because I
fin what
asked him
you
if he
sent
knew what
me.
a triangle was.
Yeah, and you were wrong. I was right. Yeah,
Strudel.
exactly.
Strudel, let's see if you're right. So a triangle
Oh my
is
god. A
it's got 3
triangle
angles,
is a
right?
3-sided shape with 3 angles, yes. 2 angles
Okay,
at
great. So
120
let's
degrees, yes.
test.
But there
Anything
are
that
looks
doesn't
like we
have
gotta find out what an
classifiers
angle
of
is.
triangles. But there are
Yeah, that's what we got to do. Okay, it's better if you're not talking, Strudel. I think even your folks would agree. So let's just do the final test. Can you get me the angles, all 3 angles, inside that triangle, and we'll see if you're correct. The thing that you think is a triangle, like the shark fin. Let's see if it's a triangle. Get the angles, and we'll see if you're right.
Thirty.
What? Dude, I never said it was just purely a triangle. I said it was a concave, convex triangle, my dude.
Are you
Look
just
at
making
what
stuff
that is.
up?
But my
No, it's not
dude,
made up.
all I
Google what
asked you
one is.
was,
It's
what's
a
a
real shape.
triangle?
It's
All I
what do you
asked you was,
mean?
what's a
Yeah, but you asked me
triangle,
what a shark
Strudel?
fin was, and I told you what a shark fin was too.
And I said, is
What
this
are
a
you
triangle? And you
saying?
should have said, no, it's a shark
I did
fin.
say it. I did say no. You're reinventing history in real time. That's crazy.
You said it's a 7-pointed object.
Yeah, the one you sent was, because it has waves at the bottom of it which make up the rest of the shape. Yes, you're right.
Are those points angles?
Yes! What the fuck is he saying?
Whoa.
What
So
are
we
you
can add up
saying?
the interior of that, right? We can measure the angles
Yeah,
on
and
that shark fin.
it'll be much greater than 180, yeah, because it has
Every
many
angle.
different
Every
shapes.
angle.
And it's
They're making a
concave.
suit of every angle.
How do you make a curved angle? Define an angle, please. Yeah, what's an angle?
This is crazy, dude. Yeah, it's point, bro.
I broke you,
Oh
didn't
my
I?
god.
I'm sorry,
No, I'm
everybody.
laughing at you. It's hilarious. What you're
I asked
saying
you
is
what an
fucking
angle
funny.
was. What's an angle?
Define
What
angle
do
or
you
go
mean,
back on
what is
mute,
an
Strudel.
angle?
You're painful
What
to
do you
listen to.
mean, what is an angle? Do you
Just
not
define it or
know?
go on mute. You have 2 options. Which option do you choose? Define angle or go on
Measure with a
mute?
protractor, my guy. What
Define
do you
angle or go
mean?
on mute. Last chance. Okay. You made that decision.
Holy crap. I haven't done that in a long time.
Yeah, stop hurting these
Right.
Globers, Professor, bro. It's
Yeah,
not
no
fair.
side
It's like
chat
beating up on
privileges.
kindergartner. Maybe you need a preschool test triangles, or do they even have triangles in preschool?
Yeah, the Peppa Pig. We need to show them the Peppa Pig series of shapes.
Oh,
Running
so you
shapes
gotta
with
make
Peppa Pig.
you gotta make the triangle into Peppa Pig, and then maybe they'll get it. Okay.
I literally have a meme that does that. It points to Peppa Pig's mouth and says, "Is this a triangle?"
Oh shit, it's already been done. Oh my gosh! All right,
Yeah.
we're cooked. couldn't sleep this morning, so I just went on TikTok and see what was going on, and I finally saw that Angels of Light guy. It's like the one guy I haven't seen on there. I gave him a follow, and within like 5 minutes of him starting his live, he had like 200 people in his chat, and like
Mm-hmm.
yeah, so I'm like, who is this guy? I had no idea. And I went to his channel, and I didn't know he was like one of the bigger, or the biggest TikTok flat earther out there. 65,000 followers, and yeah, his style is a bit interesting. I wasn't a big fan of it because he kind of the Globers would ask him one question. They'd be like, okay, so what about like I don't know, like the sun or something like that. And then he wouldn't talk about the sun. He would shift it to a different topic. So he would shift it to like airplanes, right? So
He likes talking about airplanes. Yeah.
yeah, so I don't know. It wasn't for me per se because like just address what the Glober is saying and like don't just like
So if I
run
told you
away.
the sun goes away and that's why it looks like it's going down around the ball, have you ever seen a plane fly away from you? What would you say?
Have I ever
You would
seen a
say,
plane?
"Oh," you would say, "Oh, now I get it. Gee, I shouldn't have said anything."
Yeah, but as the Glober, right? You're clearly not going to think like that. So you
No.
kind of
What happens when you okay, Glober, because I can tell you still are. What happens when you see a plane flying away from you? What does the plane look like it's doing?
yeah, it's just going out of your vision, clearly. But
It
they're not
doesn't
going to
look
say
like it's
that.
going down. It does not to now. It doesn't look like it's going down.
I get where you're coming from. I get what you're saying. But to just like address the point, besides, because every time a Glober brought
I
up a
did.
point,
You see that how I addressed the point? I'm sure he does something like that too.
yeah,
Yeah, some of his arguments are good. A lot of them are just like David Weiss scripts. But you know, he does a good job overall. I think it's difficult to sit there and debate Glober after Glober after Glober for hours straight every day.
yeah, I get it. I just like I listened to him for like 15 minutes, and like every single question the Glober asked him, he went to a different like top. Like he went to his own like wheelhouse, right? He didn't want to address exactly what the Glober was saying, right?
Yeah, he does that a lot.
He needs to
And
hang
if
out
he
with
gets a
us a
bit
bit more.
stumped, he goes into like a script. He'll say one of the weak scripted answers and then like laugh and mock and ridicule until that person goes away. And he does the whole if it's not two mediums, there's no such thing as refraction thing as well, because I guess he heard certain flat earthers say that once upon a time.
He was
But I think
dumped
he
on
does a
by the
pretty good
FED
job.
crew, unfortunately, so he stopped hanging out over there. And then I think we were a bit harsh with him when he came here, and so he just kind of left and did his own thing.
Yeah, he does pretty decent on TikTok.
John
Yeah.
Luna, who used to hang out here, is good friends with him and was an entree into that, but I think we alienated him too. So
Yeah. Well, these
Yeah, no, I'm
guys
not
are
saying
all
anything he did was
clinging
like
onto
that.
the AE map. They're all clinging onto the AE map still. So
that's a
what can you
big
do?
point. Them and the Aether Cogdician people.
It was your list, actually.
Yeah, it was my
That scared
list.
some of these
Right.
people.
It was my list, and before that, it was the Dr. Heffron Celestial Theodolite review that I've done. Completely crapped over that, but you know what? They can have it as far as I'm concerned because they're not one of us. Yeah, I mean, like, and today it's even more like it's evolved. Now it's like the dual pole whatever system by E1.
which is another projected globe. It's like, where's this going, guys? I mean, every time you bring up like Walter Bislin / Shane's, projection, you're bringing up globes. If you're bringing up the E1 dual pole system, you're bringing up a globe. If you're bringing up celestial theodolites, where Dr. Heffron himself claims parallel rays, you're bringing up a globe.
Yep. But I don't think that the globe side necessarily gets to to just own the way that we see the sky either, because on a flat Earth, I mean, we're still seeing the sky like this, imaginary. Well, no, it's not imaginary, but we're seeing this perspective view of the sky that makes it look like a big dome in the sky. And they've kind of taken that and turned it into a sphere and then inverted that sphere onto the ground. And then they say, oh, this is reality, guys. And it just looks flat because of refraction when you test it.
Yeah, good point.
Knowledge, you want to come back and talk GPS systems? I'm here.
Real quick, correct me if I'm wrong, but I thought the self-theo was basically showing the globe they're wrong by using their ways, right? So it was like not necessarily saying those things are true, but they have to be true for the globe to work. And then they were showing why it didn't add up when you look
Yeah,
into
well,
it.
so here's the thing. Here's the thing about that. They did not have a first off, they did not take a real world observation from on top of Mountain Peak in Colorado. What they did was they used stellarium to simulate a real world observation, and then they compared that to a real world observation. And they concluded that the angle to a star at a very specific, precise point in time, down to the second, was the same for a ground observer as it was for a mountain peak observer almost 60 miles away.
But wouldn't that be a way to cut out the ability to claim refraction? Wouldn't that be the only way? Because it doesn't matter.
No. First off, the angle they claimed was the same between these two observers. But here's the problem with that. There's supposed to be 1 degree of angular change for 69 miles. What they presented was data, one of them synthetic from stellarium, one of them real, showing the same angle to a star, separated by almost 60 miles.
To my knowledge, they took that into account because, like, as the star gets closer to the horizon, right, the 1 degree per 69 miles kind of goes out the window, right?
It definitely goes out the window. So in both cases, observers observed the star at 2 degrees. Was it like 31 arc minutes? 2 degrees, 31 arc minutes. Let me give you an idea what that represents. That's like taking 2 fingers and holding them out at arm's length in front of you. Okay, you got your middle finger and index finger on your right arm, right hand, holding out in front of you. That's about maybe 3 or 4 degrees. That angular width is what they're working with.
That's the difference from what the globe claims, or what?
No. This is what they're working with. They measured a star only 2 degrees, 31 arc minutes up from the horizon. The problem is anything below about 15 degrees in angular height is subject to massive corrections due to the flattening effect that we observe on the horizon.
call it refraction. I hate to call it that, but whatever, it's distortion. They're looking through the narrowest, most turbulent layer of air within that tiny 2-finger width away from your eye on the horizon. They're using elevation angles so low that all the manuals, surveying manuals, celestial navigation manuals, all say don't go below 15 degrees because you're going to get massive distortions.
Yeah.
But they're relying on observations within 3 degrees instead of 15 to 20. Second off, the second observation point in this was not a real observation. It was a synthetic one derived from stellarium. And what they do is they go into stellarium and they take the refraction checker on and off, and they toggle it on and off. They're doing this in place of a real world observation.
Yeah, but
well, hold on. If their conclusions are true, then it means there's no angular degree of inclination with respect to distance traveled over the Earth.
No angular degree of declination
or inclination with respect to distance traveled, because you had two people separated by almost 60 miles of distance with no angular change to the star at the same exact precise time.
Isn't the whole point that once it's occluded by the mountain, that refraction is no longer taken into account, because it doesn't matter that it's so low in the sky, because once it becomes occluded, then that all the effects of refraction are out. So it was directly at that time.
Yeah, so already we're accounting for that. Already, if there's supposed to be 1 degree of change per 69 miles of distance covered, absent of any refraction, then how come they have 0 degrees of angular change instead of 1 degree for almost 60 miles of distance covered?
My understanding, and it could be wrong, is because of exactly what I just said, right? They were trying to take refraction out of it, so they wouldn't have to account for that.
We've already taken refraction out of it.
They wouldn't have to account for the degree of angle change, because once it's occluded, that's the arc minute, right, and arc second that they take. Once that's occluded, the degree of angle change, it doesn't matter.
So they're throwing either hundreds and hundreds of years of astronomical observations under the bus. No, they're either throwing 2,000 plus years of astronomical observations under the bus, or their methodology is corrupt.
Yeah, I'm not disagreeing.
Absent of any refraction, there's going to be displacement of a star's position with respect to your position on Earth, flat or globe. They did not present that.
Do you agree that the Earth isn't flat?
Oh, hold on. When Dr. Heffron was confronted with this, he said, well, I believe there are parallel rays from astronomical sightings onto a flat surface. Well, if that's the case, then rest in peace, parallax. It means you can't use stars to navigate.
I never heard him say that, and I would have to.
Great. I've got 2 clips of him saying that, and I can post them in the side chat.
I believe you. I just, and to my understanding, I don't have the understanding how that would ruin parallax for celestial navigation.
I'll tell you how. If you have parallel rays to everywhere on a flat surface, it means there's no angular change by Euclidean geometry, because all rays are parallel to each other with regards to a flat surface that intersects them. And if there's no angular change, there's no parallax. If there's no parallax, there's no distance that's able to be discerned
from one position to another.
Did you hit him with that, and what was his response?
Yes, I did. So this team came to me before Dr. Heffron went public and asked me for my input. This was about 1.5 years ago, almost 2 years ago, actually. So about 1.5 years ago. I gave them this exact assessment and said, the consequences of what Dr. Heffron is claiming are parallel raised to a flat surface, which is incongruent with observation. And there are about 4 or 5 other points I presented too, which, I'm kind of covering here obliquely. They ignored me and went ahead with pushing Dr. Heffron out in front of the community along with his observations. So I responded with an academic paper that I wrote addressing his points, which they published, and then they moved the goalposts on with their rebuttal on their Aether Cosmology Obsidian page. And then I got a couple clips of Dr. Heffron talking to McToon, explaining that there have to be parallel rays to a flat surface for this to work, which is a complete contradiction to what we actually observe in real life.
Thank you. I'll have to look over the Obsidian page where you posted that academic paper and
Great.
read their
I'll
response to it.
post my paper. I'll post my updated paper, which they didn't even publish because I produced another paper in response to their goalpost moving. Let me go find that.
But then they wouldn't even address that response to their response.
Look at bloody globes. There's no water on those desk things. It says liquid on it, dude. Where'd you get that from? I gotta see this. Can you send me the link? I want to buy one. I want to take it apart. Where's your sister sauce? You gonna answer me or not?
Sorry, hold on. I have to find it. Give me a few minutes. I'm on a new phone and got new directory structure.
Not
So hold
you.
on.
Another one down.
There's so many of you. You're also unbelievably stupid.
Wow.
Isn't it funny? People that, not all, but many people that come on their Xboxes and PlayStations are just brain rot morons.
Well,
I
dude,
don't know,
all
man.
they
You're the
have
one that believes
is
the
their
Earth is flat.
Xbox and PlayStation. They might even have space games. They're probably playing a space game. What's the chance?
Oh my
Dude,
God,
are you playing a
space is
space
mine.
game?
Oh my
Are
God,
you
I haven't
playing a
seen it. They're just made up space so
Dude,
they
are
can
you
get
playing
money
a
from
space
us. Oh
game
my
right
God.
now? Are you playing a
Those
space
satellites
game?
aren't real. They made it up so they can get money
Are
from
you
us.
playing a space game right now?
Playing Roblox or some little kid game.
Ooh, is that what you like to do?
Those pedos. I mean,
Walk around.
PDFLs.
You guys walking around holding hands?
He ran away.
Yeah, I was kind of new to the flat Earth awakening, and I had been playing Star Citizen, and I bought some ships on there. They weren't cheap, and it kind of, ruined my enjoyment for that game when I figured out
Yeah, see, Flat Earth
it's pretty
saved you
funny.
money.
The
Actually,
propaganda.
it saved you money, actually.
Yeah, and time.
It sure does that.
All right, Amphibious, I tagged you. I think this is it.
Thanks, brother. I have to hit the road right now. I got to make an appointment, but I'll definitely read that. I will bookmark it.
Okay, cool. I mean, I could read it for the audience too here while everybody's listening.
Yeah, would you be
This is
able
the draft.
to? Would you be able to just give a brief of like your first response, right? Your first academic paper, and then their response to it, because right, this is the third kind of iteration of this is the response to their response, right? To your first
Yeah,
academic paper.
sure. So basically, what they came up with initially that I responded to was something I called the Heffron Delta. The Heffron Delta was a scaling factor. It was basically the god of the gaps, a value that could be inserted that can scale independently whether or not Earth is flat or a globe, depending on the timing of occlusion of the star by a distant object. So I attacked this point and called it arbitrary. The arbitrary delta was empirically unsupported because it was a coping mechanism, and it revealed basically the weakness of their methodology. The second point that I'd argued was their misuse of stellarium, their reliance on a tool which was rooted in spherical geometry, which was misinterpreted as evidence for their side. And third was their neglect of recognizing actual atmospheric distortion, which they had initially blamed on the lenses of theodolites in the first place. That third point has since had the goalposts moved several times. And the Heffron Delta has also been updated. That's it. I mean, that's really all there was to it.
And then what was their response? When you say they updated Heffron Delta, what do you mean by that? What did they do?
They said that they no longer use that anymore. They said that they don't need it. And they also said that the reliance on theodolite lensing as an explanation was also not needed anymore. What they've done is they used AI to backfit their observations by using any means necessary. And they're still using Stellarium as an FE simulator. So basically what they're doing is they're negating real world observations entirely in place of simulated observations using software that is also known to be wrong, software that was actually updated when observers during a recent eclipse had noted that the occlusion points of the eclipse and their timing was also off, and so Stellarium had to update their software to reflect that. So they're using software that is a toy, that is a hobby, and it's not based on precise astronomical observations in order to supplement what should be real-world observations they should have taken. But they didn't because, I mean, nobody wants to climb Pikes Peak in the middle of winter to take an angular measurement to a star. I get that. But the overall geometry is also bereft of any rigor because what they're proposing is parallel light to a flat Earth, when the whole reason for why people who believe in a globe believe an angular displacement over distance is due to parallel light over a curving surface. The curving surface is what gives rise to the parallax effect, why traveling over the curving surface increases or decreases the star's declination in your point of view, depending on your direction of travel. Now, when you have a flat surface and you have parallel light, the light source does not increase or decrease in angular declination or elevation based off of your distance traveled because it's parallel. Dr. Heffron twice claimed that that had to be the case for his model to work, which completely creates an incongruous model with reality, as well as a contradictory model with regards to Euclidean geometry. And that's what I argued in my paper, as well as the rebuttal. I asked for an audience in front of Dr. Heffron. They wouldn't put him through to me. And this is what they get. They get basically the shit end of the stick that I have to wield in front of them. And what I think is also ugly is I've got tons of backchat conversations. I'm not going to share them, but I'm going to summarize basically what happened. Over several months of discussions, they told me that, well, we are glad that we finally have a mainstream scientist on our side who can support what we've been saying all along. And if what we put in front of him was what you're telling us now, he might not come out in favor of our cosmology. In other words, they were willing to put this man, he's an older man with real experience. I don't doubt his expertise. They're willing to put him in front of the world in order to have an appeal to credentials. And they're willing to sacrifice the integrity of his observations and his conclusions in order to have that on their side. And what they've created was basically a very embarrassing moment for this man, his career and his legacy, which is something that I was hoping to help save them from. Now, thankfully, this work did not reach very far, so his integrity and legacy is preserved and rather relegated to a very narrow niche of the internet culture. But if it were to start to develop into something big, it would definitely cause embarrassment of untold proportions. And I think what they were doing, they were motivated basically by an appeal to authority. So they're willing to take this man and throw his life work under the bus and to cover up for the mistakes rather than address them academically and privately in order to get something out there that supports the FE cosmology. That's what happened. So, yeah, in fact, let me go through right now. I've got my directory up. I'm going to post some further information on this. Okay.
Yeah, I would have loved to hear about this, about what you bring up, like during their multiple theodolite review that they have.
Yeah,
But
what
that
are
was
they
on
on?
their
Version number 40 now? Like version 46? Because they keep moving the goalposts because it was broken from the get-go? Listen, they originally called this a celestial theodolite. And one of the models that Dr. Heffron produced was a measuring device used for stellar objects. And one of the things that they tried to use against me in my critique of this was to say there's no such thing as a celestial theodolite. We just called it a theodolite because we were using it for the stars. We said celestial. I'm like, that's not true. There are actual objects, there are actual devices called celestial theodolites. And I posted a couple examples of them. Used by the National Geospatial Intelligence Agency, used by astronomers, used by surveyors. And in fact, the celestial theodolite also has a nickname called the broken theodolite. Broken because the optical piece is actually to 90 degrees from a typical theodolite. A typical theodolite is basically a telescope. It's above a table with an alt-az gimbal on it. But what they do is they take that telescope, they use a reflector, and they bend the light 90 degrees to the eye so that the observer can be seated and look straight up at the stars with it, not have to crane their neck over for long amounts of time. Because let me tell you what, in the field, when you're observing stars and taking precise measurements, we're talking arc seconds of precision. You need to be in a very comfortable position. Otherwise, you're not going to be able to see the crosshairs. You're going to be bumping the optical device. You're going to be moving it around. It's going to be very, very frustrating. And so building it for comfort, they bent or broke the theodolite optic by adding that 90-degree reflector. And that was called the celestial theodolite. But they make fun of me today for this, saying there's no such thing. And I'm like, guys, there absolutely is such a thing. Right. So I'm going to go through here and find this information. I literally got a new phone like this weekend, and I'm going through the directories right now trying to pull this crap up. All right, so here we go. I think I called it Celestial.
Do you trust your phone? Do you trust it?
Absolutely not. I don't trust my phone.
Oh, why
Do you
not?
trust your phone?
Yeah, it gives me the time and locations and stuff like that. Tells
Yeah.
me
Why
where
do you
things
trust
are.
that? Why do you trust that?
Because it works.
How do you know it works?
Because when I punch in an address, it takes me to that location.
Yeah, is it working in an optimal way? Is it working to the best of the ability of it? Or could it be even more optimal than the way it's working?
Why do you have it if you don't trust it? It makes no sense.
I trust it because it works, but I don't make any claims to the degree at which it's successful at working. What do you say to that?
You check the time on it?
Yeah, I mean, the time tells me whatever time that it's grabbing it from. I assume the Naval Observatory's atomic clock. What do you think?
Is it correct?
I don't know if it's correct, but I'll use it. Doesn't mean I think it's correct.
Would it be incorrect if we didn't account for time dilation from the satellite it operates or the cell phone tower that gets the information from the GPS?
Why would I have to do that?
Because it would be inaccurate. Your cell phone wouldn't
How do you
work.
know? To what degree is it going to be inaccurate? And how do you know that?
Because we know that time ticks faster up in space. Like the GPS satellite has to be accounted for that.
That's what you're saying, but how do you know that's true?
Because I showed you the experiment in the side chat.
What experiment was that?
The one with the atomic clocks.
Oh, the one that I refuted with A.G. Kelly's Scientific American article. That one?
You didn't refute it because you're using your cell phone. It works
No,
perfectly.
I refuted it by posting excerpts from A.G.
Cell
Kelly's
phone
article.
would never function if Einstein's theories were incorrect. It would not work at all.
Did
Do
you
you think
even
cell
read?
phones operate over satellite?
The cell phone tower gets it from the GPS, yeah, from locations data. In
Oh,
time,
location data. No, we're talking about information transmission. None of this requires location data from a satellite.
but you said that you agree that the time you trust the time on it.
Yeah, it has nothing that has to do with the U.S. Naval Observatory's atomic clock, which is broadcast by radio.
You sure?
Yeah, I am sure. I can give you the frequency that it's broadcasted on if you want.
Your clock on your cell phone, it would be inaccurate if it didn't account for time dilation.
Yeah, you keep saying that. How inaccurate, and how do you know that's true?
Because it works.
Yeah, but to what degree is it working? I keep asking you that, and you keep going
You're
in
using it,
circles.
aren't you?
I am, yeah, but that doesn't attest to the degree of accuracy.
Okay. Do you understand the difference? If Einstein's wrong, your cell phone doesn't work at all.
You
It
keep
has
saying that, but you're not substantiating your argument. I'm asking to what degree of inaccuracy, and you keep
time and
repeating yourself.
location on your phone. Like we know this, right? Like it would be like the information on your phone would be completely wrong.
All right, guys. So it's 7 minutes past the hour. I posted 2 clips of Dr. Heffron saying that he needs parallel light to a flat surface for his argument to work. And this is why the entire celestial theodolite observation is destroyed from his own claim. What do you think of that knowledge? I just took down a major flurf argument from the other half of this community. Yeah, this guy thinks time dilation is happening.
Yes, yes.
You know what? And even if it is, it doesn't prove your cosmology is correct. You know, I'm willing to challenge time dilation and also be wrong and still know that even if I'm wrong, it doesn't mean that your cosmology is correct. What do you think of that?
I still want to know if he still claims to be a pilot or if he was just lying about that.
Yeah, you know, let's go back to that. Yeah, how do you become a pilot? Knowledge. How do you do that? Can you walk me through what you did? Just very broadly. I don't need a lot of details.
Did you just make an
What made
elf
you want to
noise
become a
as a
pilot?
response?
Yeah, what made you want to become a pilot? Knowledge. What was it that did it?
I enjoy it, but this is getting like too close to home for me.
Really?
Yeah.
Why is that? Right. Because
Uh,
I'm asking you, like, what entices you
I
to
made
become
him
a
like
pilot?
the job and like home, and man, I don't know you, dude.
You're not going to dox
Or
yourself by
listen,
telling us what kind of license you have or what you fly.
Right.
Fucking
you know what got hey knowledge? I'll tell you what got me interested in ground school was the fact that my dad was a pilot.
You
Maybe
didn't
your
go to
dad was a
school, bud.
pilot too.
You're a currently online guy. You didn't go to school.
Wait, you didn't
Lying
go
to
to
me.
ground school? Ground school's a prerequisite, dude. You
You
didn't
did
know
not
that?
go to school. Okay, stop lying
No,
to me.
I went to ground school.
No,
I
you
didn't
didn't.
come
You're
out
a
with an
currently
airman
online
certificate because I
guy.
didn't listen,
You're a
I didn't
flat earther.
complete my training. I did not receive my airman
You did not
certificate.
go to school.
But I
Okay, you're an
I
unemployed
completed
person on
ground school and
disability in the politics.
I got hours in a Cessna
No, you
152.
don't.
Yes, yes, I
Did you just
do.
ignore
Like,
everything they taught you?
I went through ground schooling. And guess
Then
what? I can tell you what got me
why
through
are
ground
you in?
schooling. I can go into detail about this without doxing myself. You know what I did? I actually joined the Civil Air Patrol when I was a preteen and stuck through it when I was a teenager
No, you
through high
didn't.
school. And yes, I did. And that's what got me into ground school. I also started my radio operator's permit through that. And I did did a lot of crazy stuff at Civil Air Patrol. Do you know what Civil Air
I don't
Patrol
think you
even
did.
is?
Nah, I don't think you
Civil
did.
Air Patrol is an auxiliary of the U.S. Air Force. It's like Boy Scouts, but for
Ah,
kids who are interested in flying and search and rescue.
you can't fly, homie.
No, I can't. I don't have my airman certificate.
You
But I
never
seem to
went
know
to
more
school
about this than
because
you
then you
do, and
would
I never
understand what I
graduated.
told you
I never
earlier.
got through it. I never completed all the hours required.
Tell me what a two-dimensional manifold is. How do we take off from that? Tell me right now.
How do you take off from it? No, so you asked me two questions. What is a two-dimensional manifold, and how do you take off from it?
Tell.
What makes you think that Earth's surface is a two-dimensional manifold?
Huh? What's up?
What makes you think Earth's surface is a two-dimensional manifold?
What is a two-dimensional manifold? You should know.
Yeah,
You should know.
it's a surface whose position or coordinates on it can be expressed in two dimensions. You can use X and Y. Like the surface of a sphere, right? Surface of a sphere is two dimensions, isn't it? A sphere is a two-dimensional manifold. And what makes it interesting
How
is
did
it's
you
a
get off
looping
the
surface
ground? How did you get
Huh?
off the ground? Okay, the ground.
You're asking how an airplane works? I thought you were the
I'm
pilot.
asking you the surface of the Earth. Like, is it a run? Did you do a two-dimensional manifold is like a flat plane?
No, it's not actually.
If you say that it
It's
like
only a
if you
flat
use it
plane when you put it in a three-dimensional embedding space.
if you use it as an analogy, like if you say that the your craft takes off from a two-dimensional manifold, enters into 3D space, and follows the geodesic, which you say the geodesic doesn't exist, then how are you navigating, dumbass? How are you navigating if you're not doing that? Like you're,
You can use
this
you
is a
can.
politics, sir.
I don't know what
You're
you're
a
talking about,
disabled
dude. Like, have you
person,
ever heard of
who's
plane
pretending
sailing
to
or?
know shit. You have a whole bunch of talking points copied
Holy
now, and
crap,
you're a
dude! How do you
moderator,
navigate?
motherfucker.
You can use your altitude and azimuth. Okay.
How are you getting from point A to point B? How are you doing that? Like we have waypoints in like the commercial industry, like right? There's waypoints. Those waypoints are what the geodesics are. Like right when we go like from waypoint to waypoint, like that's how we maximize our fuel efficiency and stuff like that in the commercial industry, right?
How do you know
Like
you
for the
maximize your fuel efficiency? By
because
taking points
the
that are not
geodesic,
maximal?
which is a straight line on a curved surface, the curvature of the Earth is the shortest path between 2 points. So if you want to travel the shortest possible so if I take like a route that's the shortest possible distance to my location, am I saving on fuel?
I don't know. Why don't you differentiate it from the alternative? Can you present that for us?
I would only do that for safety reasons.
So you can't demonstrate it for us.
Like I follow the geodesic when like there's not like
How do you
I'm
know
saying,
you're doing that? Differentiate it for us. You
how do
said
I
you're
know I'm doing
following
that?
this. Differentiate it from a
Because the Earth's
non-geodesic
surface
path.
is curved, dude.
Differentiate it from a non-geodesic.
The non-geodesic? Well, then you would just go on the two-dimensional manifold on the ground. Like,
Isn't that what you're doing, though? Isn't that
no,
what you said you're doing?
no, it's
No,
different on the ground.
no. It's different on the ground. I thought you believed in a curving surface in 3 dimensions.
Okay, but you're not. But on the
So
ground,
differentiate
it's
your
different
geodesic from a non-geodesic right now. Show us the measurements.
from point A to point B.
Yes, exactly.
Well, like the geodesic, like when you're up in the air, right? Since you're following the curvature,
How do you know you're doing that? You keep coming back to this.
how do
You
I know
keep
I'm
trying
doing
to
it?
put your conclusion into your premise. You keep trying to tell us that your claim is your evidence.
It's not a claim; it's the truth. I'm not.
How
This
do you
isn't
know
like
it's the
this isn't
truth? Prove
disputed.
it. Prove it.
I did.
No, you didn't. I keep asking you to prove it, and you keep giving me the
What?
claim as evidence.
You want me to prove it?
Yeah, that's
So I
why
go
we're
to the
here.
site.
Guess what?
So
The
I
second
have
you
to
do,
go get.
guess what, guys?
So I
I
have
will
to go get
promise
the.
you this. The second you do this, I will shut the server down and our entire community, and we go away forever.
You okay? You sure?
Yes.
So if I go
Go
get
ahead
a
and
source right now
differentiate. Yes, and I'll give you the
airline pilots
conditions.
follow a
Here are
geodesic,
the
you will.
conditions. You must
So
differentiate a geodesic path from a non-geodesic path.
you don't deviate, motherfucker. You only do that for safety reasons.
Okay, so why don't you
Like if
do it
there's
without safety
a
concern? Because
thunderstorm
that's
in
what
the
I asked you
way,
to
of
do.
course I'm going to deviate from the path. Okay,
How
we
do
don't
you know you're
follow it.
deviating?
How do we know we're
How do you
deviating?
know you're deviating for safety purposes?
Because we're not following, like the curvature like to perfectly, right? When we're
How
at
do you know that? I know you keep saying this over and over like
how
a
do I know
broken
that?
record. I'm asking you to prove it.
Because I'm following the waypoints.
How do
Okay?
you know the waypoints are curved or aren't curved?
How do I know?
Yeah.
Because how do I know? Because the Earth is curved.
How do
That's
you
why.
know that? How do
How
you
do I
know?
know that?
You keep saying it again and again, dude. Can you get off of your broken record and prove it?
Why?
Because if you do, I'll shut down the
You have a
server.
disabled person who's a moderator trying to tell me how to fly a plane. You
Who's
said
that?
that you were in the air. You didn't even know what a two-dimensional manifold was. That was
I
funny.
do know what a two-dimensional manifold is.
No, you
Actually,
don't.
you don't.
No,
You
you don't.
have no idea what a manifold even is.
You don't.
What's a three-dimensional manifold?
Three-dimensional, it would be like the Earth. That's three-dimensional.
What makes it three-dimensional?
What makes you three-dimensional?
Volume. Listen, I know this is rolled off the surface of my tongue. You know what the difference between a sphere and a ball is? The existence of volume. Volume provided by the embedding space for the two-dimensional manifold. If you take a sphere is actually a two-dimension manifold, and you put that in a 3D embedding space by giving it volume, then the sphere becomes 3 dimensions. Yep. Yeah, a sphere without 3 dimensions is two-dimensional because you can express your coordinates on the surface of a sphere using x and y only.
Yeah.
Yep, two
Go on.
dimensions.
Go on.
You had the third dimension, you had volume, and now you can express your position 3 dimensions with respect to a
What's the
north-south
fourth
axis connecting
dimension
the poles
and
of the
fifth?
sphere. Hmm?
What's the fifth and fourth?
Those are beyond our ability to recognize. You know, we can describe them mathematically, but we can't intuitively understand. Or spatial dimensions. Or higher.
What would you say is more accurate, like a paper map or a GPS satellite system? Like when we're tracking, which we want to get from like our location, like at the shortest. What do you think is more accurate?
Depends. I mean, is a GPS system based off a paper map or not?
What if I did you know that those paper maps were always wrong? You know why that is?
Yeah, I know why all maps are wrong.
No, just the paper maps.
All maps are wrong. Yeah, all maps are wrong.
Not the GPS. The GPS takes the curvature of the Earth
What
into
makes
account.
how does it do that?
How does it do that? Well, that's easy.
And
Like how do you think it does it?
I'm asking you. You sound like an expert, so why don't you talk about it? Tell us how it does it.
I'm a pilot. I'm not an expert.
Well, why'd you bring it up if you're not an expert?
Because I know that the paper maps were always wrong because they're two-dimensional objects and they don't take the curvature of the Earth into account because you can't draw like the three-dimensional object which is what the Earth is, like you said, into a two-dimensional object. So there's going to be distortions there, right?
So you're telling me
So
latitude
if
and
I want to
longitude
go
is
from a
wrong on paper?
so like if you're on the ground, you use a paper map. I'm using GPS. I'm beating you every single time
How do you know that that's the case, though? How do you know which one is correct?
because I know the Earth has curvature and the GPS incorporates that into it.
Well, you can accommodate that on a two-dimensional map using a non-uniform scale, and now
No, you
they're the
can't.
same. So how do you know which one is more
No, you
accurate?
can't.
Yes, you can use a
You can't
non-uniform
fit a
scale. A
three-dimensional
non-uniform
object.
scale is how you account for it. It's how you
There's
account
going to
for
be
yes, it's how you account
distortion.
for a spherical coordinate reference system
You
on two
can't put
dimensions. Use
like
a
a
non-uniform
three-dimensional
scale.
object like the Earth into a two-dimensional object, which is a
Have
flat
you ever
piece of
heard of a
paper.
non-uniform scale before?
Have you ever heard that you're
Have
an
you ever
idiot?
heard of a non-uniform scale before? Be honest.
Non-uniform scale. It doesn't matter.
It does matter. Maps use them all the time. You seem to be an expert on maps. Surprised you don't know
Okay,
about
hold on.
non-uniform scales.
Well, let's Google it. Let's see. Let's see if you're right. So if I Google this right now, it's not going to say that like maps aren't distorted, like the paper maps.
I never claim maps are not distorted.
Wait a minute. You said you'd shut the server down if I can prove that pilots navigate a geodesic. That's quite easy.
No,
We
I
follow
said
what they
you
call
can
like the
shut it
great
down
like
if you can differentiate a geodesic from a
we all follow the
non-geodesic.
great circle.
You listen.
Route.
You seem to have a learning disability because I said you can. We will shut the server down if you can differentiate non-geodesic from a geodesic distance. In reality, go for it.
What?
I'm sorry. Did I speak German?
What do you mean distance? What are you talking about? What distance are you talking about?
The distance covered by 2 coordinates.
A geodesic is just the shortest path between 2 points. You keep asking
2
me for like
coordinates. Yeah, yeah,
distance,
yeah. 2 coordinates.
dumbass.
Yeah. How do you know it's the shortest path? Differentiated from a linear path.
Because it's a straight line.
How? Yeah. How do you do that?
How do you do that?
How do you differentiate it?
How do you differentiate? Yeah, because it's topology and like the curvature.
And like so as like
You do it. You tell me how you do it.
I didn't make the claim. This is your homework.
You said
It's your
that you
burden to
fly.
prove, dude.
You said that you were what did you say? You were in the Air Force? How do you do
No,
it?
no. I said I was in Civil Air Patrol as a teenager, and I learned how to fly, and I never got my airman certificate.
You learned how to fly?
Yeah.
You
And a
were
Cessna
flying?
152 and a 172.
You're a liar.
And I also told the audience my dad was a pilot too.
You told the audience your dad was a pilot?
Yeah, I did. You may have missed that, and that's what actually got me interested in this in the first place. Because when I asked you what got you interested, you said it might
Told
dox
me
yourself,
that you
and I
don't
said, okay,
navigate
well,
using
guess
the
what? I'll give you a
geodesic.
personal story that won't dox myself.
I don't give a
My
shit
dad is
about
a
your personal
pilot.
story. I
Listen, and
know
that
that
got
you're
me
lying
interested
to
in
me.
flying because I used to
You
fly with him all
can't
the time when I was a little
navigate
boy. So it was great.
airline routes or any route you go to without the geodesic.
How do you know that's true, though? We're back to that. How do you differentiate that between what is not geodesic?
You mention it.
I'm asking you to help me understand what a geodesic is in reference to a non-geodesic. Differentiate them.
A non-geodesic?
Yeah, show me what happens when you don't follow a geodesic path.
What happens? You wouldn't be following a straight line.
Prove it.
Okay, we can do that. Hold on.
And how do you convince the audience that you're a pilot? What's one thing you could say that would totally like seal the deal? Because the audience is wondering if you're a liar.
Nobody cares.
No, the audience
Man,
cares. That's why they want you to do this.
who cares, dude?
The audience cares.
Your audience is fucking retarded like you.
Just say if you're a
Man,
pilot or
boy.
not. Just say yes, I am a pilot, or no, I'm not a pilot.
Like you're a disabled person in the politics server. Okay, everybody knows the server's a joke, right?
Why are you here then? Because you're a joke?
Because you entertain me.
You're entertaining me. Listen, we got
I'm
a
here to
worldwide
laugh at
audience on
you.
multiple live streams right now. And
That's
we're
cool.
clipping this, man. This is freaking
So,
entertaining.
so this is honestly the only reason I was asking you, because I think it will be a funny title if you say that you are a pilot, which you already did. So I'm going to add it to the title, right? I just wanted to know because when I clip
I don't
this,
care. Nobody
right,
watches your videos.
I
You're a
can I
joke.
think it'll be a more interesting title if I knew what
I
type of
think it'd be
pilot
more
you are,
interesting
so whether you're commercial or not.
if, like me, who's
Right.
also
So I'm going to
I flatter
DM you
to
the
you.
clip after I upload it to social media. I sent you a DM. And you could share it with your friends and families and ask them to judge whether you
My
did
friends
well or
and
not.
families. I don't.
You don't have any friends or family? Oh, okay.
My friends are family. What?
Yeah, yeah. Let's say, look, I look how good I
don't have
did in
any
this
friends.
debate against flat earthers.
Blah 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 blah.
You didn't even understand what I said. I said you can DM it to your friends and family after we clip it, so you can show them how well you did against us today, and how silly you made the flat earthers look.
How silly I made you look.
Yeah, in your own mind.
I was just having fun.
So, well, that'd be a first.
You think I'd take you seriously?
You've been in here for hours just getting wrecked on every single point, starting
got
with the
wrecked.
lake test to every single test. Yeah, look, the
I
audience
got
is going
wrecked.
to be the judge. Yeah, so your clip's going to
Who
get
cares
shared
about
all
your
over
audience?
social
Your
media,
audience is
and the
you already
audience in the comment section can be
This
the
would be like a
judge.
Trump supporter saying me. The audience, like, no one gives a shit. You're dumber than a Trump supporter.
Oh
That's how
my gosh,
stupid
he's
you are.
so mad. Listen how mad he is.
Yeah, I think he's been well and truly broken. Another
Yeah.
broken Glober.
He can't walk straight anymore.
He's super
Dude,
emotional
he was
too.
choking. He was choking on bong hits earlier. He's like, I'm choking on smoke.
You can hear
um,
the emotion controlling his mind. He
So
can't
let's go
control
back
his
to
emotions.
GPS. Hey, knowledge. Hey, knowledge.
your
Since you have
mouth,
GPS so
retard.
much, let me ask you a question. Like,
Nobody
have you ever
cares
looked at a
about GPS.
Rhinex message from GPS before?
Have you ever looked at a Rhinex message?
Yeah, I have. Have you ever looked at a Rhinex message? What does it look like?
Nope. But you're a liar, though.
Why am I a
I won't
liar?
talk to you anymore.
I'm sorry. Okay. What coordinate reference system do
You
GPS
bored me.
satellites use? I can tell
Who
you.
cares?
Well, I care
Who
because I
cares?
like GPS systems.
Who cares?
Do you know who manages the backbone of the GPS systems?
Me.
No, it's the U.S. Air Force out of Schriever Air Force Base, actually. They use an encrypted
If you're a
network.
disabled person on disability, as a
Definitely not
moderator,
disabled, man.
yes, you
I'm
are.
quite very much able. But even if I was
No, you're
disabled,
not.
why would it matter to you? Because what? You're an ableist? Are you a freaking bigot?
No, I just don't like Discord moderators
Yeah.
lying to
What's
me.
going to happen when you get old when you get like Alzheimer's and dementia? Are you going to be making fun of
Maybe
people
you
who are
can.
disabled then? Like, is that just how you roll? Because you're an asshole? You know?
No, but you're lying to me, so you deserve it.
How am I lying to you? What did I lie about?
You said you went to school and college.
Yeah, I did actually. I got 2 advanced
Really?
degrees.
Really?
Yeah, I do. Yep. Yep.
No, you don't.
What makes you think that?
Did you just ignore everything they taught you about, just about physics and like mathematics, or did you just?
No,
How did
actually,
you?
I critically examined what they taught me.
Really? So you got all the answers correct.
No, I just critically examined what they taught me. You know, nobody's going to get everything correct. I mean, duh.
You critically examined everything they taught you.
Yeah, that's right. That's why I believe what I do and I know what I do. It's because of that. Because I have a mind.
A flat earther has a mind. Just like the
Yeah, what are
vaccine
you a
denier
bigot
was
now?
claiming they
Yeah,
have a
what
mind.
does it offend you that somebody has a different thought than you?
Does
Like, come on, dude.
do you believe vaccines? Do you
It has nothing to do with the topic.
But you're in the same category of these people.
No, I'm not. That's a wholly different
Yes, you
topic. What
are.
do you mean this is the same topic?
You
We're
are
talking
just as
geometry.
bad as the
Listen,
vaccine
we're talking
denier.
geometry. What does that have to do with
You're a flat
medicine?
earther.
Yeah, we're talking geometry. Flat has to do with geometry. What does that have to do with medicine?
Nobody cares about that.
Medicine? Well, you do. You brought it up as an objection.
Homie, like you're acting like this is serious. That's your whole problem. You're funny.
Maybe it's not serious.
For
Maybe
all
you're
you know,
acting
I
like
could be a
it's serious and you're
multi-millionaire
triggered.
trolling. For all you know, I could
Why
be a
are we
multi-millionaire
talking
right
to
now
the?
triggering you. Just
Why
playing
are we
around.
talking to this guy? Like he's a horrible
I could
glober.
be
He
the
doesn't
biggest
even.
whale in the world
I
right
know. There's
now with an
nobody else to talk
audience
to,
10
Peter.
times bigger than you.
It's been slim pickings.
I
I feel
know,
like
but
I'm
it's
picking a
like I
scab.
think
How do you know you're not being trolled by a YouTuber?
I think you've
I feel like I'm
exhausted
picking a
this.
wart.
Yeah, we've
Seriously, let's
exhausted
have
this
some
one.
respect.
All right. Good point, Peter. All right, knowledge. Thank you for the content. I will DM you the clip once it's done. All right. Thanks for playing. You're done for the day.
I mean, the guy was such a poor troll. Like he doesn't even know the basics. You know, the surface of a sphere is two-dimensional. He goes like, "You're leaving the two-dimensional manifold," and then when asked, "Why wouldn't you go down the geodesic if you traveled on land?" he chokes.
I'm glad you caught that, Peter. That warms my heart.
Yeah, I mean
Welcome to the
that's like,
chat.
I mean, if I channel my past Glober, like I'd be so furious to have a champion like this, you know, who cannot even represent the globe model, whether it's true or not. I mean, Who are these guys? These guys are just. I mean, I respect a Glober that knows his model. You know what I'm saying? I disagree with the model being wrong, but you gotta represent it at least consistently. If you just walk in and say, it's just these college bros, man.
Wait. You believe in flat Earth? Does that also mean that the price of tea in China is too expensive?
Yeah, because of geodesics.
I like how
It's
he
called the
shifted back to
geodesic tax.
right.
You know, and just because you take a course on something, as I claimed I did, doesn't make me an expert either, and I still knew more than this guy.
Well, we know more about their model than they do. But listen, Yoder, just to be not to be a nerd, but isn't GPS technically maintained by Space Force?
Yeah, I guess nowadays it is. It used to be, I forgot which, an Air Force wing. But yeah, Space Force does it now.
I think Globers forget that like flat earthers were Globers. We probably know the globe model better than they do, and we actually asked questions.
Well, yeah, we were all Globers, but also to become a flat earther, you have to look really closely into the globe model, right? Most people don't do that because they got better stuff to do. So we are, we're not average people to happen to become flat earthers. We're people who looked at the globe model very carefully and then found reasons to reject it. Most Globers haven't looked at the globe model. They didn't feel the need to do so.
Yeah, and then the anti-flat earthers, when you mention critical thinking, it kind of like baffles them. They're like, "How- critical thinking?
Don't you believe everything that people tell you?
That's what his response was when Yoder was like, yeah, I critically thought throughout my education. He's like, so you cheated? Or something like that. Oh, I laughed out loud.
You really can't make this stuff up.
You know what they say, life writes the best comedy. Yoder, I actually had a question for you. So Dr. Heffron assumes parallel light rays?
Yeah, it's one of the things I came to the conclusion of before he admitted it on McToon's interviews. Would you like to see the interviews? I clipped them and posted them in side chat, and I'll replying at you. Give me a second.
Sure, I'm not gonna look at them now. I'm busy, but that cannot be true though, because with parallel light rays on flat Earth, you would never see any motion of the stars. They would always be in the
Exactly.
same spot.
Exactly.
So So how would they? A star wouldn't get occluded by anything because it would just sit there in one position. Everywhere would be ground position.
Correct. There'd be no way to navigate. Period. End of story. Here, I replied and I added you. It's quite interesting. The clips are a little long, maybe about 30 seconds to a minute each, but you'll hear it in both cases. And it captured exactly what I wrote about in my paper that I addressed to him, not by name because I wanted to leave his name out of it, but posted the papers too. You know, these guys from the Aether Cosmology came to me, like I was saying, about a year and a half ago and asked me my input on this. And I told them exactly what I've been telling everybody now. I looked at the evidence. I'm like, yeah, you got parallel rays to a flat surface. You're also doing observations from within 3 degrees of the horizon, which is fraught with all kinds of astronomical or atmospheric distortions, rather. You know, and then one of your points of observation that you're comparing to in real life happens to be in stellarium. So you're not even using a real life observation compared to reality. So they're like, those are the 3 biggest issues I have with this.
Yeah, but those other issues you're listing, they pale in comparison with what I'm in so
Yes.
much disbelief that I suspect maybe there's a misunderstanding because again, if consider the model, if the Earth is flat and rays are parallel, then the sun, for example, would be in ground position everywhere. Everyone would have sun in zenith. You know,
Peter,
like in
let me show
Africa.
you directly from Dr. Heffron himself. I'll show you
Right,
a
but let me
diagram.
finish my thought. Furthermore, if all stars were parallel rays over flat Earth, they would all appear to be in the same spot. There'd be no angle to different stars.
Yep, that's the big one. So here it is, 50.7 kilometers difference between point A and B, and the same angle to the star at the same time.
He cannot mean that. We must have misunderstood. That'd be insane.
This is all over his paperwork. It's in his own write-ups he's done. This is everywhere, and he says it himself on the 2 clips that I posted. I know it's that bad. It is that bad. I've been telling these folks it was that bad before they went public with it, and they went public with it anyway, and it's even worse now. I'm like, oh my gosh, they're like, if we could have set up a private conversation like I had asked to between all of us, this could have been cleared up ahead of time. But they said that they were more interested in putting out Dr. Heffron in front of the community as one of us than they were in correcting his mistakes, because they feared that he would pull back from us if he had done so. And I said, well, then you're just using him. You're manipulating him for your own selfish purposes.
But in
And
this
you know what,
diagram
Peter?
you
That's
just
exactly
showed,
what they did.
in this diagram you showed, there are no parallel rays. The little star has a rays at different angles.
It's 2 degrees, 31 arc minutes in both cases, as they said in the paper, 2 degrees and 31 arc minutes.
No, but look at the line, right? Like there's a line that shows a ground position, you know, perpendicular to the surface, and there's a line to the observer, which is not perpendicular. So these are not parallel rays from the star.
Yes, they are. The second position is just elevated with respect to the other. Do you understand in air celestial navigation, the Air Force teaches this? It doesn't matter what elevation you are, that the star will remain at the same angle, whether you're at 0 degrees elevation or 0 feet
Right,
elevation
because
or
rays are
35,000 feet.
parallel. Because rays are parallel.
Yes.
On the globe model, the only cause for the angle to a celestial body that's far enough, like sun and beyond, is the tilt of the Earth, not the tilt of the Earth, but your angle due to curvature.
What I'm presenting you is from his own diagram showing 50.7 kilometers of distance at the same time separated.
The height is irrelevant.
I understand, but there's a line, like look at the top left corner of the diagram. That's a little star, right? It has a line going down, perpendicular to the surface, and it
Yeah,
has a
theta
line
F
going
is the
to the
same.
observer. And then it has a line going to the observer, right, at an angle. That's not the parallel, like a glober would not draw a star like this.
I know that. I know a glober wouldn't draw a star like that.
Because a glober would
That's the
draw
problem.
parallel
That's the
lines
problem.
falling on the surface.
Yeah, I know a glober wouldn't draw a flat surface, dude.
No, it doesn't matter. Oh my goodness. A glober, there are two different parts of this. One is what is the surface of the Earth, flat or curving? The other one is, are celestial bodies far enough that for all intents and purposes we can assume parallel rays? Those are two different things, right? You could have a globe with the sun very close and then rays wouldn't be parallel. They're not parallel from the moon because the moon's too close in the globe model. Like the moon being 230,000 miles away and the Earth being whatever it is in miles. Why do I do this to myself? In miles. Whatever in diameter in miles. Those are close enough numbers that you can detect angle differences. Even with the sun, we detect half a degree of an angle difference. In the globe model, they admit it. There's a half a degree difference on the edges of the sphere. So if a glober were to draw a flat Earth with parallel rays, that is not what they would draw. It's not what you have in this image. They would ridicule flat Earth and say, oh, look, the star would be in ground position everywhere on the
Yeah,
surface of the
exactly.
Earth. But
Listen
that's
to
not what he
Dr.
drew.
Heffron yourself. Huh?
That's not
That's
what
what
he
Dr.
drew. I
Heffron
assume
drew.
that
That's what
drawing is
Dr. Heffron, Peter, that's what Dr. Heffron drew.
okay, show me that drawing that has parallel like
I
this.
just did. That's what I showed you.
Or the nth time in that diagram, there are no parallel rays from the sun, from the star.
The star should appear at a higher elevation angle when you're 50.7 kilometers closer to it at the same time. And that's not what they depicted here. And Dr. Heffron says it's not what he's saying either. He says they should be parallel. And furthermore, like I said, he used stellarium. So
Okay, let me. I'm only asking you this because I want to get to the bottom of this one. The bottom right part of the diagram, where the triangle. I always forget the word. Vertex of the triangle, I guess. Right? Bottom right. Is that the observer?
that's observer 1, yes. And observer 2 is at
Okay.
Pike Peak, 50.7 kilometers away.
All right, don't worry about observer 2. Why is observer 1 looking at a star at an angle other than looking straight up?
I don't know, because it's not later in the night.
In the model where light rays are parallel, the full meaning of that is the object is so far away that when you look at it, there's no parallax as you travel over the Earth to the object.
Well,
So
there is, and it's the hold on. In the globe model, there is parallax due to the curvature of the Earth changing your angle.
I understand, but again, try to reason over two things separately. Flat Earth, parallel rays. What does that mean? It means that the object is so far from the flat surface that no matter where you are on that surface, you're looking straight up. Because if you move 1,000 miles here, 10,000 miles there, it makes no difference if the object is trillions of miles away. It's not
Right. Or
discernible.
50.7 kilometers here, 50.7 kilometers there. It makes no difference, as the
Right,
diagram
right.
shows.
So a flat Earth with parallel rays has the star in zenith everywhere on Earth. That's the joke, right? That Globers make about flat Earth when they forget that we don't believe that objects are so far away. So,
or we don't believe that objects are even objects that could be triangulated.
let's leave that for later. So basically, what he drew there is not bad, is what I'm saying. Because when you were talking about this, that Heffron claims parallel rays, I imagine this globe radical with a flat Earth and parallel rays. But that's all what his diagram shows, so he must mean something else. We misunderstood him.
No, he didn't say that in his interview with McToon 2 times, like I posted.
I'm not questioning your report on the words that he uttered in the interview. I'm looking at the diagram, and if it came from him, then it doesn't show parallel rays.
Yes, it does, because it's going to be 2 degrees 31 arc minutes at the surface as it would be on Pikes Peak.
Dude,
if you're to
the
take an
black
elevator
line,
from Pikes Peak down to the bottom of Pikes Peak and could look through the mountain itself, it would still be 2 degrees 31 flat or globe.
bottom right of the diagram, I'm staring at it right now. There's
Okay.
a theta g angle of 2 degrees and 4 minutes. Yes?
Yeah, that's not what he's referring to. The actual observation was 2 degrees 31 arc minutes.
Okay, fine. Theta f then. So that line, the black line extending with the blue line, right?
Yeah.
That's the line of sight from the observer to the star. Yes?
Right.
How are the light rays from the star parallel?
Because
Don't you see this?
listen. If because he moved 50.7 kilometers towards it and it didn't raise in elevation.
What?
Because in the real world, if you move vertically, stars do not change in elevation.
Fuck.
Again, sorry, I was looking at something else. This, the two statements, Dr. Heffron considers light rays from celestial bodies to be parallel in this drawing are in direct contradiction.
Truth, by proxy, we can hear you, but we can't hear anything you're saying.
Sorry, guys, I'll mute.
Hello.
What's up, buddy?
There's no one talking.
We're waiting for you.
Well, yeah, I agree. The Earth is flat. I have nothing to argue about.
These mutes only last 40 minutes.
So knowledge, one test,
I have a
right?
headache.
One long distance observation. I would have a headache if I were you too. It's been rough.
Oh, shit.
Are you still knocking down the bong hits or what, Mr. Pilot?
I think I'm out of it.
Yeah. Okay.
Listen, I could function earlier. I was doing math in the side server. I'm fucked.
Okay. I'll leave you alone.
No, we can still have fun. This is the only time you're ever gonna beat me when I'm high.
Oh, well, were you not high earlier? Because that was pretty easy.
I probably. When I talked about the neutrinos, I was with Doctor in the side, but then I got fucked up.
You were gonna prove the globe, but then you got high. Pilots even allowed to get high like that? Get off their head? I don't know.
Are we entertaining the same guy again?
Yeah.
Huh. At least you didn't ask me to calculate distance with a geodesic, which you don't. Not without a location.
There's another guy
funny.
that comes in here called the Perfect Storm. You kind of remind me of him.
Bro,
Is he
no
rich?
offense, but for a Glober, like, these guys know me. I used to be a hardcore Glober.
Who is that?
This is Peter, the critical thinker. Listen,
Are you a Glover?
I used to be, but for a Glober, your performance was very, very poor. I don't mean it from a position of a flat earther that you're wrong, the Earth is not a sphere. I'm gonna channel my inner Glober that's suppressed deep inside my soul. You performed really poorly on behalf of the globe.
Ah. No fair.
It's very fair. I say
Oh,
this with love. I
I can
just need you
still
to know
type in
that.
the side chat. I can still see the keyboard. You know, it's like 3 of it.
Right now, guys, talking to this guy is just being kind of it's a form of abuse. I think we
It's
should put
like
him on mute for his own sake.
right. It's like stoner abuse or something. All right, you can go on mute. I clipped your conversation that you had recently, Peter, and replayed it in the stream today. I thought it was amusing about the neutrinos. You were comparing it to their dark matter argument. It was funny.
I mean, it's analogous, right?
Yeah,
It's
yeah, completely. Well, the part that I found funny was when you had him explaining to you how, you know, you're just making up unknown things to explain the mathematics, and he didn't get that.
right.
That's
But I don't know if you got the fact that I wasn't trying to use that as a flex. It was more like, for example, for a second, Steelman the globe position, right, and lambda CDM. Their position is this: we measure the Earth to be a sphere. That's what they think. We measure that mass attracts mass, and furthermore, Einstein equations. That's confirmed. That's measured. Now we look at the movement of the galaxies and we measure them, and it doesn't add up, right?
Mm-hmm.
That's their thing. So we have all these measurements and confirmations, and then there's a big hole, and we can't explain. The simplest logical explanation is that there's some form of source of gravity, call it matter, right? Proverbially, just to simplify, that is not visible. And we don't know what it is, right? So basically, that's the crutch to take individual things that have been measured that don't add up and say, okay, there's something we don't know, call it dark matter. All right, until we know what it is, it's this big unknown. And that's what science does very often. Now, we could use the same, like you cannot deny us doing the same. We measure that it's flat. We measure that neutrinos behave certain ways, if we accept that for a second. And so the logical conclusion is there's some form of matter that reflects neutrinos. But when we do that, he goes like, "Whoa, you can't be doing that." Yes, we can.
Yeah, exactly. That was good way to to tackle that.
Who is this truth by proxy guy?
I'm just a guy out here in the flat world.
Oh, okay. For me, it was the understanding of perspective and the non-globe explanation for why things disappear bottom up, or to be more precise, why I can be looking at a building roughly 20 miles away. The building is much taller than I am, but it's below my eye level when I look at it. That never added up for me. Like I used to use that as a globe proof, right? That the only way to explain why a building that's 200 feet tall and I am at 50 feet, let's say, appears below my eye level. Because I was just thinking purely geometrically, if you drew a triangle, 50, 50, 200, then no matter how far away I am, the top of the building would always be above eye level, like if even ever so slightly. but the measurements, the observations we have show it below eye level. So how can that be, right? My go-to was the curvature of the Earth, and the building is tilting away from me, and because of that tilt, it's underneath below eye level. But that's because I didn't understand perspective, how it works optically.
Yeah, thanks. I was just curious. I always like to hear how people came to it. You know, same for me basically. And once I made an observation across along a large lake here in Minnesota, I came to the same conclusion. So
So just to be clear, the observations didn't change for me because I still know the observations. I don't question them about those buildings and other objects. It's just that the explanation, the conclusion has changed.
gotcha.
See, for me, I kind of spent like 2 years almost, I think, arguing with these guys here on the next. So I have seen all the stuff, right? I have seen all the observations, the black swans, the skunk bays, all of that stuff. So it wasn't like I discovered something new and went like, aha, that's the one. It was more like, oh, there's an alternative way to think about it.
Yeah, thank you for sharing. And I think sometimes it's important for whoever new Globers or whatever people come in here to maybe hear a story here and there about how one of us came to, uh, being a flat earther. Although it usually comes down to the fact that we just see too far. So
Yeah, we do see too far.
Well, I'm going to move over to English Hub where I can create an event because I think we've used up all the globies in here over the last couple of days.
I shall follow you there.
See a couple new people in here. Anybody in here think they live on a spinning ball in the middle of nothing? Go ahead. Guess we have no globe believers, or at least none that want to speak up and defend the globe. Back to UAI or whoever else was talking.
Hey, speaking of fake pictures, is it possible to get someone to have a fake picture without actually showing them an image of anything? Like, for example, a picture in their mind. So they're imagining what they would be seeing or could be seeing or what something is without actually ever having seen it.
Can you repeat that? Because you're throwing very difficult questions at us today. They require a lot of thinking. I was distracted. What was that?
Like what, a woman's love?
No. So if you show someone a photograph, that's an image to look at, and they can either be convinced or not convinced that what they're looking at it represents something real. But can't you also do that to somebody with words, to where they create an image in their mind and they think they saw the thing?
Yes, in fact that's how people used to exist for millennia before the invention of realistic painting and realistic sketching, and then later photographs.
That's what they
Right?
do in books, right?
Yeah, and even before books, through oral history, and people had very colorful depictions of things that happened or didn't happen, and they built entire cultures and on that. So absolutely yes.
That being said, what are some examples of that going on that exist in the flat Earth, globe Earth discussion?
Exoplanets.
I mean, anything in the globe model, anything, when you think about the inside of the Earth, its structure, that's, nobody's seen that. When
Yeah,
you
Paradise
try to
picture, right?
even reasoning about the universe on a scale relatively tiny, which is what they call the solar system, requires a lot of imagination. Even to imagine how the planets are oriented against one another, at what angles, which way they spin, and whatnot. Then, the edges of the solar system get really murky. And anything beyond that, it's no one can really visualize it. Even if you look at the photographs from the space telescopes, or I should say images, they requires a lot of imagination to read into what they represent, right? Because the detail of what we're told is not in there necessarily for human eye to consume.
That's a good
Another
point. So,
example of that AI would be the 360-degree ice wall. People have probably imagined that, even I have. It supposedly goes
Okay, yeah.
around, but nobody knows that.
Yeah, and they might tell you, but they also might show you a picture of an ice cliff, right? Like in the field of view of the camera, and then they'll show you another one. And they'll say this ice wall cliff goes all the way around the Earth, and in order for you to see that,
The picture.
yeah, you create that in your mind.
The globe. No, it's the same thing. Light bending around a ball.
Balls
I know
attracting
what you're
balls.
saying. So you're saying You're saying, can they create something without them actually showing you a depiction of what they mean? Like, and well, yeah, do it all the time, but we're going to have a different picture of it. Each and every person's going to have a different picture of a description, right? If it's
Right.
only a
Then if you wanted
description.
to, correct, but then if you wanted to manifest a visual image of that thing, right, you would have to kind of rest on that collective idea within enough tolerance to where if you showed the image, you'd be like, this is that idea that you have in your mind. Yeah, of course. You follow what I mean there?
You got to share it with someone, right? And they said, oh, I kind of depicted it in this way. And you start adding things together. Come up with a consensus, right?
Right, but what I mean is eventually you have to have someone, let's just say, is the official version of this collective idea that everyone can see in their mind. And so they hire or they work on a team or whatever of, let's just call them artists, who are going to realize this mental image into reality and then show you what it looks like, the picture or a model. Okay, so
And then you
one such
get a lot of people
individual.
saying, oh, I didn't imagine it like that, right?
Yes and
oh,
yes
yeah,
and
that
no,
makes
but
sense.
the thing is, you have to when you're doing that, you have to work within the collective congruence, you know. So, for example, you got NASA's artist Robert Simmons saying, "I edited blue marble towards expectations," right? And
Where
so
did
he
the
has to have
expectations
some.
come from?
That's right. He has to have some kind of knowledge of the body of expectations.
Yeah, because the expectation didn't come from the public. They was told the expectations. We expect you to make a picture like this.
Another such artist was Matthew Boylan, who later changed his name for the public to Math Powerland and went on a tour telling people, hey, all these worlds that you think are worlds, they're paintings. None of these photographs exist. These are all paintings. I know because I painted most of them. You know, you've never seen Centauri Prime as a lush world of ice storms and, you know, diamonds raining sideways. I just painted that. That doesn't exist anywhere but in your mind. So in relevance to DJ's challenge for the day, it's like, how would you know they're faking space or telling you the truth? Where's your reference that you could say, this is my expectation or this is valid? Like you're just being shown images that confirm your expectations, and you're like, well, of course that's true, even though you, from your vantage point, have no way of telling. And DJ can prove that by showing you images, and you cannot tell which ones are fake and which ones. Even NASA Mission Control is on record saying that they can't tell the difference between a simulation and the real mission. They're virtually indistinguishable, to where if they had to testify that was a real mission or fake mission, they wouldn't know the difference.
that Math Powerland presentation was quite funny too. Enjoyed it. Peter, are you there?
Yes, I am.
Look, I find it really hard to believe, like that you went from a glober to, well, can we call you a flat earther or just a non-glober?
I identify myself as a flat earther, but I take it as the default that many of you guys will now believe me because of how awesome of a glober I used to be. Like I said to AI earlier, I am humbly rating myself as in the top 3 of all globers of all time, back in my, the peak of my globe activities. And
It's humbly,
so,
yeah.
yeah, so humbly, yes, top 3, which leaves some room, for
For
humility.
someone to convince you that it is a globe.
No. What I'm saying is top 3 means I could be third. That's the humble part. But so I know I totally and also on top of this, I retain a lot of the physics that many flat earthers disagree with. Right? I'm full in on many things. I'll just be honest with you. All of quantum mechanics and standard model of particle physics. I think the moon is a rock. That's in the sky. I think we landed on the moon. 7 different nations, some with humans, some without. I think we landed on Mars. I think we travel vast distances above the Earth. So I know it's a tough sell to say I'm a flat earther, but I decided to only let go of the parts that I have evidence and proof that are false and retain everything else. I don't go with this, oh, if they lied about one thing, they're lying about everything, because I don't think there's any boundary to how far you can take that. So I decided to be a minimalist and I let go of one thing at a time. How about that?
So where are these planets? And are they the same distance away as what they tell us, or?
They're in the sky above the Earth.
Yeah.
And I don't know about all the distances, but one that I will stand by is the moon is 200 and whatever thousand miles away.
And that's because of the because of the laser reflections time.
Right, I think exactly. I'm not going to invoke the landings because I like to do the minimal. So the things that person can verify from the surface of the Earth without $1 million budget is that a radio or any electromagnetic signal will bounce off the moon within around 2.6 seconds round trip, which tells you the distance.
Yeah. Okay. Fair enough.
I got a
I was
quick
really
question
surprised.
for you, Peter. My mic's working. Sorry, Timbo.
No, go ahead, Dave.
Looking back on your globe proving career, what was your best globe argument, Peter, in your opinion?
My go-to globe argument, which I thought was the best because it argued what we all want to see, which is the measurement of the curvature. I had a slide deck, I still have it. I used to argue it in politics, against the top guys here, heretics. Some of them are no longer with us, right? And I don't mean they departed the earth, but they don't participate. Heretic, Miggy, Indio, Jedi, AI Overlord, was the measurement. I used other people's measurements to argue that the reason why a tall building appears below eye level at a distance is because of the curvature of the Earth. I thought that was the measurement. I had the math for it. I had the angles, the distances, and the mathematical argument that it matches the claimed radius. And that I thought was the master, the ultimate globe proof, we used to call it, right? As globe gangsters, the ultimate globe proof. The interpretation of it, I know, was incorrect because I missed the whole concept of perspective. But that was my go-to, right? Like that's what I see. These are the angles. These are the distances, perfectly consistent with the radius.
Good answer, I guess. Just so you finally realized that they didn't prove anything, right? Is that what you said?
That's right.
How would you explain that shot now? How would you explain that image now?
I think it's because of the perspective that an object that's taller than you appears below you. It's the perspective of the observer, and the mechanics in optics that causes that.
Yeah, just perspective. Or?
Well, it's not the surface. The surface is flat. So if it were for no optical phenomena like perspective, you would expect a building taller than you to always be above eye level, like even if by a fraction with the increasing distance. You would never expect it to be below because, like I used to say to a lot of you guys, like triangles don't flip, right? When you extend the base of a triangle, it doesn't cause it to flip upside down at one point.
Yeah.
It just flattens, right? It flattens, but never tips over, so to speak. So it's the optics and the perspective that makes you see it this way, but it's not really that way.
Hello everyone.
Hello. Welcome.
I'm new here.
How are you?
I'm doing good. What about you?
Oh, good. Early Tuesday morning, on my way to work. But I
You
jump in
sound
and chat.
so good. Like I like your accent.
Oh, yeah. Australian accent sounds good.
It is. I like it. You sound surprised. Why?
Yeah, it's a first. Kind of sounds like a, I don't know, like a horn or something, doesn't it?
No. I'm just trying like to be less awkward. I'm trying to practice my English.
Oh, you mean the inflection?
Exactly.
Yeah. I try not to use it that much.
What is your native language, my good friend?
It's Arabic. Algerian.
What?
It's Arabic. I'm from Algeria.
Oh, I see. So the Algerian, you probably speak a local
French,
dialect, and then you use classical Arabic for writing and formal communications, right?
Exactly. How do you know that?
I know a lot about languages, and that's, by the way, how it used to be in Europe too, right? People used formal Latin for written communications, and then vernacular, kind of vulgar Latin, which became, French, Spanish, Portuguese, other
That's true.
languages. So it's a very common occurrence.
We use a mix between Arabic and French. It's called the Darja.
Yeah.
Can you spell that?
D-A-R-G-A.
Oh, thank you.
And I'm sure if you were to talk to someone from Saudi Arabia and the way you talk without using the formal Arabic, they would have a very hard time understanding you, right?
Exactly. But the thing is, like, I can understand their dialect.
Right, because they speak the formal version. Or close to it.
It's a little bit, yeah, close to it. That's it.
Yeah, and
But for us,
that
it's like
language would
completely changed.
be that language would be in your religion too, right?
Yeah. Islam.
Yeah.
I'll give
Which
you
is, by the way,
7,000 points in the Flat Earth merch. Tell me what those languages are called in the class.
Say that again. You
Sorry?
cut out.
The languages that Peter just described, they're in a class. You can tell me what it's called. You get 7,000 points in the Flat Earth merch.
Romance language.
Oh, you win.
by the way, this dynamic where the language in which the scripture is written being used as the formal communications language, that's exactly what happened in Christianity, right? Western Christians used Latin, biblical Latin, obviously the translation from Greek and from Hebrew, but as base. And when Newton was talking to Leibniz over letters, they wrote those in Latin, like Principia Mathematica is written in Latin, in like scriptural Latin as the formal language. But then, of course, in daily interactions, they wouldn't use those languages. That language, they would use their local or the most popular European language to converse. They didn't converse in Latin. They couldn't speak it very well, like pronounce it. There was no common pronunciation, but they just used it as a writing system all over Europe, even with languages that are not Romance languages. I'm sure some Persians, for example, where Farsi has nothing to do with Arabic, but they probably are able to communicate in written Arabic if they're especially like religious scholars.
Wasn't Farsi a mix of all the tribal languages?
I think Farsi is an Indo-European language, right?
Is it?
It's closer to English than it is to Arabic.
I think it's the opposite, no? Closer to Arabic than it's closer to Arabic than to English. Farsi
No.
language.
No, Farsi belongs to the Indo-European family, and Arabic does not. Yeah, it's in the Iranian branch of the Indo-Iranian subdivision of the Indo-European languages, so it's more similar to German and Hindu than it is to Arabic. Arabic is it's in its own league with Hebrew, Aramaic, Amharic from Ethiopia, like Semitic languages. It's a completely different family.
Hey, Brother Peter, can I ask you something?
Absolutely.
How can I learn these stuff? Like I want to learn, but I don't have the resources.
YouTube, my friend. Go on YouTube and look for channels dedicated to languages, but not like the good ones.
You share some for me, with me.
I will give you a really good video on how almost all alphabets and writing systems on Earth originate from the same place, including Arabic and Latin.
Yes, please.
Enlighten me. Where do they come from? Where does the alphabet come from?
They all come from Egyptian hieroglyphs.
That's interesting.
Which were basically stolen as in a good meaning of the word as a technology. They were taken by please let's not talk about what that word means, by Jewish immigrants to Egypt, and they were brought into the area that we would call Palestine and that whole part of the world there, and they were repurposed to write a completely different set of languages using the characters that were originally the pictograms that the Egyptians used. Because it was such a successful technology, right? Hey, these guys can visualize sounds. Let's use that to visualize our language, which has nothing to do with the other one. But the sounds, you know, there's an S, there's an A, there's a B, there's a V. So let's use the same pictographs to just describe the first letter of that sound, and let's write our language with it. And then everybody stole it from them. The Phoenicians, the Greeks, the Romans, the Vikings, everybody just stole it and modified it slightly. So
What
I'm
were
posting it.
what were Sumerians using before that?
That was actually I don't know if that line died out. I'm not that. I think it may have died out, that technology. So like nobody copied that.
Yeah.
I think that's the story.
Oh.
Check this out. There are no sounds in a picture, right?
That's well. Let's think about it. So basically, the Egyptians would have a pictogram, kind of like Chinese do, for let's say a bird, right? And in their language, the bird, I'm making this up, would be floblob, right? Floblob. So the Jews just said floblob just makes no sense to us. But the fact that it starts with F, right, is what we're going to use.
Right.
So now we're going to use the sign for a bird just to depict the letter F. So it becomes an alphabet where symbols don't represent words, they represent sounds. So F is a bird. Why is it? We don't know. Just because it used to, you know, stupid Egyptians.
Right, it's a convention.
Call it floblob. In our language, bird is bird, nothing to do with F, but, you know, we just use it for F.
So the point you, but the point you keyed in on is that you can change the association, right? But keep one of the conventions, so you can have an infinite.
That's the genius of it. Yeah.
Right.
And as a software engineer,
that,
I really appreciate that someone came up with this idea.
Right, and you are correct in calling it. That's exactly what it is. A lot of people don't think about it. They just take language for granted, right? They think language is just natural; it just happens. No, it's a technology.
Well, to be pedantic, this is about writing systems, not the language, right? Any language can be written. English could be written using Cyrillic very easily. It looks funny, but if you know Cyrillic, you can read it the same way. So to me, this was one of the biggest like technological discovery. How can we generalize the writing system to be useful for any language, including languages that have nothing to do with each other? Like Phoenician language was Semitic, like Arabic and Hebrew, and the Greeks directly stole the concept of the alphabet from Phoenicians for Greek, which is an Indo-European language, so a completely different category. But they just followed the same pattern, right?
Right. So then you have the tokens and the sound associations, but then you also have the tokens and the meaning associated. Sounds and the tokens are meant to convey the same meaning, so you can associate the sound with the token and the meaning. Now I'll give another person 10,000 Flat Earth Store credits if they can tell me what study of that is called.
Phonetics.
Wrong. I think
Ask
Peter
it again.
knows.
But I didn't understand your question.
The study of the process.
Yeah, so you have tokens, written, physical, visual, or auditory that are associated with a meaning, and then you convey them between the two. So if I have this sound, which represented by this graphic, that means that this graphic represents that sound. But the meaning associated with it is added in separately. Like the thing itself doesn't have them. So when you're creating that system of conveying meaning and studying how you attribute meaning to tokens, there's a whole field of study about that.
What's it called?
And that field is called. Well, you have to win. You have to win the prize.
No. I don't care about prizes. I just want information.
Okay. It's called semiotics.
Semiotics.
say.
All right, you win the prize. Oh my goodness.
Sorry, there's a lag. I said it before you did, but it's just the lag came in.
Yeah, whatever, Neil. No relation to symbiotic?
Interesting. I don't think so. I think symbiotic is relationships between biological organisms.
Yeah. Well, the relationship part's right. It's just a different.
However, you can create a symbiosis representation and hijack it to create meanings inside people's minds that don't actually exist.
So
much like a fake photograph. Yes, brother. Much like a fake photograph that's showing you something that doesn't exist. You can create meanings with words that are fake that can create assumed realities in a person's mind. So you can forge reality or interpretations of reality with audio visual, and you could do it with languages too, whether spoken or written. In other words, you can make someone believe something's real by showing them a picture of it or telling them a story about it, and then they create the picture in their mind and they close.
I think your headphones are going flat. Every fifth word cuts out.
Oh dang! But anyway, you got the point.
Yeah. That's what the globe does.
Like gravity is a great example of that, isn't it?
Yes.
In this community.
Well, you can't. Oh, you can draw a picture of it, kind of. No, you can draw a picture of the effect of it, right?
So, for example, people say, "What is gravity?" Drop a pen, and they think when they see a pen drop in their mind, they see that pen not traveling to the floor of their room straight down. They see that pen floating in an infinite cosmic void, moving towards a giant space ball.
So, Peter, you got a language background, but you're a computer software engineer. But do you have a physics background as well, or?
The language, I don't have a background on other than the fact that I speak a couple of languages, but it's of interest to me. So I've watched a lot of YouTube stuff about languages, how they work and history of them. But yeah, computer stuff and some physics in college,
Is physics in, is there any type of physics in software engineering?
No, not in software engineering. There is quite a lot of physics in super low level design of computer components. But when you're a software engineer, you don't even care what the hardware is. You don't even know sometimes, right? That's the whole idea.
My dad was a software engineer at the start of computers, but I don't even know how to use a computer.
So was my mom.
So, yeah. I went into construction.
Dude, what's the purpose of language in any form?
Well, it's descriptive, right? Communication at its best.
Communication, if you think, it's an overloaded question, but if you think at the very beginnings, it's communication, right? Expressing danger, tiger.
Right.
In that sense, some
So
animals
what
have
is?
languages, right? Some animals
Oh,
have
absolutely.
communication systems.
Yeah, Like those monkeys, they have different noises for different animals.
So let's go even. What is communication? What's the purpose of communication?
To
Getting
relay
information.
information.
Okay. Yeah. Okay, but communicating the information, some people could argue it's just the same thing as communicating the language, because you have to understand the information. In order to understand the information, you have to understand convention of the token meaning association. So on a root level, if you study semiotics or the fundamental concepts, that it's actually conveyance of meaning. It's the meaning that actually, when it comes to communicating between minds. Now, systems, just brute information that results in a mechanical output, right? Like some people would say that's not real meaning, right? It's just ones and zeros acting out in like dominoes. So there's a little bit of tension there between like what is really being transmitted from the one to, is it the information or is it the meaning? But either way, you need to understand the convention. Like the method of communication has associations with the ones and the zeros, the triangles and the squares, the and the the little Osiris eye, and then the other person has to understand what those mean. Otherwise, giving the other person those tokens is meaningless. And the tokens themselves don't possess the meaning, because if they did, you would be able to read every language, right? There's actually an argument to be made that the presence of a language that can convey meaning is proof that language had to be initiated by a mind. So basically, all this stems from mind being preordinate to any of these processes that are in the natural world. So when you're shown an image, the alleged globe in space, it's not so much that you're looking at an object; you're looking at a conveyance of meaning, right? Which you were primed ahead of time to get a reaction out of since you were a child. Same thing with the dropping of the pen, right? And a lot of globers will confuse the description of what's actually happening, the explanation for why it's happening, and then assume that they're seeing the explanation. So you'll ask a glober, when have you ever seen an object
by gravity? Or when have you ever seen a ball attracting another object to it? They'll say, well, I dropped a pen, therefore I saw it.
Hello, everyone.
Yeah. Hello. Hello.
Yeah, hello.
What do you think of the room topic? Come on, use your words.
I wonder if that's what she does. She goes to every room and just says hello. And
Great example of non-communication. Did she dip out or? Any Globers? Yeah, bruh. Hey, bruh. Coda, you there?
I think I'm here, yeah. Do you copy?
Sí. Sí, señor. What do you think of the room topic?
What is the topic about? I just joined.
Oh, we were talking about language, but the room, what the room's called is 24/7 flat Earth.
Oh, Earth is rounded. Not flat.
Rounded.
Yeah, it's a sphere. It's not a flat.
In what way?
In what?
In what way?
Do you ever see football?
Yeah, but okay,
The American
let's.
football.
Right. So before photos, they said the Earth was a globe, right? Because we can both agree that you can manipulate images, right?
Manipulate images. Do you look at the moon?
Yeah, but the moon's not the Earth.
It's not flat, is it?
Well, could be a sphere, could be a circle, could be a projection, could be anything, right? But that's not
So
really
basically,
what
when we look
talking
at
about.
everything in the sky, either stars, or the stars, we cannot really see the shape. But for other, I don't know how to call them, for other planets, yeah.
Yeah.
You don't
And
see
what
them flat,
relation?
do you?
What relation do they have to the Earth?
Well, they are planets. Earth is planet.
Yeah, but how does that make the Earth round? Or
Because they are
spherical?
also round. You're a human, right? I'm a human. You're a human.
I hope so.
Do you have six arms?
No.
Okay, so we're both humans, and
Yeah, but
these are both planets.
But we can test that, right?
We can test it. Yeah.
Yeah, I can walk up to you, I can see that you don't have 6 arms, and I can touch your 2 arms, and I can go, he's got 2 arms.
Yep. Of course we can
Yeah.
test it. But let's imagine someone has joined the conversation and he is from China or
Yeah,
from Siberia
Chinese
or
people have
somewhere
2
really
arms
far.
as well.
Yeah, I understand. But can he also test that you have 2 arms? It's gonna take a long time, right? Maybe he doesn't have enough resources to reach you, right? And if you hop in a video call with him, he can say that, oh, it's image, it can be manipulated, correct?
What?
So right now, you think the Earth is flat because you don't have enough resources to prove it. Other people, or some people,
No,
have
we
proven
do.
that Earth is not flat, right? No, I'm talking about you personally.
Yeah, I've
Yeah.
proven to myself that
So,
the Earth is not a globe.
well, good for you then.
Yeah. How did you prove to yourself that Earth is a sphere?
I just look at the other planets, and since they are planets and Earth is planet, so it has to be a sphere.
How do you know that? But see, the second one, I know. So I know that things are spheres in the sky, and I know that Earth is a planet. How'd you get the second one?
How Earth is planet?
Yeah.
What else would it be?
No, that's not an answer.
What else would it be?
Could be anything, right?
Well,
You got to prove that
define
it's a
anything.
sphere.
Is it, I don't know, is it a cup?
You can.
Is it a jar? Is it, I don't know,
What else? Well,
a
what else
phone?
would it be?
Exactly, what else would it be? It's a planet.
Yeah. How do you
If
know
you
it's a
can think of
planet?
anything else, it would be. I know it's a planet.
Planet has curvature, right? In your mind.
Well, I
Or
know it's a planet, and the
how?
curvature, it
That's the
depends. It
question.
completely
How?
depends. How?
Yeah.
It is a planet. For me, it is a planet. That's you know, like when you say 1, 2, 3, that's for me 1, 2, 3. Earth is planet. 1, 2, 3. That's it. You cannot argue with me that one is not one. It could be anything
Okay, so you
else.
just say because I think Earth is a planet, then it's a planet, right?
It has to be a planet. It is a planet.
Okay,
For
so
me.
if it has to be a planet, then how did you confirm that it's a planet?
Bro, do you have a soul?
Don't stop asking me silly questions.
Because you're asking me silly questions too. So I'm just like
It's not
asking
really a
you.
silly. It's not really a silly question, though,
Just
is it?
because
Like,
something you cannot see it or you cannot confirm it physically or whatever your ways, whatever the ways that convince you, doesn't mean it doesn't exist, right?
okay, so you say Earth is a planet because you can't confirm it.
Earth is a planet because I cannot confirm it.
Yeah, that's what you just said.
Earth is a planet because everything else is a planet. Every planet is a planet. Why Earth would be different?
Okay, if you're in a forest and you walk around and all you can see is trees, does that make you a
Yeah,
tree?
I can see myself. I'm not a tree.
Ah, so you
Do
can
the
test
trees
yourself,
walk?
right?
Do the
So you can
trees
test
walk
it.
while
So you can,
hold on, while
so
I'm
you can,
walking?
so
Do the
you can
trees are walking?
physically test it, right?
Well, of course, I can physically test it, but also the trees
Yeah.
don't walk. I am walking, so I'm not a tree.
So you can physically test if the Earth is a sphere, right?
And you can physically test that the Earth is a sphere if you get on a rocket and you shoot yourself up to the moon. Why don't you do it?
That's the only way to do it.
Well, for me, that's the only way I do it, because I confirm visually.
The way you do
I'm
it.
not. I have no idea about physics. I didn't study physics. If you're trying to like say, oh, I confirm
so
it
it's
with time and some
like what we were
things that
doing
I don't
before. Like
understand.
someone
Like
presented you
I
with a
need your proof to
picture.
be dumb proof, you know. Your
So
argument
someone
has to be dumb proof.
okay.
I'm a
So someone
caveman.
presented you with a picture, and then now you have that picture in your mind, and you say, okay, that's where I live because this person told me that that's where I live.
Sure.
Okay.
Okay,
So
how's that gonna bother
you're in
you?
a religion.
Let's say you don't live there. Okay, you don't live there. You don't live on Earth. You live on something else that you haven't proven yet. What's that gonna change about your life?
It's not the question at hand.
Well, it's not the question, but basically, what's that gonna change about your life? I'm asking you a question.
Nothing, because we use the Earth as flat,
Exactly.
stationary, and
So
horizontal
Earth.
anyway,
So
right?
for all I care, Earth can be a cube, but I choose to believe Earth is a planet and it is a sphere. You choose to
Okay.
believe it's flat, and you're saying that you have proved it. Well,
So we've come to
if
the
that makes sense
conclusion
to
that
you,
you
then
just have a baseless belief that the Earth is a sphere.
a baseless belief.
Yeah.
Well, we came to the conclusion that this information doesn't change much about my life, and it doesn't matter much to me. If they say it's
Okay.
tomorrow, they say it's a flat, and we have discovered this, and they show a picture of flat Earth, I will say, yeah, maybe it's flat. But right now, it's not a flat to me.
Okay. Fair enough. Like a religious belief.
Yeah, I am a religious person.
Yeah. Globe. We're in the religion of globe.
Definitely. And I'm happy. I've never asked this question if is the Earth is flat or not. See, you should join the religion so you can end the debate in your head.
I was in it.
Yeah,
Get out of
seriously.
it.
Yeah, unless you enjoy the debate in your head, then that is different.
Yeah, I like truth though. So.
I like truth. Okay.
Yeah.
So, if Earth is flat, well, how does the sun?
Sun
How
is
can't we have
irrelevant to the shape of the
day?
surface.
Hold on. If Earth is flat, why don't we have all like just a day? Why it's day in USA and then it's night in China? Because we're all in the same level. We're flat. So if the light travels in a flat surface, that light will reach us all. Why it doesn't?
So the Earth, right. So the Earth measures to be flat. So whatever the sun's doing, it does on a flat surface.
How does it do that on a flat Earth?
It does it because it measures that way.
I think, yeah, I think the sun has two eyes, so it opens one eye per time, and it depends on which side of the flat Earth you're in. The sun either gives you the light or not. Probably, I don't know.
That doesn't make sense.
Well, it doesn't make sense either what you're saying, because if Earth is
What I'm
flat,
saying.
sun doesn't make sense to me. Yeah.
Okay, so if you measured the surface to be flat, would that mean the surface is flat?
What does that mean then?
Well, it's a simple question. You measure the surface to be flat. Does that mean the surface is flat?
All right. How do you imagine flat Earth? Can you send me a
You're going to
picture? Do you have
answer
a
it, or
picture of flat Earth?
you're going to answer the question?
I asked you a question, okay, and you did not answer me. But
Which one?
the way I imagine it, how Earth is flat, I want you to give me a picture that I can see, so I can understand what you're saying, right? If you have a picture that I can put in my head, that I can imagine it, that oh, this is flat Earth, this is how the sun works, this is how the moon works for Earth, right? Maybe I can understand what you're saying. But to me, right now, if I open a light source in my room and that light source is exposed to all the flat roof, every part of the roof or the floor will receive that light.
Make the
So
room bigger.
a room bigger. So you're
Yeah.
saying the sun is smaller. Okay. There's something special about the sun. You know what? You know what is it? What it is?
What?
It's the heat. It's the heat. You feel its heat, right?
Yep.
So no matter how big the room is, the light has to reach, because after all, we see the stars, and the stars are a million years away, right? But we see
We
them.
don't know
We see
that.
at least a flash of the star. We don't know that.
No.
Okay. So what are the stars then?
I'm not making a claim to that. I'm just saying you don't know how far away they are.
However, they are probably farther from the sun, because we see the sun bigger than the stars, right? They're far from the sun. Does that make sense?
Wait, brother, did you just agree? Did you just agree that the sun is in the earth?
Did I just agree? Is sun is where?
Well, you said we feel the heat from the sun.
Yeah, we do feel the heat.
Well, that could only happen if you had a conveyance, right? So you'd
So
have to
you
be in the
say it can
atmosphere
only
to
happen?
do
It
that.
can only happen if it is very close.
No. See, in the heliocentric view, there's a vacuum between us and the sun. So there's no heat coming
Yeah.
from the sun per se. The heat that we get from the sun comes from the radiation and the light that it's sending out. It's not the actual heat of the sun itself. So we don't actually feel the heat from the sun, sir, in your worldview, unless it's in the Earth's atmosphere.
I'm not following. I don't think it's in the Earth atmosphere, to be honest. But you can believe that.
Well, then how
It's
does the
up to
heat?
you.
How do you feel the heat then? How do you feel the sun then?
Because the sun is basically it's too big. It emits so much heat, not only for planet Earth but for the entire solar system. Basically, we are far, and we have a
Okay,
distance with like eight minute distance in
How
the
hot
speed
is
of
the sun?
light.
Okay, interesting. How
I
hot is
have
the
no
sun?
idea. I have to Google that. But what I'm saying is we have an
Okay,
8 minute
hold on. Let
difference
me
in the
Google
speed
it.
of light. Right.
How hot is the sun? Okay, hold on. The surface of the sun is 5,000. So are you trying to tell me that we feel 5,000 degrees Celsius?
5,000.
Yeah.
Wait.
So I'm sorry, what was your question? On the sun, it's 5,000 Celsius degrees. And we don't
Okay,
feel that
so
on Earth.
the core is 15 million Celsius degrees, and the surface 5.5 thousand Celsius degrees. And wait,
So what was the question again?
the information exists. So apparently we feel the heat because it emits electromagnetic radiation, right? That's why you feel it?
He's muted, I think.
Yeah. Well, that's what ChatGPT said, at least.
I didn't quite understand the question. Can you repeat me? Because I just entered this down.
Yeah, I know that the light of the sun and the light of like I don't know, a normal light with your flashlight or something, they are different. The difference is the light of the sun, it carries the heat with it. And I forgot what was the name of that.
But any light carries, I think.
Well, the question was, how does the sun prove the surface of the Earth is a globe?
And how does the sun prove the surface of the earth is flat?
We didn't make that claim. You made that claim. You keep on pointing to the
I
sky.
said the stars are far away, and you can still see the light coming from the stars. You said, how do you know, right?
Yeah, how do you know how far away they are?
Well, I know because they are so small comparing to the sun, and the sun is supposedly close to us, right?
Well, how do you
So
know
they
how
are
big they
smaller.
are?
Well, they look small to me, at least in the sky.
Yeah, they look small. So you're saying because they look
Yep.
small, they're far away. Then you'd have to know the size of them, right?
He's still in the same logical framework where he inherits these categories, right? That the sun and the stars are the same category of object. Therefore, the stars are supposed to be the same as the sun or bigger even, right? So he's working within all this. He's not getting that we're questioning all of that.
Yeah, he's just repeating what he's been told without actually knowing how they come to these conclusions.
How do you explain airplanes and
They fly.
traveling?
Airplanes traveling? They take off from an airport and then they land in another airport.
Yeah.
Yeah. Does that need a globe? Does that need a globe?
Well, if it's a flat, you say that it's a flat Earth.
Why would they lie? Why would they lie?
Yeah. So what's the relation between flying an airplane and a curving surface?
No, I'm wondering if it's flat, what's on the other side?
You're in space. No, we don't claim that the Earth is in space, right?
Okay. I'm curious. Can you tell me what do you think?
Well, the
Where
Earth
it
is
is?
all we know. The Earth is all we know, right?
Okay, let's say it like that.
Yeah, it's all we know. Earth is below us. That's all we know.
Okay, so when you fly an airplane in one direction,
Yep.
and you go straight, are you going to get in the same position when you started?
Well, you can't really do that, but if you're talking about east and west, it's hypothetically possible, right? Because you're flying around a northern magnetic point, so the compass always points north. So if your compass always points north, then you're going to fly around in a circle east and west.
Okay, so you go east,
Yep.
and people who are on that spot who saw you going on east,
Yep.
they later see you coming from west.
Yeah, you're floating around in a circle.
In a circle.
Yeah, it's the same on a globe.
Have you ever watched the SpaceX launch?
Yeah, on TV. Yeah.
Well, I usually watch it live on YouTube, but
Yeah. Yeah, it's on a
do you
screen.
see?
Okay. Yeah.
Yep, but
Yeah.
do you see the curve of the Earth while you're watching?
Yeah, they use different cameras.
Okay.
Yeah.
All right. Despite the camera, do you believe that there are satellites in the space?
There are things in the sky that relay information. Yep.
Well, I said satellites.
You could call them satellites. Right.
Okay. Well,
I don't think
they're
they're floating in the vacuum of. I don't think they're floating in the vacuum of space, though.
Do you think that
A lot of questions coming here and no conclusions to any of it.
We'll never reach a conclusion because it's a belief space. There is no proof. It's a belief way. There is no proof.
Yeah, I know. That's why I told you about
Yeah.
measuring the surface, right? That's
Well,
the only
me-
conclusion. Yeah, the only conclusion we're going to get to is if we measure the surface, because it's the only place we can go to, right? So if you measure
Well,
the Earth's
well,
surface to be curving, then you can have a globe. But if you measure it to be
here's the
flat,
thing.
then the surface is flat, right?
Here's the thing. If you want to prove or deny that Earth is flat, just go to the edge of, like when USA is connected with Russia on the eastern side and on the western side, right? And keep walking, keep walking. See where you're gonna go, where you're gonna end with it. You
Yeah,
return to the same place.
you'll
You
probably
just
just
make a
die.
tour. Well, I think you'll make a tour around the globe of planet Earth.
Yeah,
Right.
are we going
And
east or
I
west?
think a lot of people have tried it, and a
Are
lot
we
of people
going?
are convinced.
Are
But
we going?
you, sir,
Are we
if
going east
I
or west?
hold on, are you really looking for a proof? You really want to prove it to yourself, or you're just convinced that it's
I've
flat and
already
that's
done
it?
it. I've already done it. I measured the surface. That's what I told you. It's not curving.
You measured the surface of Earth.
Yeah.
How do you measure
yeah.
the surface?
Over a certain distance, there should be a certain drop, right?
What?
Over a certain distance, if the Earth is curving, then it should
Okay.
drop, right? So 10 miles,
It
66
should
feet
drop.
Yeah, the surface should curve down, right? Like a sphere
Okay.
from your position.
Okay. Yeah. I see what you're talking
Yeah.
about.
Yeah. So
Yeah.
if you
So
so
when you
go
look,
so place yourself
when you
over
see,
water. Hang on.
yeah,
You didn't let me explain. So if you
yeah, no,
take yourself
I
to
know what
the
you're gonna
if you
explain.
take yourself to the edge of the water, because water
Yeah.
conforms to the shape of the sphere, right?
Okay.
Yeah. So if you take that and then grab a laser, level it out from your position, then 10 miles away, that laser should be 66 feet in the air.
Okay.
I
Yeah.
think that's actually happening.
Yeah, I know. Yeah, and we measured it to be the leaving position. So we did this over 27 miles, and the laser left at 2.9 meters, and they picked it up at 1.7 meters on the other side of the lake, 27 miles. No drop over distance. That drop should have been
Are
about
they
300.
Are they sure the
about
surface
three.
is completely flat?
Yeah, water.
The
They did it
surface they
over a
measured
lake.
it.
Yeah, over a lake.
Water. Yeah.
But how do
Still,
you
water isn't completely
explain?
flat. It's gonna take the
Okay, so
shape that it's placed in.
yeah,
It's
it
not gonna
isn't.
be completely flat because basically, water is always pulled into the center where the gravity resides, right?
Yeah, so it should be curving, right?
It is gonna curve, yeah.
Yeah, okay. So
It's
we
gonna
did
curve. But
so we shot the laser over the water
you're not gonna see it
where it
because the
should be
curve is
curving.
really big. Mm-hmm.
Okay, so
But
we
when
shot the
ship,
water. Yeah, so
when ship
300
is
feet, it should be 300 feet in the air, and it wasn't because of
but
the
when
curving surface, right? The curving surface is supposed to be there over water, like you said, conforms to the shape of the ball due to gravity, right?
but the people's well, ship when is going um, away from you, he is slowly going down into water. It looks like that.
Looks like that sometimes.
No, how sometimes? Why sometimes?
Okay, so sometimes you say, all right, the ship disappears from the bottom up, right?
So you have ship, and it is going away from you.
Yeah.
Okay, and it looks like to you. I mean, I'm describing it.
Yeah.
The ship is falling into water.
Yeah, like it's going
Slowly.
down below a curve, right? Like that.
Yeah.
Yeah.
So
it doesn't happen all the time, though, does it?
when it's happening and when it's not.
Sometimes it happens and it looks like that, and then sometimes it doesn't happen.
Explain me why. Why sometimes it happens, sometimes not.
Well, it's optical, obviously optical, because if it was if it was a curve, and you're claiming the quotes disappear from the bottom up because of a curve, then it would happen every single time.
So you're saying that
At the same
Earth
place,
is.
because it would be a physical obstruction, right?
So you're saying Earth is actually globe. I mean curve.
No, I'm saying what you see is optical. So atmospheric conditions would dictate what you see.
No. I mean.
No. Okay.
No, it's.
So why does it change then? Does the Earth's size change?
Can you repeat the question?
So if you see it disappearing from the bottom up at a distance, and then you see it disappearing from the bottom up at a different distance, is that the Earth increasing in size and decreasing in size, or is it optical?
I mean, it depends. I mean, it does not depend. Earth is not a full globe. It's a little bit ellipsoid, something like that. So
Okay, would that
you're
change
saying
the
maybe
distance
that
in the
would.
same position?
I think that always curvy. I think that it's always equal that disappearing. Did you do some experiments that
So you think?
proves it
Okay, so you
opposite?
think that if you went to the same place every day, you would see the ship disappearing from the bottom up at the same position?
Yeah,
Yeah.
it always disappears in the same way.
All right. Let's have a look.
And also, I really wondered about that uh, airplane going in circles. I want you to explain me that.
So let's have a look at the chat.
Where?
You know where the chat is?
Oh, inside of the voice chat.
Yeah.
Okay.
The text chat.
Okay, I'm wondered about this in circles because it's hard for me to prove about this ship, and for you it's hard for you to prove me that this uh, this is real, this video and things like that.
Okay. So you're not going to accept that? That's all right. So you're not going to
It's
accept any of
hard to
the
explain. Honestly, it's hard to explain that ship. Let me just see this airplane.
hard for you to explain the ship, right? We can explain it.
No, because this video may be fake. I don't know if you took that from, I don't know, video edited video. Maybe you found it.
Okay. All right. So what would you accept then? Because you were talking about things. So can you show me Can you show me a ship disappearing at the same place every time then?
Oh, you can say that my video is edited if I send you.
All right. So we're not going to rely on.
You stopped. I didn't hear you.
Okay, so we're just going to throw images out the window.
No, this about the airplanes, it's more, you can explain it, you can imagine it. It's actually something that we can logically prove.
Okay, so go ahead. Go back
Let
to
me
airplanes.
just see this picture. So, Earth is, what is this picture? I'm sorry.
Do you have a picture that goes with what you're going to talk about with the airplanes?
Yeah, let me just find this picture. I'm not sure where this
I
appears.
have a question. Oh, this image is too big. Wait, I gotta
I don't
find
know
another
where
big
it
image.
disappeared. Okay, there it is. Uh, this picture that you sent is a globe, actually. I mean, Earth is a globe.
Take a look at this picture, sir. Take a look at this picture. So, according to you, if the sun, if Earth is flat, okay? So basically, a sunset is Earth is swallowing the sun, right? Because it's flat. There is no possible way for me to see part of the sun and not to see the rest of the sun if it's completely flat. Explain this to me. Hello?
They
Oh,
disappeared.
everyone is silent. Yeah. I think the Earth swallowed the sun somehow.
I mean, okay, but this airplane going in circles, it doesn't quite well land with me.
No, I want something that are that are dumb proof. You know, every dumb person can understand that level into the physics.
I mean, yeah, but it's their. They think that they lie to us, and that's the main reason why we're actually talking about this.
Oh man,
But I
I don't
really
think
don't know how to. And all these
there
things,
are.
these videos, they say that NASA is fake, and I can say that their videos are fake. But this about the airplanes and about explaining what's near Earth, what's are we going to fall from it? It doesn't land with me.
Well, hold on a second. Nobody here said any videos were fake.
Well, there's a guy that says in a chat he admits it can be faked, so that includes NASA.
Well, I
Yeah,
think you'd probably agree that, especially in this day and age, any video that you watch is subject to some scrutiny because of AI and computer graphics. And there's about a million different ways you could fake something, but that's not what we're talking about. We're talking about the Earth measuring to be flat.
Earth measuring to be flat.
Yep.
I'm sorry, I'm not familiar with that term.
So when people measure the Earth, it's always flat from point to point. There's no curve anywhere. So I don't have to talk about anybody faking any videos. If it measures to be flat, then it is flat. Kind of the end of the story, right?
Let me be clear. So if it's flat, are we going to fall from it on the edge?
Where would you fall to? What are you talking about? What edge?
No, he's saying if it's flat, we haven't reached the edge yet. Actually, it's like there are more. It's bigger than we think. If it's flat.
I don't know about
Like
any of
bigger.
that. Nobody claimed that either. Why would you claim that?
We didn't understand you. Explain to
Okay.
us what you
Explain to us
think.
what are you claiming? Flat Earth. Give us an image of your flat Earth, if you could.
No, there's no image. You just you see it every day. What do you need an image for? Are you on the Earth or no?
So you have no imagination of how the flat Earth is in your head.
No, it's not
You're
a
just saying,
matter of
oh,
imagination. Holy cow, dude. What do you mean imagination of what the Earth is? It is the Earth. You're standing on it. It's not an idea or a picture. It's the Earth.
Okay.
Okay.
But
So you guys are on the Earth and it measures flat everywhere. The end.
Yeah.
Is
Good.
there? Is it
nice and?
Is there edge of the Earth?
I don't know. I have no idea.
Okay, I'm curious with what do you think? I'm not familiar with all your thoughts and what you're thinking about.
Well, I mean, it sounded like you were familiar. You were saying that we think that NASA puts out fake videos and pictures. It seemed like you knew kind of what we were all about, but I don't. So you're saying now you don't know what we're claiming. We're claiming that the Earth is measurably flat and experienced that way and measured that way by everybody in every practical sense. There is no point in which a globe ever comes into any equation when you're navigating or when using the Earth or building on it or any of that stuff.
But you're building on small surface. It's not curved surface.
Okay. Okay, so how much curvature should we be accounting for, and where would we find it? If you think it's just so minuscule, how much should we be looking for and accounting for all the time?
What are you building so large?
Bridges. I mean, there's pretty large construction projects that people aren't aware of out there. You know, you build a golf course.
Large, but you don't have a bridge from Europe to America.
Yeah, okay, yeah, fine. There's one in China that's like 100 miles long.
Okay, but
over the water, which is flat. You guys know that water is flat, right? Level on its surface.
Well, it's always zero it's zero.
Yeah,
level.
right. No slope of any kind, so it's always zero, always flat.
Yeah, I agree.
Yeah, okay. So if it's always flat, then what curve is there?
But it's flat in a way from the center of the Earth. It's flat.
Oh, center of the ball. Okay, so if it's a ball, then it would be curving. Okay, where's the curve at? Where can we find that?
Well, I mean, we already told you that when you're in a plane, you can see the curvature. When you're on large
Nobody's seen any Earth curve from a plane. You can't even. That's not even one of the globe claims that you can see it from an airplane. They're claiming you can't see it from the ISS, whatever that is. But now you're telling me that you can see it because I've been in planes. I've seen no Earth curve.
I mean, so you think that you said that what that IIS? What that?
The ISS, the International Space Station.
Okay, so
Can't see any curve from there apparently either. If I wouldn't know, I've never been to the ISS.
Guys, sorry to interrupt, but who's doing those scratching noises?
I am.
Okay. But so you're saying that what that space station is telling is a lie, if I understand you?
No, I didn't say that. I didn't say that. You're saying that. So you think that they're lying about the space station now?
No, I did not say that. I am.
Oh, okay.
Because you said that they said that, like you told here.
No curvature can be seen from the ISS. That's a claim made by basically anybody who understands the size of the ball and the distance that the ISS would have to be away from the ball. No curvature can be seen from a mathematical perspective, just purely mathematical.
So is there edge of the Earth?
I don't know. It is flat though.
But if it's
Take
flat,
a look at the picture I just sent.
It needs to be like maybe a table, and table has the edges.
Do you see the picture I just sent you?
Infinity.
In the chat? Because I see a curve.
Let's see here. What do we got?
No,
Yep,
just
that's a curve.
tell me
That's a
about
curve from the airplane of the window. That's
There
a
you
very
go.
much
Very
curve.
simple, right there.
Yep,
Let's
that
see.
is a
Why
very
can't-
much a curve, yeah.
Okay, so can we measure that anywhere then?
I don't know.
Okay, well
And
let's measure the
the
Earth and see if
the
it's
first question. The first question was about the sun. If you can explain the picture I sent in here, why the sun, I can see only partial parts of the sun and not the entire sun if the Earth is flat. why the sunset is only partial.
Hold on a second. What does the sunset have to do with anything?
Well, if it is flat and sun is close to the earth, I should be able to see it, because if what I'm seeing here, earth is flat and sun
Whoa!
is like
I didn't make
inside
any
the earth,
claims
bro.
about the sun or its proximity to the earth.
Well,
Now, did I?
then somebody else did make that claim. Said that sun is closer to the earth. But regardless, where's the sun?
Other, do you know
Where is
how
the sun? It's
on the
usually in the
moon?
sky, except when it's not in the sky.
It's over there.
Okay. Over there.
Other,
Nice. Good job,
Yeah.
guys. Good job. It's pointless
Other,
to
do you
argue.
know on the moon shadow is curved, you know, and that shadow is from the earth.
Oh, it is the shadow of the earth. How would you prove that?
I mean, it's by the knowledge that we know from the science.
What science?
It,
Tell me
you
what
know,
science is involved in figuring out whether or not the sun or the moon or the earth being in between them. What would that be? How would that be related to science in any way?
science
What
knows that
hypothesis could you offer me? What is the cause and the effect?
because the earth is a globe and sun is
Well, you're just
sun is
saying that. If it's a
going here.
globe, it has a size. What is the size of the globe, and how can we measure that?
I'm sorry, but I don't know those stuff honestly. You know those facts.
Okay, so all you actually know is what you were told, but you never actually got any information to prove what you were told.
Yeah, but you know this. I'm all again referencing the airplane. When you go north, I mean when you go east, you come from west, and it doesn't quite well land with me to you going in circles like your
Circumnavigation, so you're telling me you can't have a circle on a flat surface?
I think that why are you going in circles actually? Why don't you go just straight if Earth is flat?
Well, according to the coordinate reference system, no matter which one, flat or globe, east and west are circles around north. So that doesn't prove anything.
But if it's a flat Earth, Earth is stretched. You know, if
It's
you
stretched, how
stretch,
much?
when you stretch a globe on a flat surface, it's kind of disoriented. It's kind of distorted. I'm sorry.
Well, you may not
Those
know this,
coordinates.
but the globe itself is already distorted. That polar, they call it a polar coordinate system.
Polar coordinates, yes.
That's already
When you,
distorted. So the globe that you have in your classroom, those already are distorted. Did you know that?
yeah, but you cannot do the same mathematics in the different coordinate systems. You have to actually.
Yeah, I know there's a different scale for each coordinate system.
Yeah, there's some adaptation.
Yeah.
You know, there's spiral, as much as I know, spiral coordinate system and things like that.
Yeah, there's about 200 different map projections of the Earth. So which
Yeah.
one do you think is the right one?
Based on what situation you are. If you're on a flat map, you use one thing. If you're on globe.
No, I'm asking you which one is the correct one. Which is the actual representation of the Earth? Which one is correct?
If the Earth is a globe, you know. I mean,
if the Earth is a globe, that's the one that's correct. So the polar coordinate system, the one that's on your teacher's desk, that's the correct one, the one with all the distortions?
How do I say it? How do you, I mean, I would like to see a picture of how you imagine it.
I know you've been trained that way. You think that reality is just in pictures. Like you almost can't even really look at reality. You would rather look at the picture of reality and go with the picture. It's a real problem.
I don't think it's a problem. It's another perspective from which we're looking at.
So what's the better perspective, the actual reality or the conceptualizations or the reifications of reality? Which one is more accurate?
If you have a wall in front of you and you're sitting in one point, you cannot see what's behind that wall. Changing perspective is just seeing what's behind that wall. It's the same as using the pictures. It's
Well,
another way
if you
of
don't hold on, bro.
intelligence.
So you're saying there's a brick wall. Okay. So there's a brick wall and you can't see behind it. So you think that you can just make up, like you can just draw a picture even though you haven't looked on the other side of it? And now the concept or whatever that you think is behind the wall is probably true or possibly true?
Uh, I mean, like, things that you're only.
Why don't you just look behind the wall? Then you know. Then you don't have to guess.
How much one? How much one?
The thing is that you're only.
Only your
ايش دك
You're, you're thinking your thinking is based on what you see.
No, it's based on what can be observed and tested. Now, seeing it is part of that. You think apparently that if somebody just creates a concept, even though they can't see it, it's better.
I don't see a problem with it because.
Okay, so you just make stuff up. So you don't see a problem with making stuff up.
I'm not why it's making stuff up. It's. So you don't have any picture to provide me how you.
No, do you have any pictures that you can provide me of the Earth that are accurate?
I can give you a 2D picture of Earth that's
Okay.
used in geography classes. It's, I'm not sure how they call it, but it's stretched. It's a globe stretched, so it fits.
Yeah, probably a Mercator projection. Right. So that's supposed to be the Earth. And that's how the Earth really looks, or no?
No, as I said, it's.
No. Okay. So if it's not how the Earth really looks, you can't provide me with any kind of image or idea of what the Earth actually looks like either.
I mean, I can give you a picture of a globe.
Okay, and that's a polar coordinate system. So that's still not reality. So you don't have a representation or an actual one-to-one
Define me that
model of the globe. Is that right?
That means it's not reality.
Why does that mean it's not reality? Because it's in the name. It's called a projection, a reification.
I mean, so polar coordinates are not real.
Obviously not. It's a concept.
Yeah, it's a concept of representing dots in space.
Dots. What do you mean dots in space? Dots in 3D space.
Yeah, coordinates.
Okay. Coordinates in 3D space. But it's not the actual, it's not really accurate, is it? Because it's a projection. It's not what reality looks like.
It's 3D projection.
It's a 3D projection of what reality is supposed to look like, but it's not reality because it's a projection. So it's not actually what reality looks like.
But, think that I believe that it's a globe, and my thoughts are all around that it's a globe.
So why do you want to believe that it's a globe so badly, even though it doesn't have any features that would be consistent with a globe? The first one would be curvature.
I would like for you to elaborate me planes going in circles.
Why? What would that help? We already talked about this. You can have a circle on a flat surface. You can have a circle on a curved surface. That doesn't prove anything. I would like you to show me curvature of the Earth in reality. A measurement of it would be great. Between 2 points that are very far apart, a measure of drop over distance that is consistent with the claimed size of the globe that you believe that you live on.
I mean, I can find you something probably on the internet, and
Terrific.
I can provide you something, some of those information.
Terrific. Find me who measured the Earth to be curved and how they did it, and we'll see what they did.
Okay, so I give you, and let's say that I gave you that. What
No, I
you're
know
going
you
to
won't.
say?
That's the thing. I know that you won't. That's my favorite part because I'm already asking you, and you're not going to get it because you know it doesn't exist. The best you probably will have is some Greek pervert from about, I don't know, 200-300 BC that we don't have any primary source documentation for. And apparently he measured some shadows after pre-assuming that the Earth was curved and that sunlight rays are parallel. And there's a bigger problem with that because rays are just concepts as well.
Yeah, but let's say that NASA did.
Well, NASA has
The
no Earth
measurement.
curve measurements. Believe me, we've checked. But if you want to check, you go ahead.
What organization is valid to you?
I didn't say it wasn't valid. I just know they don't have it. We've already looked. Dude, do you think that we haven't looked everywhere for someone to have measured Earth curve? Everywhere.
I think that I know from geography classes that there was some measurements about the light. Pointing light straight, and if it doesn't, it should go straight. Something like that.
Like a laser?
Yeah. Laser.
Yeah,
Light
we've got laser
laser.
tests. The laser test that we use, 20, 30, 40 kilometers over large bodies of water, there's no deviation from the laser, which is essentially a straight edge, and the Earth. There's no deviation. So those measure the Earth flat when we should have hundreds of feet of vertical drop.
Okay, so you did that by yourself? I mean, can you
No, I didn't do it. I
tell
just
me?
know that people have. Do you want the data? Do you want the PDF and the videos? Do you want all that?
It's okay. I can. It's okay. You don't need to provide me that.
Okay.
So basically, you flat earthers, you actually think only about the measurement.
Yeah, what
Only
else
about
is there?
and how you perceive it.
No,
from
not
the Earth.
perceive. The measurement is the measurement. I don't get to interpret the measurement. The laser hits the target on the other side of the lake at 40 kilometers. That's the observation.
And you're not saying that you have edges and things like that. You don't know just.
I have no idea. If there was an edge, which way do you think I should go to find it?
Anyway, I think.
Anyway, okay, so if I went straight north, I would find an edge.
If Earth is flat, maybe there is some edges.
Yeah, maybe. I'm not ruling that possibility out. I just don't know where to find an edge, if there was an edge. I also don't know what you mean by edge. Are you talking just by like a limit or something that you could just run and jump off of, like a cliff?
It's pretty much the same. Is it a limit or a cliff? It's a limit.
Well, if when your front door is open,
hello everyone.
Do you you step out onto your front porch, or when the door is closed, do you not step out onto your front porch? Do you run into
Excuse
the
me,
door?
can you hear me?
It's edge.
Yeah, we can hear you just fine.
It's edge or a limit. You define it how you want to. Where is it?
Okay, I'm asking you because you said edge. I'm asking what context you're using the word edge.
Define it as you want. End of the earth.
You
A
brought it up.
line.
Okay, a limit. Okay. Yeah, I think there's a limit to the earth.
Okay. Where is it? Why?
I have no idea. Where would I go to look for it?
So it's kind of a proof that there is no edge because.
So you're saying, so this is an argument from silence fallacy or an argument from ignorance. Because I don't know, or because you don't know, somehow we already revert back to the other
let's
possibility
say
that it has
you
to be a
go,
ball.
You go one direction. Okay, you choose one direction. Which way to go? I don't know. You choose it. And you go straight.
Okay, east.
And you go
okay,
straight.
east.
You should
Yeah.
probably go find that edge or limit or how you define it.
Okay. And that will prove what? Now it'll be a second claim. So the earth is already flat. You agree with that. But now we'll
Okay.
prove that there's an edge. Okay. Terrific. The earth is still flat. The globe idea has already been crushed.
Okay, it's flat. You go straight. Where you end? Where you end up by going straight?
I don't know. I don't know. And it's weird because I don't think anybody's really actually done this. You should give it a shot.
I mean, people've been to every part of the earth is explored.
Oh, really? Well, that's a very interesting claim. So you have
Yeah.
knowledge that mankind has seen every inch of the known earth.
Yeah, because
Okay. How are you going to prove that one?
So only thinking about the proofs. So for you, Earth is flat.
Yeah,
unless-
obviously, dude. We're having a discussion about reality. Proof is pretty helpful. Instead of us just making stuff up. Like, if do you want me just to give you some dumb idea like the edge of the earth is as far north as you can go, and is that going to satisfy you, or is that going to be dumb on my part to make some kind of baseless claim? I don't make claims like that.
I mean,
You, however, have made a claim that you know that man has seen and explored every possible inch of the earth, and there's no way that you could prove that.
But there's no also evidence about edges and things like that.
I didn't make a claim about the edge, did I?
But that's kind of a point. If Earth is flat, there should be an edge. There should be something.
According to you, I'm just making the claim about the flatness. It's weird that you're so hung up on this whole edge thing. We're talking about flat. That's a surface description.
But it's
I make no
also
claims about
connected-
edges.
It's also connected with them. When you have a flat surface, you have a desk. It has some edges around. If those two
Okay, so
things
that's
are
a desk.
connected-
Now we're talking about the earth. Where are the earth edges that you think must exist?
I don't believe that there should be edges. I mean, but
Oh,
if
okay, so you're not making
your
any claims
theory-
about edges either. Great. So we don't know if earths have edges, but we do know that the surface of the earth is flat. I'm glad we're back on topic.
Wait a minute,
your
brothers.
claim-
Wait a minute. Hold on, bro. I gotta ask you a question. Do you not believe in the horizon? Do you not believe?
Who are you asking?
You. I'm asking. Do you believe in the horizon?
Horizon and like a thing that you see far away.
No, I mean the edge of the earth that blocks that edge. Horizon.
I'm sorry, maybe your internet, maybe mine is bad, but I didn't hear you. Can you repeat me, please?
Yeah, I just heard you say that you don't think the earth has an edge, so I was wondering if you think the earth has a horizon. Because in the globe conception, the horizon is the edge of the earth, blocking things in the distance.
No, horizon is a line that you see, how to describe it, between sky and the earth. That's horizon.
Okay, I would agree with you that it's not the edge. I agree.
Yeah. Where's this guy? I mean, to continue.
Okay, so if the horizon's not the edge of a, then where's your ball Earth in reality?
Can you repeat?
Yeah, if the horizon is not the blocking things in the distance, like the sun or ships, then where's the ball Earth in reality?
If the sun is not blocking, because I'm sorry, but you're not internet
Yeah,
something.
no worries. So what he says, if the horizon is not the edge of the earth that's blocking out boats and buildings, then the globe does not exist, right? Because as far as we understand, the horizon is supposed to be the edge of the ball.
But if you have curvature, you see some part before that edge
Yeah,
that we're talking about.
correct. There's a little bit. There's supposed to be, according to the map, there's supposed to be a little bit of land or sea that you can observe, and then the edge of the ball begins to block things out as they go farther off in the distance, or you move farther in the distance.
I mean,
But
if
you
you have
said that the
curvature,
horizon is just the apparent location where the sky meets the earth. It's just a line. So it's not the edge of the earth.
it's a visual line in a way when you're watching it. It's a horizon.
Right. So it's
No,
not the edge of a ball.
no. It's just
No, not at
a
all.
line.
Okay. Okay.
It's just a line
So
that
then there
you
is,
see, horizon.
right.
How to say it? It's not actual connecting sky and earth. It's just how
It's
you
just a
see
line.
it.
Right.
It's describing horizon. Look at the horizon.
So then if you
That's
show us a
clear.
photograph like the guy did earlier of a sun that apparently, or it looks like, the horizon is blocking out the bottom of the sun. In reality, it's not doing that because that's not the edge of a sphere Earth. Correct?
Horizon is blocking. I'm sorry.
Yeah, didn't you see the photo that the guy posted earlier with the sunset and part of the sun was missing?
Hey, bro, let me take a moment
Okay.
to agree with him. Hold on, brother. Let me take a moment to agree with him that the idea that the horizon blocks things in the distance is a silly idea. That's why you're stumbling at the mouth to comprehend it.
Yeah.
I'm seeing that picture. Okay. It's
Okay.
so you see a sun and it's shining, and I mean that doesn't prove that Earth is flat.
No, I didn't say that it was. It's supposed to be a proof that the Earth is curved because apparently that line that you said is not Earth curve, now that it's not Earth curve, it's not blocking out the sun. It's just an apparent phenomena. It's just something that we observe, but certainly not the Earth blocking out the sun, right?
I mean, yeah, Earth is blocking that.
Oh,
Sun.
so now the horizon is the edge of the Earth blocking out the sun in this photograph. So you changed your position?
No, because horizon is. Let me just Google exactly what horizon. Maybe my English is bad. Apparent intersection of the Earth and the sky as seen by an observer. It's by
Right.
an observer. You can
So it's
see
not the
it from
edge of the Earth.
you can see it from the everywhere. No, it's not edge. It's not edge, as I said.
Okay, so then it's not the edge of the Earth or the Earth itself blocking out the sun in that photograph.
Yes, it's blocking the sun because if there's a
Now
curvature,
it is.
if there's a
So
curvature,
you're
you
telling.
cannot see a whole sun. You can see just part of it.
I understand that. We can see part of the sun. So now you're saying that in this case, the horizon is the edge of the sphere Earth. So you changed your position back.
So let me ask you a question that you asked before. How do you define edge? What's the meaning of your edge?
So
when I say edge, I
according
think
to
about
the lore,
desk edge, for example.
right?
A cliff.
But if you have a sphere, right? If you have a sphere or even a circle, if you draw a line from the center of that circle out to the edge of the circle, right? The curved line, that would be the edge of the circle.
If I draw a line from me to that edge that we're talking about, to that horizon.
Uh-huh.
Yeah.
No, that's not what I'm talking about. I'm talking about essentially a radius. You have a circle or a sphere, those will have radiuses, right? A position or a point in the center of the circle or the sphere out to the edge of the circle or the sphere.
Okay.
Okay. So a ball has an edge. It's the outer curved surface, line, whatever you want to call it. Curved line,
okay.
curve. Yeah, okay. So that would be the edge of the sphere. You're saying that the horizon is not that edge, blocking out the boats and the buildings and the sun in the distance.
But I ask you, what's the edge for you? What's your edge?
Dude, why do you? So now you got caught in a pickle. So you're going to go back to asking me about what edge means. I'm defining it for the sphere or the globe. Do you agree with it or not?
Okay, so if you're telling that the edge, yeah, if I understood you well, that's the edge, yes, and it's
Okay,
blocking
the
the
edge
way
of the
of sun.
circle or the sphere.
Yeah.
So now
and
it
it's
is the
blocking.
edge. So the definition of horizon is no good when it says it's just the apparent location where the sky intersects with the sea or the ground.
Horizon is how do I say it? It's a way of describing. You can see it from everywhere. Wherever you look, you can go to that point, to that your edge, and look in the opposite direction, and that you'll still see a horizon.
Okay, great. So you see horizons wherever you go. And if you look off in the distance, that apparent location where the sky meets the earth or ground, you can look back and see the horizon in the other direction. That's your claim. Okay. Is that horizon, is it blocking out the sun? Is that the edge of the earth?
It's
Is that the
blocking
curvature or the sagitta? Some people say sagitta. Is that the tangent point that's blocking out the boats and the buildings from bottom up as they get farther and farther away?
Yeah.
Okay, great.
from seeing
So if
it.
that's the case, then that should happen at 1.22 times the square root of the observer's height in feet, because this is all math. We have an established size or a radius of the Earth, which is supposed to be 3,959 miles, and that dictates that every distance to horizon can be no more than 1.22 times the square root of the observer's height in feet. But there's a problem with that. When we test that, that's never the case. We can see well beyond where the globe geometry states that we should see a blockage of geometry, physical earth, water, dirt, I don't care what it is. It's supposed to start blocking stuff up from bottom up as it goes farther in the distance. And that just doesn't happen. We've tested it.
I mean,
So we just have to take your words for it and that you have tested it and that there is a problem.
No, absolutely not. No, you go out and test this for yourself. You see if I'm full of crap. Go out and
Alright,
take your
cool.
cameras and
So
your
right
P900s and
now,
your telescopes and go out to the ocean and see if the geometric location that is dictated by the radius is actually correct.
I think
right now, so you're just saying the Earth. Well, there is no proof that the curve exists. That's what you said, and you have tested it. Basically, you're
Yeah,
not claiming anything
there is
else. You're
none.
not claiming that Earth is flat or Earth is not flat. You're just saying I don't know. That this is not the
No, I'm
case.
saying that the Earth is measurably flat, and that's how it's always
Measurably
measured
flat.
every day.
So measurably flat according to what you measured.
No, I'm
But
according
there
to
could
what
be a
anybody
mistake.
ever measures. Excuse me.
There could
According
be
to
a
what
mistake.
anybody ever it's weird. I'm talking and then you decide to talk right over me. I'm saying according
go
to
ahead.
anybody ever that measures the surface of the earth for any purpose, they do not measure any curvature unless they're dealing with hills and mountains and valleys and stuff like that, right? But as a whole, the earth curve that's supposed to be consistent with the globe that you've been told about is nowhere to be found. It's essentially 8 inches per mile squared. No one has found that.
I don't know, but I think that if Earth is flat, it has edges, and you're telling me that you don't know if there are edges.
Yeah, I mean, you might want to take a minute and just breathe into like a paper sack or something because you're still hung up on this whole edge thing. I'm just talking about the flatness of the surface of the earth.
I don't know, bro. I'm really tired. So it was a nice talking to you. I love your questions. I love your observations. So maybe next time we'll talk more.
Yeah, come back anytime, dude. Nice talking to you.
Yeah,
Sleep
bye,
well.
bro.
Bye.
You guys cooked the shit out of that guy.
Well, he was pretty seasoned already, so it wasn't that hard.
Yeah,
that was awesome.
Isn't it funny that they can't even picture what they believe?
Yeah. I don't know if Coder's still in here. Coder, yeah, we're just pointing out that for any practical purposes and what we experience is of a flat and stationary earth everywhere. Welcome to any new people. There seems like there's quite a few. Zen, Z, people I don't recognize anyways. How you doing? Welcome. Leo. Leo's got his self deafened. Kim, hello. Got Coder. He's been on the mic a little bit. Ceiling Bulb, hello. And Abeke.
Hello, hello.
And
Do you
Mick.
hear me, guys?
Hello.
So the question I can't understand. The thing I can't understand. If you may explain it to me, like, you guys know that the star spins right in the North Pole. It's like
Yeah, there seems to be a
counterclockwise.
star rotation. Yeah.
Yeah.
Yeah, there's star
But
rotations
if you
in the
look at
heavens. Yeah.
if you look at it in Australia, for example, you will spin counterclockwise. Not
Well,
clock. In Australia, clockwise and in northwise counterclockwise. So how do
yep.
you guys explain it? I think it's
Well, we don't
pretty.
need to explain any of that, and I just want to help you out. So counterclockwise and clockwise those are relative directions. The stars always move for everybody on Earth, as far as I can tell, from east to west.
Yeah, but it's for mostly for the people who live in near to equator. For example,
No, for everyone,
for
everyone on
everyone,
the
yeah, but
Earth,
for everyone. But
everyone, they go
if you
from
look,
east to west.
if you are in the North Pole, you know, for example, in the north of the Russia or somewhere, if you look at the sky will the stars will spin counterclockwise. If you look
Okay,
at
let's for a moment let's just entertain this idea. You're talking about counterclockwise and clockwise directional rotations of the celestials. What does
Yeah.
that have to do with anything? Because we're not making any claims about the sky or what's going on up there. We're talking about the Earth.
Yeah, exactly. The thing I'm saying is, if the Earth is flat, why would stars would confuse us, right?
Well, I don't know. We use them for things like navigation, signs, seasons. They're actually quite helpful. They reset every year, right, and do the same pattern over and over and over again. So they're helpful for things like reference and navigation and stuff like that. So we're not too confused about them. They just do what they do.
Right. If I may step in to clarify, right? When it says who says east to west, that means east of the prime meridian to west of the prime meridian. That happens everywhere on Earth with all the stars, except for like Polaris. Well, even then, actually, even Polaris actually goes east to west of the prime meridian. Teeny tiny little microscopic circles. Yeah. So, do you know what I mean by the prime meridian?
I've never. Maybe I don't know I don't know it in English, you know. But can you explain it?
Yeah, the prime meridian is set by Greenwich Mean Time from Greenwich, England. Okay.
Can you type it? I'll search it.
There, 54 minutes past the hour, prime meridian. Stars go from east of the prime meridian to west of the prime meridian. That's in the sky. Happens in the north as well as the south, everywhere on Earth.
I mean, what does it have to do with the point that I just told you guys? Well, I think maybe I didn't clarify myself, you know. for me, it's clear evidence for that it's the Earth is not flat. You know
Well, how? How is
how?
that clear evidence that it's not flat? Just because the stars do circles in a certain way in the sky, what in the world does that have to do whether or not the Earth is curving or not?
Because if the Earth is spinning, right? If you place something,
But whoa, now you added in another variable. So now the Earth has to be spinning. Well, what's the evidence that the Earth is spinning? Because you just told me that the stars are rotating.
yeah, from perspective, because if you say that
Okay.
I'm standing still, I would look up the sky. I would say the stars are spinning, but in fact, it's actually the Earth is spinning. You know.
Okay.
Yeah.
So how would you prove that? Our obvious
So
experience, the thing that we actually experience is that the stars move. We don't experience any motion.
Yeah, they're standing still. But if you place some kind of uh, camera to how do I say it?
Yeah, time lapse camera. Yeah.
Yeah, exactly. You'll notice
Yep.
that they're
That they
actually
move.
moving. Yeah,
Right. So the Earth is not moving, the stars are.
yeah. Well, from perspective, you
Yeah.
can say that. Yeah.
Well, yeah, so our perspective and our experience is that the stars move. Now, the thing that would be hard for you to prove is that you ever experience any motion and can prove that the Earth itself is actually in motion unless there's an earthquake.
Yeah. Why would I experience some kind of motion?
Because you said that
We
the
are
Earth is moving.
well. For example, do you feel some kind of motion when you're in a train or I don't know, in a fast-moving car? Except
Yes.
if no, after acceleration. If
Well, the Earth is supposed to be a rotational or an angular path, right? A rotation. So that is an acceleration. It's a constant acceleration, always changing its direction. So it'd be like being in a car and going around a curve. So you would feel that constant acceleration. However, a car or a train is still not a good example because those are not like kinds. Earth is supposed to be an open system. What you're describing are essentially closed systems.
Yeah, I see what you mean. You mean centrifuge, or I don't know how to call it in English.
Yeah,
Centrifuga.
yeah, centrifugal force. That's what a lot of people will give a name to that. But it's an angular momentum or an angular rotation,
Right.
an angular path. So there you're going to feel the constant acceleration of continually changing your vector.
Okay, I see the point. But do you
Yeah.
have you ever heard of gravitational force of the sun?
Oh, I've definitely heard of it. The problem that I have is that I don't have any evidence for it.
I mean, every single planet of the on the Earth system, solar system, is spinning around the sun. How is it?
Well,
How is
that's a
it that
claim.
evidence? Yeah.
That's a claim. Now, how would you prove that?
I mean, we can't prove everything.
Oh, so if we can't prove it, why are we believing it?
I'm not believing it. I'm just we can just look up the sky and uh, uh, and see the how the Earth moving, how the stars spinning around, you know,
Mhm.
differently
Right. Now, have
on
you
the
ever witnessed?
each side.
Yeah, right. So have you ever, I'm just going to ask you this question. This is what you've been told. The Earth and all of those wandering stars that we call planets
Right.
are orbiting the sun. Have you ever seen a star at any time in your life orbit the sun?
Uh, Objectively, no, you can't see it without.
Right.
Sorry, what do you mean by saying have you ever seen?
Yeah, have you ever seen any of those wandering stars take a path around the sun?
I didn't say stars. I said planets that spinning
Yeah, the
around the
wandering
sun.
stars, that's what planet means. I think a lot of people don't realize that. The original meaning of the word planet or planetai means wanderer, and that means wandering star. But now we've changed it to those are big giant dirt balls and gas balls, and they orbit like the Earth because the Earth is a ball and it goes around the sun. But no one's ever observed this to occur, ever.
Sorry, I didn't get the point.
The point is that if you have these things called planets, which a
Right.
long time ago, probably about 500 years ago, they were called wandering stars. Now we call them planets. And we think about planets in such a way where we think that they are either big giant balls of gas or dirt or whatever, and that they are all part of the solar system, quote unquote, and that they take a path around the sun, but no one's actually ever observed that to happen. What they have seen is diagrams and animations of the solar system as a whole, which is purely conceptual, and they say it works like this, but no one's ever seen it that way.
Yeah, exactly. I don't know
Right.
how it works either.
Well, it's essentially just a lot of math. They use math and conceptualize or, turn what we see in the sky into an entirely different system than what we observe. It's called the heliocentric model or the solar system. But it's only done with math. It's not done with necessarily any kind of measurements. It's just a way of thinking about how it could possibly be, even though we don't observe it. And you have a whole bunch of other models or conceptions of how this could work. One of them is called a geocentric model, where the Earth is at the center and all the celestials have a cycle in relation to the Earth being at the center. Then we have what's called the celestial sphere, which is another conception of the sky. And because all of the math works out, any of them are plausible, or at least possible. But the problem is the math is not going to tell us, the concept is not going to tell us ultimately what's true. If we can just move the math around and make different, bodies the center, I imagine you could probably do it with the moon too. But you can just mathematically conceptualize the heavens and their relationship to the earth and make it whatever you want it to be. But how do you know which one is correct?
Correct one is the one that you can measure and prove that.
Excellent. I agree. And so the solar system and the heliocentric concept that we have today requires that the Earth have a certain size because everything is in a relationship to an Earth with a radius of 3959. But if the Earth isn't curving anywhere, well, that entire concept goes down the drain.
Hold on. Let me just search. What do you mean by curving? Is it rotating? Is it the same meaning?
No, I'm talking about curvature. So the Earth is supposed to be a ball, right?
Right.
Right. And one of the most defining features of a sphere or a ball or even an oblate spheroid is that it's curving everywhere. And so that curvature should be measurable. we've been given the details of that curvature and the curvature rate, which means that we can measure over the surface of the Earth to see where the curvature is and how much occurs, right? How much drop over distance. If you were to create a tangent point on the top, anywhere, is the top of the ball. So if you have the surface of the ball and you put a flat, big plane on it, like a big straight edge, then it should curve away from that straight edge at a certain rate. And so we've tested this. We've looked for this actual drop over distance from this tangent plane. We're just kind of trying to beg the question with the people who believe in the ball and say, okay, this is a tangent plane now. Now, from this tangent plane, how much drop is occurring over distance? And let's see if it matches up with the claim of something roughly 8 inches per mile squared. When we do that, there is no deviation. There is no drop from our little tangent point, which means that it's not a tangent point anymore. It's just another parallel plane along the surface of the Earth itself. So there is no Earth curve. There is no ball. And if there is no ball, then there is no heliocentric or, globe solar system type concept to worry about anymore. All of that is completely down the drain.
I'm sorry. I think my English is not that good in this kind of conversations. But I get that point that someone did work to prove. But can you just send me the you know
Sure. So we can get you some laser tests. I don't know if that would satisfy you, but most people really like lasers. They're really cool. They're used a lot in sci-fi movies. But they're also very handy to create an artificial straight edge or a light straight edge across the surface of the Earth. So
No, I was
if
saying
that
about
satisfies you,
the uh about the curvature thing you were saying. Is there a video or
yeah, just a second. We've got many of them. Hold on. I'll give you a good one.
Yeah, if there is an article or something, I would love to see it.
Let's see, laser tests.
I've noticed in our conversation that you sir said, if you can't prove it, how do you believe it? My question is, do you guys don't believe in gravitational things?
No,
in
I mean, not
gravitation?
me.
No?
No. Mostly because there is no scientific evidence for it. Whatever concept that they try to place along with this idea of gravity, this word gravity, requires a few things. Those few things, sadly, do not exist. One of them is the idea that one mass, which is undefined in physics for the most part, is going to attract another mass. But that's more of a claim than an explanation. So the testing that has been done to prove this is essentially, it's not scientific. There's no experiment. There's not even a hypothesis, because we would need to know how to create a scenario where you would get something that has a mass, whatever that is, and get it to attract something else.
But
The other
you guys
problem, the Einsteinian, the general relativity, well, that requires a space-time. Well, space and time are both concepts. You can't bend and warp concepts.
But there is a force that holds you on the ground, right? So they call it
Nope.
gravity.
I
That's it.
haven't noticed any force holding anything to the ground.
Okay.
What we do observe is that depending on the medium, objects within the medium will go up or down depending on the density relationship. So if the object is more dense than the medium that it's in, it will go down. If the object is less dense than the medium that it's in, it will go up. And then we have gas, and gas moves freely and randomly in all directions. So there's nothing holding the gas down.
I think there is something that holds gas down, but there are more things heavier than gas, you know. For example, if some materials have more of the neutrons, neutron. How do I call neutron?
Hello, guys.
Well, if you're saying that gas is being held down, why is it moving freely and randomly in all directions?
It is less denser than the other materials.
What other materials?
For example, iron. For example, I don't know.
Well, yeah, but the iron's not moving, right? So it's just laying on the floor. The gas is moving everywhere all the time. Up, down, left, right, diagonal, constantly.
No, like if gas expands until it freezes, then it can't ricochet back and create pressure. So it tells me that the fact we have gas pressure means we're contained before the gas reaches absolute zero and freezes.
Have you guys heard of this guy named Flat Earth Rico? Anybody?
No, like Uncle Rico.
Yeah. He actually kind of looks like him too. He's Filipino. Nevertheless. Yeah, he's on TikTok and he's got 157 viewers right now. And he's got Flat Earth Dave on the panel. He's got Tron. He's got a couple other people. I just figured if someone knew him or not. I've never seen him. Let's take a little listen in for a couple minutes.
Yeah, man, sounds good.
Also, because he was one of the first guy, 2014, 15, he made this big start, with 5 books at the same time and YouTube documentation and so on, and that's why I think he was one of the guys who started the whole hype. What do you think?
Eric Dubay, I believe as far as getting on a social media and bringing it back to light, Flat Earth has been around for a long time. Before the Flat Earth Society went bad, in my opinion, it was actually good going all the way back to the 1950s. But if we really want to get, that's one of the reasons why I got on TikTok, is to remind everybody that didn't know maybe that Flat Earth has been a thing. We can go back almost 200 years to Samuel Robotham in his book, Zetetic Astronomy. I wish every flat earther would get that book. I have it and read it. It's a little dry reading, but they didn't leave nothing to chance for what they had during their day. They were so incredibly smart. So we've been around for a long time. Eric Dubay mentioned all these books early on, all these books. And so I think he just kind of brought it into the social media realm, and which has been huge since. But we should go all the way back. Many people don't even know that flat Earth made it in the turn of the century, 1900s, made it to the floors of Cambridge University for debate, and we did very very well. So it's kind of been it was kind of suppressed, but now that we have social media and then it's just exploded. So anyway, that's my position on it.
The other ones?
Still suppressed.
And the information is still available.
Announcement also for the viewers. We are by 90k likes, so shortly before we break the 100k, and so make a short sprint. And also an important, the queen of all Globy trolls are here, so yeah, big applause for Tiffany PNV, the biggest queen of every Globe trolls. Thank you that you are here.
That's where no bottom
I
sun
remember
girl.
that you have kicked me so often from your lives when I bring evidences, and you see you lost, sorry sister, and yeah, why you don't make your own? We're making here a flat earth joint venture. Why you don't share every trolls from every countries in the world on
Edgar, you're connected
the flat earth lives? Okay, so why you don't make your own joint venture?
Anyways, that's a little listen to Flat Earth Rico and his crew talking up a storm.
What your aim is? I can't.
One of the guys German. I guess I get like German super chats. It's kind of funny. But yeah, that's just a what do we call it? A look into the universe of flat Earth from a different people. So yeah, cool.
Hey Neil, why don't you go on there and troll Flat Earth Dave?
I've requested. I'm currently in the panel trying to get up there, but
if you get it on, can you relay it onto this?
Oh, 100%. That's what I'm trying to do right now. I'm just my request. I don't think they're gonna let me get up, but if they do, they will.
You better have a straight sound system.
Oh no, we need more donations for that. No joke.
Yeah, get one like AI's.
I'll just mute my end the whole time. I don't know. We'll figure it out. But anyways,
I'm just saying it's not worth pouring in a bad way, you know.
Yeah, I think we got it under control.
You already got a reputation, so to speak.
Yeah, I know. But I think it's good when I go to other people's lives. I think that way there's no like a doubling. But when I do my own lives, I have to get a microphone. So I think we're good when I join other people's. Or sorry, not a microphone, headphones.
Wait a minute, you got headphones?
I don't. Well, they're somewhere. I don't know where they are. I haven't used headphones in like 15 years. I got a pair of gaming ones somewhere. I gotta dig through.
Didn't I send you money for headphones the other day on TikTok?
You did. I'm up to $1.13.
Yeah, so get on frickin' Temu or Alibaba and get yourself $1 pair of headphones.
Yeah, arriving in 3 weeks to 6 months.
So you've got enough money to buy really old BMXs, but not a set of headphones, right?
Hey. Now that I need them, I'll You know, maybe I'll go look in my shed. I have a feeling they're in this blue box, which all my electronics are in. And yeah. You know what? I'll be back. How about that? How about that?
Timbo, I finally got the electricity. Then I got to run the hard line ground. Then I can set up a little studio in the shed. I'm gonna run the Cat 6 cable across. I have my laptop in my side.
Are you going to do a Cavendish in there?
Yeah. Well, I'm either gonna end up doing Cavendish or they wrote those two. It's usually what happens. Start doing flat Earth shed. I got my eye on a 70, $300. Just slap that in there for my monitor.
It's like a sidecar. Like your weenus is a sidecar.
Dude, that still ain't healed yet. It's getting there though.
is your weenus shrinking?
Not the whole thing, just the tip. Dude, this is a family show.
Yeah, well, okay. They need to, family show listeners need to Google weenus. It's just flabby skin, bro. Flabby skin, you know. You know, in some faith traditions they cut it off, but in ours, you know, you don't know.
Dude, you are correct. It's flappy skin, busted, right? It gets swollen, and then it gets nice and. But you know what? It made me think of immediately. Kid, people tell you don't. This is what does elbows on the table have to do with anything?
Weenus pads.
That's right, dude. Well, your elbow's on the table too much, busting your elbow, and then you're in a lot of pain.
So, does that make you a weenus supremacist? Okay, leave that one alone.
Maybe it started as no weenuses on the table, and it just morphed into no elbows on the table.
I can support that. No weenus on the table. Yes.
Just a blanket. Anything that ends with enis shouldn't be on the table.
No luck. Sorry, guys.
Hey, isn't the plural for that weenie?
So yeah, Abdul, thank you for coming into the chat. So the topic is weenus supremacy.
Hi everyone. Okay, thanks. What does Winnie means?
I'm glad you asked. Yeah, so like a weenus is like extra skin. Weenus. So if you extend your arm so it's straight all the way out and you pinch your elbow, if you pinch your elbow skin, your weenus is your elbow skin that stretches down. It's like nice and flabby, you know? They call that a weenus. And some people have a condition. It's like elephantitis of the elbow, and their weenus stretches like a basketball.
Wow, good explanation. I understand. Thanks.
I love it. Yep. So we're bridging cultures and bridging language here in the English Hub. I got to say, like Neil with his expositions makes me want to get onto TikTok like yesterday, so I can start smacking those fools.
Well, do it.
Annie up, cap that fool. Annie up, flat smack that fool. Can't even say it. LMAO.
Dude, I got a I got a show I want to go. It's called,
Yeah.
but it's not actually a TikTok show, but I thought it was because how you started doing shorts, and then some of them are lives, but if you listen to the stream, but it looks just like a TikTok stream.
Oh, you watched that too with those kids making money and scamming all the little kids with the GIF things?
No. Flurfs scamming kids next on MC Tune.
Oh, okay. It's a totally different thing. Never mind.
Yeah.
Hey, listen, I'm thinking
made
of
some
changing the taxes for how fat your ex-girlfriends are. That's how much taxes. I'm gonna call it the X size tax.
I mean, paywall?
I just posted my dinner. I made some hamburger helper. Almost a half a pound of bacon. One and a
What did
half
you do to
pounds
that
of
poor
meat.
pan?
Are you,
Man,
are you going to
grease
eat
that
right out the pan?
bacon.
Let me guess. That's
I
a
basically
meal for one.
I cooked a bunch of pig weenus. I took the weenus off of pigs. I cut them up and I slapped them into that skillet.
Listen, brother. Peter already came out earlier today, so just we're here for you. Go ahead.
Okay, so I'll tone it down. I don't need to call him in.
I can't remember what he said though, but it's pretty funny.
He said he wants what is it? College males? I don't know, college intellectuals, something like that. I don't know.
Cream of some young guy.
Sounds tasty.
I gotta say, like, Wayne's World is a generational divide movie. And so is like Suburban Commando with Hulk Hogan. And the Babysitter's Club. No. Adventures in Babysitting. That was it. Adventures in Babysitting. Yeah.
My God, there's a lot of people here. God damn.
Yeah, kind of an awesome thing, isn't it? A bunch of people who know what the Earth is.
That's crazy. So many. Like, how can you? Let me count. 3, 5, 6,
I got a good prompt from somebody on TikTok. If you think this smokestack is spinning with the Earth's 1,000 miles per hour speed, you've been successfully indoctrinated. Ooh, that's pretty good.
Whoa, there's like 30 people here. Isn't that crazy? 30.
Yeah, man. Most popular room in the server. Oh my goodness.
That's crazy. Guys, the Earth is not flat. Come on, don't be stupid. It's global.
Oh no, you're spiraling already.
I'm joking. It's flat, guys. It's flat. Don't be stupid.
Sure,
Don't be
flat.
dumb.
Why do you think so? How come?
It's just is. It's just flat. Like it's just like I don't know how to scientifically explain it, but the dumbest person can
Try
tell
your best. Try to
there's
pretend
something
I'm like,
wrong.
the dumbest person in the room and try and explain it to me.
Uh-huh.
Yeah,
Okay.
just in like in layman's terms, yeah.
Okay, NASA is full of shit. That's number one. Like, I think the only organization that tells us about the space is NASA, and they're full of shit. So it's like that's the first thing to start question.
No, they're not full of. No, dude. They're
Don't
telling
defend
the
them.
truth.
Come on, you're flatty. You're flatty like me. Stop. Don't defend them. And second thing, I would say, like, don't you feel like the Google map is something wrong with it? Like the distance and stuff like that?
Dude, I
If you
totally
like,
get it. Like the Google map has more in common with toilet paper.
true. How was that? What was that? Who's this? Neil.
Because of the projection.
Millie.
What happened?
How was it? What do you mean what happened? Like I just explained the whole thing and you were like,
dude, I'm on TikTok. I TikTok
not even
brained
paying
out.
attention?
I wasn't.
Oh my
that
God.
I swear.
Yeah, me
I
too.
wasn't
Like
there.
TikTok got smarter people.
I literally explained all this like for you. You said like,
well, you did good. You did okay. I like it. It's like
you
you're
didn't
trying.
pay attention. You're lying. You didn't pay attention. You were doing something else.
I heard what you said a little bit. I
You
didn't
like
hear the very
NASA.
last thing.
Now you're like acting like NASA, like full of shit.
Maybe. But yeah, I don't know.
Okay,
I
I'm
like
gonna
that
stop
you
talking.
tried.
There's so many people here. Somebody's like probably like streaming this on YouTube, and tomorrow I'm gonna be on like.
Bro.
Oh no! Don't worry. We've had way dumber people.
Take a look at the top of the channel. We got 2 YouTube streams happening right now, same time.
Oh
Two,
my
not
god.
one, but two.
Yo.
Yeah, you're in 4K,
Am I
bro.
live?
Technically 8K.
You
Am
are
I
live.
really live?
You're live on YouTube, Rumble, X, Spotify. Yeah, man, Twitter.
I'm gonna be famous.
Go say hi to your
Hey.
friends and fans, and what do you want to shout out to them?
Hi,
got business?
friends. Hi, fans. Hi, everyone who's watching. Hope you guys realize it's flatty. It's not global.
Yeah, man,
Stop
tell
being
your mom
idiot.
the earth is flat.
Don't say that. My mom is
Yeah, why not?
resting.
Tell your mom. We all told our moms. Did you tell your mom?
He's resting in peace. He's not here.
Yeah, you can still tell her.
Shut the fuck up. Don't. Anyway, back to the stream.
Yeah, we need the soundboard for that one.
This is why I hate recording, because this is gonna be like, you have to like, it's hard to have like a panel of people because everybody's talking, and you can't control your own mic. If you're streaming and
Guess
people
what?
are
We
like
can.
watching, it's better like to be like, it's either like solo or like with a panel of people you trust. Like they're not gonna like say dumb shit like Dr. Udera just did. Like, you know what I mean?
I get it, but listen, man, everybody is listening to you.
Right. Right. A lot of pressure. That's a lot of pressure.
Yeah, man, share your world, share your truth. What's happening, man? What do you think about the earth?
It's global. I was lying the whole time, guys. This is global. Like, stop.
Yeah, no kidding. But why do you think that is? Why do you think we're wrong and you're right?
Because NASA's not a full of shit. This is true.
Why? Because they gave you Velcro shoes and Tang orange juice.
I love NASA, guys. I love NASA. You should all trust the science.
We asked you to sacrifice your weenus to science.
Yeah. Oh, wait. Did you say the Zionist?
No. Should you sacrifice your weenus to science? You know what your weenus is, right?
Oh,
Should you
science.
sacrifice that to
I
science?
thought you said.
Yeah, your weenus.
Yeah, yeah. I thought you said something else. Okay.
No, weenus.
Yeah.
Should you sacrifice your weenus to science?
Weenus. What is a weenus? I'm not native English, by the way. Like, what is a weenus?
Oh man, you should Google it. It's like the new hotness.
I'm not gonna Google anything from you, Tito.
No, it's fine, man. That's like
Just
totally
say what
rated
it
G.
is. Say what it
Serious
is.
weenus.
Just say it. A weenus.
Yeah,
Is it a
your
penis?
flat, your flabby skin.
You mean like the penis?
No, man, you're gross, man. No.
It's like the complete wrong direction.
Your
Like, it sounds like
flabby
a
skin.
penis or
Just
something.
flabby skin. Like, guess what? If you like pinch your elbow skin, you can stretch your elbow skin out. That's your weenus.
Weenus. Wow, I didn't know that. Okay.
Yeah, man. You want to sacrifice
Just
your
a new
weenus to
word.
science?
Sure. That's a weird
Oh, okay. Yeah, you're a cult
What
member
is
now.
this? What does it even mean? Like, what does that mean?
Yeah, you're part of the scientific covenant. The new covenant of science
okay.
requires you to
Praise
sacrifice
science.
your
Like, I
weenus.
trust.
NASA.
Maybe NASA is not as bad as you guys say. You know, maybe they have something going on. So
Oh, yeah,
ridiculous.
they're a weenus cultivating factory.
Can somebody take the mic? Take the mic, guys. I'm not gonna talk anymore. I'm high. Okay. Let me just.
You are. Guess what, dude? The police are coming. I call the police.
Sounds
They're
like
coming.
both of you
fuck.
are. Sounds like you guys
No
are
shit.
in the back room.
Shit, the police
Oh
is
my
here.
god. Yeah, make sure it's a female one. Female police. Thank you.
Bro, if you don't be careful, Peter's gonna hang out at.
Uh-oh. Uh-oh. All Globers are stoned.
Peter is in search. Peter is searching for his weenus.
True. True. That is the truth. How come there's like 30 people here and like no one is talking? Isn't that crazy? Like,
Because you're here,
what are you guys
dude. This
doing
is
here?
all about you right now. You are the
No,
star.
I don't want to be the star.
Yeah, you're the
I
star,
like to be
man.
in the
Welcome.
background.
Welcome to the channel. We've been waiting for you our entire life, man. Welcome.
Whoa. No, no, no. I want to be in the background. I'm gonna let someone else talk.
No, man, it's too late. It's too late. Like God chose you. God chose you to talk to us right now.
I
It's
don't
your
believe in
show.
God. I'm atheist. I'm done.
Yeah, well, that doesn't matter. Like you can be an atheist all you want. God chose you to be here right now for this channel.
Where can I see my stream?
If you click on either of the YouTube stream bots at the top, you can look at their YouTube links inside of the user information. So click on like the YouTube stuff. What's that, like a exclamation point YouTube and exclamation point 24/7? Click on those. You'll see our YouTube streams.
Yo, I'm actually live. Wow. That's invading
Bro, you're
of
more than
privacy.
alive.
Like, how am I supposed to be? Who told you to put me on live? You can't put. You have to ask people who come here. You have to tell them like, yo, you're online. You're live. That's a lot of pressure.
What, you got an
I can't have my
expectation of
picture on
privacy on
right
the
now.
internet? Are you crazy? Are you high?
I am high, but like this is like basic. Can't like stream people without them permission. Unless you're like
Yeah, you can.
you're making money off of us. Like what the fuck?
No, nobody's making money. Like these channels don't make
Yeah,
money.
you are.
So no.
You have
No, we're
3K
not.
followers. So like you're gonna like start like building followers and then viewers and then you get money off of me? The fuck?
Nobody,
That's
dude,
not.
No,
nobody
man,
makes
we
money
don't.
off.
Other people? You're supposed to ask people like, do you guys want to be live? Permission.
Dude, man, like if you could twerk for us or something, and then we could probably make some money, but that's not gonna happen, is it?
It has nothing to do with money, and it has nothing to do with fame.
That's what they all say. Everybody says that. Like, it's not for money, but it's actually like at the
Yeah,
end of the day, like
okay.
you guys want money, like stop.
It's more like if you go into a courtroom and you've got somebody keeping track of everything that's said. We have bots for that, so it's automatically recorded, so we can go back and discuss conversations as they were spoken, not as people remember them to be.
Okay. Well, somebody took the mic.
I kind of want to say that, yeah, we are making money off of you. Now go sue us so you can get disclosure. You can figure out exactly how much money we're making off of you.
كل حلسب عليك يامي
كل حاسبة
ها
كل
كل حلسب
yeah.
Welcome to 24/7 Flat Earth Discord. If you have any questions, feel free to ask. Don't be shy. If you have any questions, feel free to ask.
A tide breathes low where the edges blur. A voice of mist begins to stir. In the cradle of waves where the light bends thin, the currents carve paths where the stars begin. Each ripple a story, each crest a vow. We drift through the folds of the endless now. Rise, rise through the veil of tides, where the heart of the deep and the heavens collide. We share our anchors, we break the seam, awaken the pulse of a boundless stream. The shores we've known crumble under the swell, their truths dissolve where the silences dwell. A spiral of light threads the dark's embrace. We chase its arc through uncharted space. Rise, rise through the veil of tides, where the heart of the deep and the heavens collide. We share our anchors, we break the seam, awaken the pulse of a boundless stream. The water remembers what the stone forgets. Each drop a debt to the infinite's bets. Do we swim or sink or become the sea? The question burns where the soul runs free. In the churn of the deep we are forged anew. Our shadows dissolve and the dawns break through. No map, no chain, no fear to bind. We are the tide, the spark, the mind. The surge ignites, the heavens roar. We carve the path where none soared before. The tide recedes, yet its song remains. A whisper of light through the heart's soft veins. We stand transformed where the currents meet. The stars are roots, the sky our feet. Through the veil we glide, no end in sight. Born of the tide we become the light.
Como, velho? Isso? Mentiroso, mano. Io lo vedo.
Hi.
Time to duel.
I built a kingdom made of ink to quiet down the noise so I didn't have to think. I drew a line to stop the tide. I built a wall to stay inside. Every mountain was just a shape. Every exit was just an escape. I thought I held the world in a frame, but the wild wind doesn't know my name. The colors bleed, the edges fray, the perfect picture falls away. Tear the paper, touch the stone. We walk a world we cannot own. The map is not the land we see. It's just a cage for you and me. So let it break and let it rain. Let the wild world break the chain. Yeah, the map is not the land. It's just dust inside my hands. Path the paper showed, I found a river where the road ran out. The compass spins, the needle lies. There's a fire here that never dies. We chase the truth in black and white, but lose the colors in the night. The grid is gone, the ground is deep. I'm waking up from a paper sleep. The colors bleed, the edges fray, the perfect picture falls away. Tear the paper, touch the stone. We walk a world we cannot own. The map is not the land we see. It's just a cage for you and me. So let it break and let it rain. Let the wild world break the chain. Yeah, the map is not the land. It's just dust inside my head. Lines on a page, iron and rust. Whatever we build turns into dust. You can't draw the heat, you can't draw the cold, you can't draw the hunger, you can't draw the soul. So let it break and let it rain. Let the wild world break the chain. I feel the earth, I take my stand. Because the map is not the fold it up, put it away. The ink is washing out into the gray. Into the gray.
Yo, what's up, guys?
What the fuck is going on? Does anyone here can speak or what?
Yeah, what's up, dude?
Hello, how you doing?
Good, how are you?
What?
I'm doing well. How are you doing?
I'm great. I'm grateful. Thank God.
Good. So what brings you into the room today?
I can't hear you.
What brings you into the room today?
Just chilling my time, wasting my time, you know. And why there's a lot of people here? Don't any or no.
Well, we just like to talk about and listen about the Earth, specifically how
Earth?
flat it is.
Yeah, all of these it's radical things. It doesn't matter if you are living in the Earth, so it doesn't matter.
Well, I mean, yeah, we're not really in, but yeah,
It's kind of
it's true.
has a circle shape. It's not circle or it's not flat. It's kind of have the circle or the egg shape.
Sure, how do you know that?
Yeah. So can you speak other languages besides English?
A few. But you said that the Earth was an egg shape. How do you know that?
Mm, I think from the instruments they went to the space and has a lot of photographies of the Earth. So yeah.
Okay, so they told you it was an egg. They showed you a picture, and you believe it. Did you ever
It doesn't
go
matter.
outside to go
It
check?
doesn't matter to me. It doesn't matter, you know, because I'm living in the earth, and if I did, so it's gone. You know, everything will gone. So it doesn't matter.
Oh, I mean, well, you're on the Earth. I
It will
mean, it
not.
does matter if you
It will
care
not.
about truth.
Yeah, but it will not. It will not change anything if you know the truth. You know.
You don't think so?
I
I mean, I
think
could give you
it's
an
my
example.
opinion.
Yeah, okay, so
You take,
yeah,
you
so
taking an
we're
example
just
from
talking
me.
about truth. We could talk about just knowing something's not going to change something, right? So we'll see. We could say
Yeah,
that you have a girlfriend,
yeah.
and every single time that she's been going out to work, instead of actually going to work, she's been going to her other boyfriend's house. and having fun with him. You know, keep it
Yeah,
PG-13. Okay.
that is another
And then
thing
you
between
well, then you come
rather
home
than
and then
Earth.
you find out, and then yeah, she tells you, and you're like, okay, cool. Thanks for telling me. Appreciate it. Like the truth doesn't matter to you. Like you don't care if you find out, or
The truth,
would you
the
rather
truth in
have her lie
your
to you?
personal, the truth. Listen to me. The truth in your personal activities or personal things, it matter. But in the
Well, yeah, that's
like in
matter.
the
We
earth,
live on the earth. We're gonna live here. We're here when we're
yeah,
born, and we're gonna be here till we die. I would
yeah.
argue that
Okay,
the
if you
earth
don't,
is more important than your girlfriend, because the earth will
okay,
be
if you
here
know,
always, before you were born and after your death. The earth is still
if you
going
know
to be
it's
here.
a flat earth, if you know if it's a flat, so what's gonna change?
Yes. You know the truth.
What's gonna change? What?
You know the truth. That's what's gonna
And after
change.
that,
You can tell people the truth. Like if I find out, for example, that your girlfriend is cheating on you, I now know the truth, and I could be like, "Hey, let me go tell you the truth."
yeah, that I said that
Yeah.
that is another thing.
Well, it's just another example of truth and knowing the truth. See, now, if you want to do something with that information,
They
you're
don't
more
need
than
what?
welcome
They
to,
don't need what?
right? If you don't want to, then you don't have to. You can still stay with her if you want to, right? You don't have to leave her for cheating on you. You can still stay
I
with her.
know
Yeah.
it's
So
not
just
equal.
knowing the truth
These
doesn't
topics not
change
equal.
anything.
Truth,
Truth?
the truth change the topics or change the subjects because it depends on the real subject. Like if you're talking about the girlfriends and all these things, so the truth matter here. But I told you like
Well,
if
yeah, the
you
earth
know
matters still.
you know
It's the truth.
the flat Earth, if it's the truth. So what's gonna happen?
Even in your favorite restaurant, you find out that they've been spitting in all their food, right? You can still choose to keep eating there if you want to, even if you know the truth, right?
Uh-huh.
You can know the truth that these people keep spitting in the food. Once you know that information, you don't have to do anything. You can just keep going back, or you don't even have to go back, or you can tell people.
Yeah,
You don't even have to tell anybody.
you keep distracting the topics because I told you this is
I'm not.
like
Okay,
another
even if
thing.
it's, let's say it's a restaurant that you don't even go to,
Okay.
right? You find out the truth that these people have been spitting in their food. Are you gonna
Okay,
tell people
this is
about it?
that is
Or are you
that
just gonna
yeah.
ignore it?
No, I'm gonna tell
What
people
are you gonna
about it,
do?
but this is
Okay, this is
I'm
what
gonna
I'm
tell
saying. This is what we're doing here. We just found
yeah,
something
but you
out
will
and we just want to tell people about it. That's it.
I know, but you will not be able to do anything if the Earth is gonna be flat or egg shape or anything of that.
Well, it's just the truth. That's it. That's all it is. You don't
I
have to do
know.
anything with this information if you don't want to. I'll tell you right now, the earth is flat. You don't have to
Yeah,
do anything
it's
with that information.
I got you. I
You can
got you.
choose to stay and learn more about it if you want to tell other people about it. If you want to learn just for yourself, you're more than welcome to. If you want to stay and argue about it, you can.
Yeah, I got you. So what is your opinion on the Earth?
Well, it's not an opinion. The earth is flat. Even if I said the earth was spherical, the earth is still flat,
Mhm.
right? If I had an opinion on it, I could say that the earth is a
You
sphere, but my
you
opinion
should
would be
still what?
incorrect. An opinion?
Yeah, your opinion.
It's
And I
like
ask
my
you if
feelings, my
you should have.
thoughts.
Hmm.
Yeah, the earth is gonna be flat.
Flat.
Yeah, I know
So
it's flat.
why would you
It's measured flat
why would you say that?
because the ground, it's measured flat. The water, it's flat, measured flat.
Yeah, but if you go into the space, you will notice that it is a circle or has the egg shape.
That's not true. You can't go out there anyway. You know how we know
I
that those
think
things are fake?
I don't know, but I think if you watch the Earth from a higher place or something, I think you would notice like it has kind of circle shape.
Well, sure, it could be a circle, but circles are flat. They're two-dimensional.
So I asked you if you speak other languages beside English.
Yeah.
So what
I
these
speak
languages?
Spanish, a little Japanese. I can
Oh,
understand a little bit of
You only speak
Chinese. I can
Mandarin?
understand a little bit of. No, my family doesn't speak Mandarin. We speak a different
Cantonese?
dialect.
And
person.
No, it's called Chucho. It's not any major dialect. It's like one of the rural, like weird
damn,
ones on the
dude.
side. Yeah. Or it's called Hokkien. That's what you can call it also. Chucho or Hokkien. But I can also understand some Cambodian, very small amounts of Thai.
So let us say you are multilingual or something.
Okay.
Yeah. That's it.
Oh, okay. All right.
Yeah.
Yeah. I mean,
I'm
okay.
just curious about that because my major is languages and translation. So I'm asking people, you know.
Oh, fair enough.
Yeah.
You don't speak French, bro? Come on, man.
No, I don't want to speak French. I was never interested in French for some reason.
Bro, you don't speak Punjabi? Are you like, you know?
No, I know being an English sub and everything. I should know all these.
I speak a little Punjabi, unfortunately.
And good for you, dude.
That's definitely not good for me.
Yeah, anyway, just want to say real quick about the Earth and the pictures, real quick. How we know that those photos are fake? Just to check the authenticity of a photo, right? You can just check the contents of the photo, for one. So, for example, oh, you dipped. Okay. All right, never mind. We just really wanted to talk about language, so. Don't blame them, I guess. This topic can be. Actually, no, not really boring, actually. I guess for some people it could be. And shit, I'm in here every day. Almost anyway.
Gosh dang. I gotta do dishes. It's gonna be
Funny.
Oh. I gotta make dinner. And I gotta do dishes again. It's like a vicious cycle.
I'll just repeat this anyway in case there's any Globers listening on YouTube or something. So what you can do to check the authenticity of a photo, is you can check the contents. I'll use an example of my face. If I was to show somebody else a picture of my face and there's a giant mole above my left eye, you can actually validate and check the authenticity of this photo by checking the contents, which would be above my left eye, and see if there's a giant mole above my head or above my eye. Sorry. If it's not there, then I obviously doctored the photo somehow. Two, you can check the location of where the photo was taken. I'll show somebody a photo of inside a castle in Atlantis, or inside the halls of the gods, something crazy, Santa Claus's workshop or something. So we know it's fake, obviously. Anyway, if Glober wants to talk about it, let's listen on YouTube. You can always come in. We can talk to Neil about it. I gotta head out pretty soon. Anyway, I just did a Glober call, so if we get raided, you can handle them, Neil. You got this, brother.